The ultimate SAP EWM migration playbook, SAP ECC to SAP S for HANA. Over 1,000 production incidents.
Welcome to the most exhaustive SAP EWM migration series ever created. We are documenting over 1,000 real-world production incidents, architectural failures, and technical bottlenecks that occurred during an ECC to S/4HANA EWM Brownfield conversion. This series strips away the textbook theory and exposes the brutal, undocumented realities of the warehouse floor, the server room, and the steering committee. Because of the massive scale of this playbook, this masterclass will be released in continuous, phase-based installments.
Why over 1,000 migration incidents?
SAP EWM is one of the most complex applications in the SAP ecosystem because it sits at the intersection of enterprise software and physical warehouse operations. Every organization has unique warehouse layouts, automation technologies, business processes, integrations, master data, security models, and operational constraints. As organizations progress through the discover, explore, realize, deploy, and run phases, each of these areas introduces its own architectural decisions, implementation challenges, production issues, and governance risks.
The purpose of this 1,000-plus incidents library.
When combined, these variables create thousands of realistic migration scenarios. This library is designed to simplify that complexity by systematically covering real-world incidents across every SAP Activate phase, helping architects, consultants, and interview candidates prepare for the situations they are most likely to encounter in enterprise SAP EWM transformations. Because of the massive scale of this playbook, this masterclass will be released in continuous, phase-based installments.
The SAP Activate Lifecycle Roadmap.
Throughout this series, we will sequentially trace these failures across the entire enterprise lifecycle, discover and prepare, strategic alignment, landscape discovery, and technical prerequisite failures, explore, fit to standard blueprinting, architectural gaps, and physical process omissions, realize, custom code compilation errors, integration deadlocks, and testing paralysis, deploy, go-live cutover failures, data migration corruption, and executive war room chaos. Run hypercare and BAU, post-go-live stabilization, critical support incidents, and long-term optimization traps. Let's dive into Part 1 covering Discover Phase incidents.
Part 1, the complete Discover phase.
In this first installment, we begin at ground zero, the Discover phase. A technical conversion cannot succeed if the strategic foundation is flawed. In this comprehensive video, we will cover all 10 critical categories of the Discover phase, walking through 49 mission-critical incidents. Spanning strategy, landscape mapping, master data, custom code, automation, infrastructure, analytics, and security. We will explore the early governance and architectural failures that quietly destroy project budgets before the blueprint even begins. Let's dive into Discover Phase Overview before deep diving into incidents. SAP EWM, SAP ECC to SAP S for HANA Migration Discover Phase Overview.
Discover Phase Overview. Understanding where migration failures begin.
The Discover phase is the foundation of an SAP ECC to SAP S for HANA transformation. During this stage, organizations assess their current ECC landscape, evaluate business processes, identify technical debt, analyze integrations, and decide on the overall migration strategy. Decisions made here influence every subsequent phase of the program. Most Discover phase incidents occur because teams underestimate the complexity of their existing environment. Hidden customizations, undocumented interfaces, poor data quality, obsolete automation add-ons, and overlooked business dependencies often remain invisible until later phases, where remediation becomes significantly more expensive and disruptive.
Business objectives of the Discover phase.
The Discover phase sets the strategic and financial baseline for the transformation. The primary business objectives include 1. Target operating model alignment, defining the S/4HANA EWM target operating model and deployment architecture based on physical warehouse complexity. 2. Financial baseline establishment, securing accurate project funding, hardware budgets, and realistic return on investment projections. 3. Operational risk mitigation, identifying and documenting high-level operational risks, particularly around automation latency and legacy integrations. 4. Program roadmap definition, establishing the overall migration timeline, specialist resource demands, and global template rollout strategy. 5. Business transformation vision, identify opportunities to simplify warehouse operations by adopting standard S/4HANA EWM capabilities, instead of replicating legacy custom processes.
Functional activities performed.
A successful S/4HANA EWM discover phase requires rigorous functional execution. 1. Assess legacy LEWM and decentralized EWM business processes. 2. Review inbound receiving, outbound fulfillment, and reverse logistics processes. 3. Analyze warehouse master data including materials, packaging specifications, handling units, batches, serial numbers, business partners, handling unit management, and handling unit numbering standards. 4. Assess physical storage type complexity, bin layouts, and capacity constraints. 5. Evaluate localized warehouse variations versus global template standardization. 6. Identify business-critical warehouse maintenance periods and peak shipping seasons. 7. Assess organizational change management, shift supervision, and user readiness. 8. Evaluate operational reporting, analytics, and visibility requirements. 9. Assess warehouse execution strategies including wave management, replenishment, labor-intensive processes, and value-added services.
Technical and architecture activities performed.
Technical teams must map the physical and systemic boundaries of the warehouse landscape. 1. Inventory custom developments, legacy user exits, enhancements, and Z programs. 2. Assess HANA database sizing and historical warehouse transaction data growth. 3. Analyze the interface landscape including MFS PLC controllers, mobile and external systems. 4. Review third-party automation add-ons and middleware components. 5. Assess data archiving status and warehouse task retention requirements. 6. Analyze physical wireless network coverage, RF hardware, and network latency. 7. Evaluate security models, single sign-on, and operational technology segmentation. 8. Execute the SAP Readiness check and audit S/4HANA simplification items. 9. Assess business continuity, disaster recovery, and high availability requirements.
Key architectural decisions during Discover.
Unlike standard modules, EWM requires fundamental architecture decisions during Discover that dictate the entire future landscape. 1. Embedded versus decentralized EWM, deciding whether the warehouse execution engine resides on the core ERP or a standalone server for automation isolation. 2. Basic versus advanced EWM, mapping physical warehouse processes against strict licensing tiers to prevent commercial budget overruns. 3. S/4HANA EWM versus stockroom management, evaluating if legacy warehouse operations can survive on deprecated limited functionality storage models. 4. Cloud versus local edge computing, balancing RISE with SAP cloud hosting strategies against the ultra-low latency requirements of physical material flow systems. 5. Greenfield versus system conversion versus selective data transition, selecting the migration strategy that best balances business transformation, technical risk, and implementation timeline.
Governance activities performed.
Strong project governance prevents catastrophic scope creep later in the program. Key governance activities during the Discover phase include: 1. Steering committee mobilization, establishing the core project steering committee and enterprise architecture review boards. 2. Template boundary definition, defining the exact boundary between the rigid global template and allowable local operational variations. 3. Accountability mapping, developing the RACE matrix for all functional, technical, and business operations teams. 4. Vendor certification governance, validating third-party software component certifications and external vendor compliance strategies. 5. Executive sign-off, securing formal executive approval on the final migration strategy, licensing models, and cloud hosting mandates.
Critical business stakeholders and their role.
EWM transformations fail when corporate teams design the system without the warehouse floor. Engaging these stakeholders early is mandatory. 1. Enterprise solution architects, Define target architecture principles, standardization boundaries, and technology decisions across the migration program. 2. Logistics operations directors. Define acceptable downtime windows, peak constraints, carrier SLAs, and business continuity requirements. 3. Shift supervisors and floor operators. Provide visibility into undocumented manual workarounds, shift handovers, and critical mobile usability pain points. 4. Warehouse automation engineers. Identify physical conveyor constraints, PLC hardware models, and legacy material flow system integration requirements. 5. Chief Information Security Officers. Define the delicate balance between strict operational technology cybersecurity and low-latency execution. 6. Master Data Governance Leads. Identify dependencies for business partner conversion, packaging specifications, and material master attributes.
Key integration touchpoints and why they matter.
A warehouse does not operate in isolation. The discover phase must map the following enterprise boundaries. 1. Manufacturing and production planning. Supports line-side staging and production material requests. Failures here immediately halt manufacturing lines. 2. Material flow systems and WCS. The critical cyber-physical boundary connecting EWM to automated conveyors, cranes, and robotics. 3. Transportation and global trade. Connects to transportation management for freight planning and global trade services for bonded customs compliance. 4. External carrier systems. Provides real-time shipping costs and routing guides. Overlooked carrier APIs block trucks from legally departing the yard. 5. Label printing spoolers. Thermal print servers and ZPL templates required to generate physical shipping manifests and barcode labels. 6. Mobile hardware and RF framework. The physical scanning hardware operators rely on to execute sub-second physical movements on the floor. 7. SAP ERP and Finance. Synchronizes inventory valuation, goods movements, purchasing, sales, and financial postings between warehouse execution and core enterprise processes.
Why incidents occur during this phase.
Migration failures frequently trace back to these root causes during the discover phase. 1. Migration strategy and deployment architecture decisions are made using incomplete volume and performance information. 2. Hidden custom logic, undocumented user exits, and tribal warehouse rules are completely overlooked. 3. Integration dependencies, especially local carrier interfaces and PLC connections, are not fully inventoried. 4. Data quality problems, particularly business partner duplicates and missing packaging specifications, remain undiscovered. 5. Business teams underestimate the impact of S/4HANA simplification items on legacy warehouse execution. 6. Executive stakeholders focus strictly on timelines while underestimating the physical operational disruption risks. 7. Legacy RF transaction usability and wireless network dead zones are assumed to work unchanged in S/4HANA.
Deliverables produced during discover.
A compliant discover phase must exit with these concrete architectural and project artifacts before starting the blueprint. 1. Current state assessment and target architecture blueprint. A comprehensive document defining the existing warehouse landscape, future deployment model, architecture boundaries, infrastructure strategy, and HANA sizing assumptions. 2. Business case and transformation roadmap. Financial justification, implementation roadmap, capability assessment, budget assumptions, and specialized EWM resource planning. 3. Enterprise integration and automation registry. A comprehensive catalog of all third-party systems, PLCs, legacy interfaces, and custom protocols. 4. Simplification and custom code remediation plan. A detailed strategy outlining technical debt retirement, Z program ownership, and standard adoption targets. 5. Organizational change management strategy. A governance blueprint mapping stakeholder readiness, physical UI transitions, and super user upskilling paths.
Discover phase, exit criteria.
The transformation program cannot safely proceed to the explore phase until these exit criteria are formally satisfied. 1. Readiness check verification. The SAP readiness check is successfully executed with all prerequisite simplification and collector notes applied. 2. Deployment strategy lock. The strategic deployment model, specifically embedded versus decentralized EWM, is formally approved by the architecture board. 3. Template governance approval. The global template governance charter and strict localization exception boundaries are defined and signed. 4. Current state assessment complete. Legacy interfaces, automation protocols, custom developments, infrastructure constraints, master data risks, and technical debt are fully documented and approved. 5. Executive financial approval. The Program Steering Committee formally approves the transformation budget, timeline, infrastructure costs, and resource plan. 6. Business scope baseline. Core business processes, warehouse scope, organizational boundaries, and migration objectives are formally agreed and approved for the Explore phase.
Key message of the Discover phase.
Most SAP S/4HANA migration failures are not created during technical conversion. They are created during discovery when organizations fail to fully understand their existing physical landscape, custom technical debt, unmapped integrations, and hidden operational dependencies. Every structural, hardware, or integration issue missed during the Discover phase becomes exponentially more expensive and disruptive to fix during Explore, Realize, Deploy, or Run.
Here are the 10 categories we will cover in this phase.
We will explore 49 critical Discover phase failures organized across these 10 strategic domains. Category 1, Strategy and Business Assessment. Category 2, Warehouse Process Discovery. Category 3, Warehouse Landscape Discovery. Category 4, Master Data and Archiving Assessment. Category 5, Custom Development Discovery. Category 6, Integration and Automation Discovery. Category 7, Technical Readiness and Platform Assessment. Category 8, Analytics and Reporting Discovery. Category 9, Governance and Project Readiness. Category 10, Identity, Security, and Access Management. Let's dive into Category 1.
Category 1, Strategy, Business Case, and Organizational Readiness.
In the Discover phase, Category 1 establishes the strategic, financial, and organizational foundation of the entire transformation program. This category analyzes the critical program-defining risks, spanning incorrect migration strategies, unvetted deployment models, underestimated multi-warehouse complexities, optimistic business cases, undocumented floor-level pain points, unmapped licensing models, ignored change readiness, unrealistic best practice expectations, and standard resourcing gaps that must be audited before project authorization.
Category 1, Strategy, Business Case, and Organizational Readiness Incidents 1 to 9.
During the Discover phase, a failure to establish strategic, commercial, and organizational readiness results in severe scoping and project governance failures. Here are the 9 incidents we are going to cover in this Category 1. Incident 1. Brownfield migration strategy selected even though the existing warehouse processes require a complete redesign. Incident 2. Embedded SAP EWM is chosen without evaluating whether decentralized EWM better fits the business landscape. Incident 3. Warehouse complexity assessment underestimates multi-warehouse operational dependencies across business units. Incident 4. Executive business case underestimates the cost and complexity of SAP EWM brownfield migration. Incident 5. Existing warehouse pain points are never properly documented during the discovery workshops. Incident 6. Licensing and EWM deployment risks. Assumption that current EWM licensing will seamlessly transfer to S/4HANA embedded or decentralized without additional costs. Incident 7. Change management and organizational readiness. Warehouse operator, supervisor, and logistics leadership change readiness is never assessed during discovery. Incident 8. Unrealistic expectations from the S/4HANA trial system. The business views standard SAP best practices in a discovery system and assumes their highly customized processes can easily adapt without massive change management. Incident 9. Project resourcing and niche skill sets. Budgeting generic SAP resources without realizing that complex labor management, yard logistics, or MFS require rare, niche EWM experts. Let's dive into Incident 1. Finally, let's start with Migration Incident 1.
Migration Incident 1. Brownfield migration strategy selected even though legacy complexity requires redesign.
A common strategic mistake during the discover phase is when the project team decides to pursue a brownfield system conversion approach for SAP S/4HANA, even though the legacy system's warehouse processes, custom logic, and operational complexity require fundamental business process redesign, warehouse layout optimization, and solution re-architecture. This decision is often driven by timeline pressure, perceived lower cost, or a desire to preserve historical data, but it leads to massive downstream issues in EWM design, configuration, and cutover. Business objective. Select the most appropriate SAP S/4HANA EWM migration strategy based on warehouse complexity, business objectives, customization level, integration landscape, and long-term operational goals.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this strategic transformation failure across these operational boundaries. 1. Complexity. Very high enterprise strategy failure. 2. Frequency. Common in large, highly customized legacy warehouses. 3. Business process. Enterprise warehouse transformation strategy. 4. Warehouse area. Entire warehouse operations. 5. EWM deployment type. Not yet decided or assumed embedded without proper evaluation. 6. Immediate business priority. High and strategic. 7. Primary ownership. Enterprise solution architect or program architect. 8. Business ownership. Program sponsor and transformation steering committee.
Migration incident analysis and root cause why this happens.
Selecting an incompatible migration path is rarely a sudden error. It is driven by several systemic factors. 1. Existing warehouse complexity is heavily underestimated during the initial discover assessment phase. 2. Legacy customizations, RF processes, automation, and exception handling are assumed to migrate without significant redesign. 3. Executive leadership prioritizes shorter timelines and lower perceived implementation costs over operational stability. 4. Warehouse process assessments are not sufficiently detailed for selecting the final migration strategy. 5. Experienced SAP EWM solution architects are engaged too late to influence the strategic direction. Key insight. Brownfield is a system conversion strategy, not a business process redesign strategy. When most warehouse processes require redesign, the migration approach should be questioned before realization begins.
Business, solution, and operational impact.
Proceeding with an incorrect strategy causes compounding failures down the road. 1. Financial impact. Inflated project costs during later phases, delayed go-live dates, and a compromised business case ROI. 2. Solution impact. Extensive customization replaces standard SAP EWM functionality, making the future solution complex and expensive to maintain. 3. Process impact. Warehouse process standardization opportunities are completely lost, increasing technical debt before go-live. 4. Operational KPIs. Long-term productivity, labor efficiency, inventory accuracy, and order fulfillment SLAs suffer due to compromised design. Selecting a migration strategy without objective assessment is a governance failure, not a technical failure. This is fundamentally a governance and architecture decision failure.
Governance and accountability.
To prevent or correct this failure, we must establish clear ownership boundaries across the program. 1. Decision owner. Enterprise solution architect, responsible for recommending the most appropriate transformation strategy based on technical and business assessment. 2. Business sponsor. Program sponsor and transformation steering committee approve the recommended migration strategy after reviewing business objectives, risks, timelines, and investment. 3. Supporting teams. EWM functional lead, enterprise architect, integration architect, automation specialists, and PMO. Selecting a migration strategy without objective assessment is a governance failure, not a technical failure. This is fundamentally a governance and architecture decision failure.
Real implementation tips and best practices.
Apply these 5 proven principles during the discover phase to align your strategy with reality. 1. Conduct a detailed warehouse process complexity assessment before choosing the migration strategy. 2. Involve experienced EWM solution architects in the discover phase, not just after the decision has been made. 3. Use a formal deployment decision matrix evaluating embedded versus decentralized and brownfield versus greenfield versus hybrid. 4. Run process fit workshops focused on exception handling, automation, and custom logic before committing to brownfield. 5. Define clear success criteria for choosing Brownfield, such as requiring less than 30% process redesign. Pro tip: if the projected Brownfield remediation effort starts approaching Greenfield complexity, the strategy must be formally reassessed, rather than forcing a legacy conversion to save temporary costs.
Follow-up 1. What are the key differences between Brownfield, Greenfield, and selective data transition approaches specifically for EWM?
Answer: Brownfield tries to convert the existing ECC system while keeping most custom code and processes. Greenfield rebuilds the solution from scratch using best practices. Selective data transition allows migrating selected data and processes. For EWM, Brownfield often leads to heavy customization, integration challenges, and higher long-term maintenance. Greenfield enables clean adoption of standard EWM functionality, better automation support, and simpler future upgrades, though it requires more initial effort and data migration.
Follow-up 2. How do you objectively assess whether a warehouse is suitable for Brownfield migration?
Answer: I conduct detailed workshops focusing on custom RF logic, automation interfaces MFS, PLC, ASRS, exception handling volume, multi-site variations, and degree of process standardization. If more than 30 to 40% of core warehouse processes need redesign, or if there is heavy custom development, I recommend considering Greenfield or hybrid. I also evaluate master data quality, integration complexity, and future scalability needs before giving a final recommendation.
Follow-up 3 curveball. What do you do when executive leadership has already publicly committed to Brownfield, but your assessment clearly shows it is the wrong choice?
Answer: I prepare a fact-based risk report with quantified impacts, estimated cost overruns, go-live delay risks, and post-go-live productivity loss. I frame the discussion around protecting the overall business case rather than opposing the decision. I propose a compromise such as Brownfield with selective process redesign for critical warehouses or a phased approach. If resistance is high, I suggest bringing in an independent external advisor for a second opinion to make the conversation more objective.
Governance takeaway for this migration incident 1.
The migration strategy should be based on objective warehouse assessment, not project assumptions. Incorrect strategic decisions made during discover are significantly more expensive to correct during realize or deploy.
Migration incident 2. Embedded EWM selected without evaluation.
During the discover phase, the project team selects embedded EWM as the deployment model without conducting a proper evaluation of whether decentralized EWM would better suit the business landscape, considering factors such as multiple ERP backends, warehouse transaction volume, automation maturity, infrastructure strategy, disaster recovery requirements, and future business expansion. Business objective: choose the optimal EWM deployment model, embedded versus decentralized, that best supports current and future warehouse operational needs, performance, integration, and scalability requirements.
Incident classification and relevant SAP note if applicable.
1. Complexity, high architectural decision failure. 2. Frequency, common during S/4HANA EWM migrations. 3. Business process, EWM deployment strategy. 4. Warehouse area, entire warehouse operations. 5. EWM deployment type, assumed embedded without proper evaluation. 6. Immediate business priority, high and strategic. 7. Primary ownership, EWM solution architect or enterprise architect. 8. Business ownership, logistics director and program sponsor.
Migration incident analysis and root cause why this happens.
Choosing a deployment model without systematic assessment is usually driven by these common factors. 1. An inaccurate assumption that embedded is the default and best choice in S/4HANA. 2. The lack of a structured, evidence-based deployment decision workshop in the discover phase. 3. Insufficient analysis of peak warehouse volume, automation complexity, multi-ERP landscapes, or real-time transaction performance requirements. 4. Intense program timeline pressure forcing teams to move quickly into the implementation phase. 5. Limited involvement of experienced, decentralized EWM solution architects early in the program lifecycle. 6. Business growth strategy, acquisitions, or future warehouse expansion plans are not considered during deployment architecture planning. Key insight: The default choice is rarely the best choice for highly complex environments. Never let timeline pressure dictate your core architecture.
Business, warehouse, and operational impact.
Bypassing the deployment assessment creates cascading bottlenecks across the entire warehouse landscape. 1. Business impact. Suboptimal performance and scalability in high-volume warehouses, leading to expensive and highly disruptive migration projects later. 2. Solution and warehouse impact. Severe integration challenges with multiple systems, performance bottlenecks during peak operations, and limited flexibility for future logistics expansion. 3. Operational KPIs. Throughput limitations, increased response times in RF and automation processes, and higher operational risk in large-scale environments. A wrong deployment model creates permanent architectural constraints that are extremely expensive to correct once the system is live.
Governance and accountability.
To secure the platform against long-term architectural constraints, we establish these boundaries of ownership. 1. Decision owner. EWM solution architect and enterprise architect responsible for presenting the formal data-backed deployment options. 2. Supporting teams. Basis team, integration team, and automation or MFS specialists. 3. Business ownership. Logistics leadership and the transformation steering committee, accountable for approving the final recommended deployment architecture. Pro tip: deployment model decisions must be based on a formal, multi-dimensional evaluation, not convenient assumptions.
Real implementation tips and best practices.
Apply these 4 industry-proven practices during the discover phase to guarantee an optimal deployment path. 1. Conduct a formal EWM deployment decision workshop during the discover phase. 2. Use a structured evaluation matrix covering peak transaction volume, automation complexity, the integration landscape, and future scalability. 3. Involve both embedded and decentralized EWM experts in the decision process to prevent bias. 4. Formally document the rationale, risks, and architectural trade-offs for the chosen deployment model. Pro tip: give serious consideration to decentralized EWM whenever the warehouse landscape includes multiple ERP systems, extensive automation, stringent performance isolation requirements, or long-term scalability needs. Validate the final decision through a formal architecture assessment, rather than assuming embedded EWM is sufficient.
Follow-up 1. What are the main differences between embedded and decentralized EWM in S/4HANA?
Answer: embedded EWM runs within the same S/4HANA system, offering tight integration and simpler master data management. Decentralized EWM runs on a separate system, providing better performance isolation, support for multiple ERP systems, and greater flexibility for very large or complex warehouse operations. The choice significantly impacts integration complexity, system sizing, and future scalability.
Follow-up 2. How do you decide between embedded and decentralized EWM for a client?
Answer: I evaluate warehouse transaction volume, number of connected ERP systems, complexity of automation such as MFS, PLC, ASRS, or AGV, performance requirements for RF transactions, and future growth plans. If the warehouse is very large, has heavy automation, or needs to connect to multiple ERPs, decentralized is often the better choice despite higher initial setup effort.
Follow-up 3 curveball. What do you do if the project has already decided on embedded EWM, but you believe decentralized would be significantly better?
Answer: I prepare a clear comparison document highlighting risks, performance implications, and long-term costs. I present both technical and business impacts to the steering committee. If the decision is locked, I recommend mitigation strategies such as careful sizing, optimized integration design, and a future migration path. The key is to document the risk formally.
Governance takeaway for this migration incident 2.
Selecting embedded or decentralized EWM is an enterprise architecture decision, not simply a system installation choice. The deployment model should support long-term business strategy, scalability, and operational resilience rather than only current implementation convenience.
Migration incident 3. Warehouse complexity underestimated.
During the discover phase, the project team significantly underestimates the operational dependencies, warehouse process variations, automation maturity, master data differences, and integration complexity across multiple warehouses and business units, assuming a relatively standard and straightforward warehouse landscape. Business objective: accurately assess the true complexity of the warehouse network to make informed decisions on migration strategy, timeline, resource allocation, and solution design.
Incident classification and relevant SAP, note if applicable.
1. Complexity, high discovery and assessment failure. 2. Frequency, very common in multi-site organizations. 3. Business process, warehouse landscape assessment. 4. Warehouse area, enterprise multi-warehouse landscape. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, enterprise solution architect. 8. Business ownership, logistics leadership and program sponsor.
Migration incident analysis and root cause why this happens.
Underestimating complex multi-site dependencies is driven by several critical operational gaps. 1. Superficial warehouse assessment focused only on high-level metrics like total volume and number of warehouses. 2. Lack of deep dive into cross-warehouse stock transfers, shared resources, and interdependencies. 3. Business units operate semi-independently with different processes, making true complexity hidden. 4. Time pressure during the discover phase leads to rushed, high-level assessments. 5. Insufficient involvement of operational warehouse managers and supervisors from all physical sites. 6. Master data ownership, quality, and standardization differences between warehouse sites are not evaluated during the initial assessment. Key insight: high-level metrics hide operational realities. An architecture team must assess the relationships between systems, not just their independent sizes.
Business, solution, and operational impact.
Ignoring these shared dependencies introduces massive risks across the entire project lifecycle. 1. Business impact: severe underestimation of project effort, timeline, and cost, leading to budget overruns and missed go-live dates. 2. Solution and project impact: major surprises during explore and realize when hidden dependencies surface, causing significant redesign. 3. Operational KPIs: increased project risk, delayed benefits realization, and potential operational disruption during cutover.
Governance and accountability.
To secure the platform against long-term architectural constraints, we establish these boundaries of ownership. 1. Decision owner: enterprise solution architect, accountable for the accuracy of the landscape complexity model. 2. Supporting teams: EWM functional leads from all major sites and the integration architect. 3. Business ownership: logistics director and multi-site warehouse operations leads.
Real implementation tips and best practices.
Apply these 4 industry-proven practices during the discover phase to guarantee an accurate assessment. 1. Conduct multi-site warehouse assessment workshops with operational leads from every major location. 2. Map all cross-warehouse processes, shared master data, and interdependencies early in the assessment. 3. Use a formal complexity scoring model for the warehouse network to categorize risk. 4. Validate findings with key warehouse supervisors and managers, not just headquarters executives.
Follow-up 1. Why is assessing multi-warehouse dependencies so critical in S/4HANA EWM projects?
Answer: many organizations run warehouses with different processes, storage strategies, automation levels, and integration points. Underestimating these dependencies leads to incorrect assumptions about standardization potential, data migration effort, and cutover complexity. It directly impacts whether embedded or decentralized EWM is more suitable.
Follow-up 2. How do you perform a proper multi-warehouse complexity assessment?
Answer: I organize workshops with operational leads from each warehouse, map all cross-warehouse processes, stock transfers, shared resources, reporting, document variations in master data, automation, and exception handling, and create a complexity heat map. This gives a realistic view before deciding on migration strategy or deployment model.
Follow-up 3. Curveball. What if the project timeline does not allow for detailed multi-warehouse assessment?
Answer: I push back and explain that skipping this step is one of the highest risk decisions in the project. I propose a fast-track assessment 2 to 3 weeks with key representatives. Accepting incomplete information early almost always leads to much larger problems and delays later in realize and deploy phases.
Governance takeaway for this migration incident 3.
Underestimating multi-warehouse operational dependencies during discover leads to flawed strategic decisions that become extremely expensive to correct in later phases.
Migration incident 4. Executive business case underestimates EWM complexity.
In the discover phase, the executive business case significantly underestimates the actual investment, implementation effort, business risk, and long-term operational complexity of migrating to SAP S/4HANA with EWM in a brownfield approach, leading to unrealistic expectations, budget shortfalls, and major scope compromises later in the project. Business objective: develop a realistic and accurate business case that properly reflects the true cost, timeline, risk, and complexity of the SAP S/4HANA EWM brownfield migration.
Incident classification and relevant SAP note if applicable.
1. Complexity, high strategic planning failure. 2. Frequency, very common in brownfield S/4HANA programs. 3. Business process, business case and investment approval. 4. Warehouse area, enterprise warehouse transformation. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high and strategic. 7. Primary ownership, program sponsor or enterprise architect. 8. Business ownership, executive leadership and steering committee.
Migration incident analysis and root cause why this happens.
This strategic planning failure stems from a combination of technical blind spots and governance omissions. 1. Technical complexity of EWM custom developments, automation interfaces, warehouse-specific processes is not deeply analyzed. 2. Legacy warehouse customizations and operational exceptions are assumed to migrate easily with minimal effort. 3. Over-reliance on high-level benchmarks and vendor estimates without sufficient EWM-specific due diligence. 4. Strong desire to secure project approval leads to optimistic cost and timeline projections. 5. Governance failure. Lack of independent review or challenge from experienced EWM architects before business case finalization. Key insight: a business case built on high-level averages rather than technical realities is not a plan. It is a budget disaster waiting to happen.
Business, solution, and operational impact.
Underestimating the program business case results in severe business, technical, and operational degradation. 1. Business impact. Significant budget overruns, scope reductions, delayed ROI, and potential project failure or cancellation. 2. Solution impact. Compromised solution quality, heavy customization debt, and suboptimal warehouse processes after go live. 3. Operational KPIs. Increased project risk, reduced transformation benefits, and long-term operational inefficiency. A wrong deployment model creates permanent architectural constraints that are extremely expensive to correct once the system is live.
Governance and accountability.
We align the lines of executive accountability to enforce business case integrity. 1. Primary ownership. Program sponsor and enterprise architect, jointly accountable for the business case feasibility. 2. Supporting teams. EWM solution architect, finance lead, and PMO. 3. Business ownership. Executive leadership and the steering committee, responsible for verifying technical diligence before funding.
Real implementation tips and best practices.
Implement these 4 strategic practices during the discover phase to secure your financial plan. 1. Include experienced EWM solution architects directly in the business case development workstream. 2. Perform a detailed complexity and effort assessment before finalizing financial allocations. 3. Use reference benchmarks from similar EWM brownfield projects, never generic S/4HANA ones. 4. Build explicit financial and schedule contingencies for warehouse-specific complexities such as automation integration, custom developments, RF redesign, and cutover risks.
Follow-up 1. Why is the business case for EWM brownfield migration frequently underestimated?
Answer: EWM has unique complexities, deep integration with automation, complex master data handling units, batches, packaging specs, custom RF logic, and warehouse-specific processes that are often not fully visible at a high level. Generic S/4HANA benchmarks do not capture these EWM realities, leading to optimistic estimates.
Follow-up 2. How do you build a more realistic business case for EWM migration?
Answer: I insist on a detailed warehouse complexity assessment early, including custom code volume, automation interfaces, multi-warehouse dependencies, and exception handling. I then use actual effort multipliers from previous EWM Brownfield projects rather than standard S/4HANA ratios. This frequently results in significantly higher effort than generic S/4HANA estimates because warehouse transformations involve additional automation, custom development, integration, and operational design activities.
Follow-up 3 curveball. What do you do when the executive team insists on keeping the business case numbers low despite your warnings?
Answer: I document the risks clearly in a formal risk register with quantified potential impacts on cost, timeline, and benefits. I present multiple scenarios: optimistic, realistic, pessimistic, and recommend governance approval gates. If they still proceed, I ensure the project plan includes clear contingency triggers for scope or timeline adjustment.
Governance takeaway for this migration incident 4.
A business case that underestimates EWM complexity is not just optimistic. It is a governance failure that sets the entire transformation program up for budget overruns and compromised outcomes.
Migration incident 5. Existing warehouse pain points are never properly documented during the discovery workshops.
During the discover phase, critical warehouse pain points, operational workarounds, recurring business complaints, manual activities and process bottlenecks, operational challenges, exceptions, and inefficiencies in the legacy system are never properly documented or deeply analyzed in the discovery workshops. Business objective: capture a complete and accurate picture of current warehouse pain points to ensure the future S/4HANA EWM solution delivers real operational improvements.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this discovery failure as follows. 1. Complexity: high discovery and assessment failure. 2. Frequency: very common. 3. Business process: warehouse pain point assessment. 4. Warehouse scope: entire warehouse operations. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise solution architect. 8. Business ownership: logistics leadership and program sponsor.
Migration incident analysis and root cause why this happens.
Failure to document existing pain points usually stems from the following root causes. 1. Discovery workshops are conducted at a high level and focus mainly on happy path processes. 2. Warehouse operational teams are not sufficiently involved or given enough time to share real challenges. 3. Workshop facilitators ask process-oriented questions but fail to investigate operational exceptions, workarounds, recurring complaints, and productivity losses experienced by warehouse users. 4. There is pressure to complete the discover phase quickly and move into project planning. 5. No structured template or checklist is used to systematically capture warehouse pain points.
Business, solution, and operational impact.
Undocumented pain points create significant downstream consequences. 1. Business impact: the future solution fails to solve real operational problems, weakening the business case. 2. Solution impact: many legacy issues are carried forward instead of being resolved in the new EWM design. 3. Operational impact: warehouse teams continue facing the same inefficiencies after go-live, reducing user adoption, productivity improvements, and overall confidence in the new EWM solution, and ROI.
Governance and accountability.
Clear ownership is essential to avoid this failure. 1. Decision owner: enterprise solution architect responsible for ensuring comprehensive pain point documentation. 2. Business sponsor: logistics leadership must provide operational experts and validate findings. 3. Supporting teams: warehouse supervisors, key users, process owners, and operations leads.
Real implementation tips and best practices.
Follow these practices during discover workshops. 1. Use a structured warehouse pain point template covering exceptions, workarounds, and inefficiencies. 2. Involve operational warehouse supervisors and floor leads, not just management. 3. Dedicate specific sessions to exception handling and daily operational challenges. 4. Document pain points with real examples and quantify their business impact where possible. 5. Validate documented pain points through warehouse walkthroughs and direct observation, instead of relying solely on workshop discussions.
Mandatory discovery deliverables.
A successful discovery workshop must produce concrete project deliverables to establish the baseline for the future design. 1. Current state process maps. Visual workflows of active warehouse processes across all major distribution centers. 2. Pain point register. Capturing documented operational bottlenecks, legacy system limitations, and process friction. 3. Exception log. A comprehensive catalog of standard process variation, edge cases, and physical execution errors. 4. Manual workaround register. Detailing non-standard operational bypasses, such as Excel sheets, duplicate scans, and handwritten logs. 5. Integration dependency register. Documenting all upstream and downstream systems, interfaces, automation equipment, and third-party applications that interact with warehouse operations. 6. Warehouse complexity assessment report. Summarizes warehouse process complexity, automation maturity, integration landscape, customization levels, operational risks, and overall transformation readiness. 7. Assumptions and constraints register. Cataloging baseline assumptions such as RF coverage and master data cleanliness that represent future design risks. 8. Improvement opportunities. Identifying business improvement opportunities through process simplification, standard SAP EWM capabilities, automation, and operational best practices. 9. Business priority matrix. Aligning operational stakeholders and steering committees on high-impact areas for process redesign. Key takeaway. These deliverables form the foundation for fit-to-standard workshops, solution architecture, configuration design, testing strategy, and ultimately the SAP EWM blueprint. Missing or incomplete discovery artifacts almost always result in solution redesign, project delays, and avoidable rework later in the implementation.
Follow-up 1. Why is proper documentation of warehouse pain points so critical in the discover phase?
Answer: because the entire transformation value proposition depends on solving real problems. If pain points are not documented, the future EWM solution may replicate legacy inefficiencies instead of eliminating them. This directly impacts user adoption, ROI, and whether the project is considered successful by the business.
Follow-up 2. How do you ensure pain points are thoroughly captured during discovery?
Answer: I use a standardized template, run dedicated workshops with actual warehouse operators and supervisors, and ask probing questions about exceptions, workarounds, and daily frustrations. I also request real examples and quantify impact time lost, cost, errors whenever possible.
Follow-up 3 curveball. What if business stakeholders say there are no major pain points?
Answer: I treat that as a red flag. I dig deeper with specific questions about exceptions, peak periods, manual workarounds, and complaints from floor staff. Almost every warehouse has hidden inefficiencies. If they still insist, I document the risk that the future solution may not deliver expected improvements.
Governance takeaway for this migration incident 5.
Undocumented warehouse pain points during discover lead to a solution that fails to deliver expected business value. True transformation starts with brutal honesty about the current state.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 6. Assumption that current EWM licensing will seamlessly transfer to S/4HANA embedded or decentralized without additional costs.
During the discover phase, the project team assumes that existing legacy SAP EWM licensing will seamlessly transfer to SAP S/4HANA embedded or decentralized without additional commercial assessment. SAP S/4HANA provides basic and advanced EWM capabilities, and organizations planning to use features such as wave management, value-added services, or material flow systems should evaluate whether advanced EWM licensing is required under their commercial agreement. Failure to perform this assessment early can lead to unexpected licensing costs and budget overruns later in the program. Business objective. Ensure accurate budgeting and risk assessment by properly evaluating S/4HANA EWM basic versus advanced licensing requirements early in the migration strategy.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this commercial and deployment risk as follows. 1. Complexity. Medium to high commercial and licensing risk. 2. Frequency. Common in S/4HANA EWM migration. 3. Business process. Licensing and commercial planning. 4. Warehouse scope, enterprise warehouse landscape. 5. EWM deployment type, assumed embedded without proper functional validation. 6. Immediate business priority, high. 7. Primary ownership, enterprise architect or commercial lead. 8. Business ownership, program sponsor and IT procurement team.
Migration incident analysis and root cause why this happens.
This commercial planning blind spot typically arises due to the following factors. 1. Lack of early engagement with SAP licensing experts, commercial account teams during the discover phase. 2. Assuming that existing SCM EWM licenses directly map to S/4HANA EWM runtime licenses. 3. Ignoring the critical functional boundary between S/4HANA basic EWM and advanced EWM features. 4. Procurement and contract teams are brought into the S/4HANA transformation program too late. 5. Over-reliance on high-level partner assurances without performing a granular EWM functional scope check. Key insight. S/4HANA includes basic EWM capabilities within the core entitlement, while advanced EWM capabilities require additional licensing depending on the customer's commercial agreement. Understanding which warehouse functions require advanced EWM is essential before finalizing the migration strategy.
Business, solution, and operational impact.
Unvalidated licensing assumptions introduce serious strategic risks later in the project. 1. Financial impact. Sudden, unbudgeted software license fees that can run into millions directly threatening the business case. 2. Project impact. Forced budget reallocations, timeline delays due to contract renegotiations or sudden scope reductions. 3. Solution and business impact. Pressure to adopt a compromised, standard-only functional design to avoid purchasing advanced EWM licenses, severely impacting operational throughput.
Governance and accountability.
We align the lines of commercial governance to secure the program budget early. 1. Decision owner, enterprise architect or commercial lead accountable for verifying the commercial footprint. 2. Business sponsor. Program sponsor must ensure commercial validation occurs before committing to a deployment model. 3. Supporting teams. SAP licensing expert, IT procurement, and EWM solution architect.
Real implementation tips and best practices.
Apply these 4 commercial principles during the discover phase to prevent contract surprises. 1. Engage SAP licensing experts and procurement teams early in the discover phase workshops. 2. Perform a detailed basic versus advanced functional mapping check against your legacy EWM features. 3. Document all licensing assumptions, exclusions, and cost impacts transparently in the initial business case. 4. Build financial contingencies for additional licenses, future warehouse expansion, increased transaction volumes, and possible scope changes identified during Explore. Pro tip: if your business requires advanced features like yard management, VAS, or MFS, do not compromise the solution designed to save on licenses. Budget for advanced EWM from day 1.
EWM, commercial readiness deliverables.
A rigorous discover phase must exit with these concrete commercial artifacts before project authorization. 1. Basic versus advanced functional map. A granular document matching legacy warehouse processes to S/4HANA EWM licensing tiers. 2. Functional licensing assessment. Maps every planned warehouse capability wave management, VAS, MFS, labor management, yard management, etc. against basic and advanced EWM licensing requirements. 3. EWM sizing and throughput forecast. Estimating average and peak delivery item volumes to project potential advanced EWM throughput fees. 4. Target licensing and commercial model. Documents the proposed SAP S/4HANA commercial structure, including the selected embedded or decentralized deployment model, basic versus advanced EWM licensing approach, key commercial assumptions, and expected contract scope. 5. Commercial risk and contingency log. A formal documented risk register outlining potential license adjustments and mitigation paths. Key takeaway: these commercial deliverables safeguard the project from sudden post-blueprint budget shocks, ensuring the business case matches long-term operational costs.
Follow-up 1. What are the main licensing differences between legacy EWM and S/4HANA EWM?
Answer: Legacy SCM EWM licensing is based on a distinct SCM server and processor model. In S/4HANA, EWM is split into basic and advanced tiers. S/4HANA Basic EWM is included in the ERP core license, but has strict functional limits. Typically, S/4HANA Additional Advanced EWM licenses are required according to the customer's commercial agreement. Moving from legacy to S/4HANA models frequently causes commercial surprises if advanced features are actively used.
Follow-up 2. When should the EWM licensing assessment happen in the project lifecycle?
Answer: It must begin in the discover phase, before selecting the migration strategy greenfield versus brownfield or deployment model, embedded versus decentralized. It should be formally updated during the explore phase as the detailed functional blueprint is finalized, and before signing the S/4HANA contract with SAP.
Follow-up 3 curveball. What do you do if the project is committed to embedded EWM, but you find they actively use advanced features like wave management?
Answer: I immediately escalate with a clear options paper. I outline the financial exposure of using advanced features under a basic license versus the functional impact of removing wave management from the physical warehouse floor. I recommend either upgrading the contract to advanced EWM, redesigning the processes to fit basic EWM standards, or negotiating a commercial compromise with SAP.
Governance takeaway for this migration incident 6.
Licensing assumptions made without expert validation are one of the most expensive mistakes in S/4HANA EWM migrations. Always validate licensing implications before finalizing strategy or deployment model.
Migration incident 7. Warehouse operator, supervisor, and logistics leadership change readiness is never assessed during discovery.
During the discover phase, the project team fails to assess the operational resistance, skill gaps, and change readiness of warehouse operators, shift supervisors, and logistics managers who are most impacted by the transition. EWM introduces a complete pivot in daily execution, shifting from legacy transactional manual processing to highly disciplined, system-guided workflows. Neglecting the human element during the discover phase results in severe operational bottlenecks immediately following go-live. Business objective: proactively identify organizational change risks, cultural barriers, and technical skill gaps to ensure high user adoption and minimize operational disruption.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this organizational change failure as follows. 1. Complexity: high organizational change and readiness failure. 2. Frequency: very common in large-scale warehouse migrations. 3. Business process, change management and organizational readiness. 4. Warehouse area, entire warehouse organizational structure. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, change management lead and OCM specialist. 8. Business ownership, logistics leadership and warehouse operations managers.
Migration incident analysis and root cause why this happens.
This critical readiness gap usually occurs due to the following strategic blind spots. 1. The change management team is engaged too late or treated as a low priority, soft skills activity. 2. Discover workshops focus heavily on system processes and technical architecture, completely ignoring the people impact. 3. An inaccurate assumption that standard training during the deploy phase will resolve all user resistance and skill gaps. 4. Warehouse floor staff, shift supervisors, and key operators are excluded from early assessment workshops. 5. Executive leadership incorrectly assumes organizational adoption will naturally follow technical implementation without structured change management governance.
Business, program, and operational impact.
Leaving user readiness unaddressed creates catastrophic risks across the entire project lifecycle. 1. Program impact: low user adoption extends hypercare, increases stabilization costs, delays realization of business benefits, and significantly raises the probability of post-go-live operational disruption. 2. Business impact: severe drops in warehouse productivity extended hypercare cycles, and a complete failure to realize projected business case ROI. 3. Operational impact. Massive inventory receipt and shipping backlogs, elevated scanning error rates, and high post-go-live support costs. 4. User impact. Warehouse operators bypass standard system-guided processes, reverting to manual workarounds and off-system spreadsheets due to interface frustration.
The S/4HANA EWM user experience adoption gap.
Organizations frequently modernize the warehouse user experience during S/4HANA migration, but the operational shift remains massive. 1. Process navigation shift. Even when ITS mobile and legacy RF framework interfaces remain in use on Zebra or Honeywell handheld devices, operators must adapt to entirely new EWM menu structures, validation rules, and transaction steps. 2. System-guided discipline. S/4HANA EWM relies heavily on system-directed warehouse task sequencing. Operators accustomed to manually choosing their next task face significant behavioral friction. 3. Exception handling friction. EWM requires highly structured system-guided exceptions. Operators used to manual workarounds struggle with EWM exception codes, slowing down shipping and staging operations. Key insight. Operators do not resist the concept of S/4HANA, they resist the loss of operational speed. If you do not plan for this process and execution transition during Discover, your day one throughput will drop severely.
Governance and accountability.
Clear ownership must be established early to manage the organizational change footprint. 1. Decision owner. Change management lead and OCM specialist, accountable for executing early readiness and change impact assessments. 2. Business sponsor. Logistics leadership, responsible for releasing warehouse floor operators to participate in assessment workshops. 3. Supporting teams. Training lead, warehouse operations managers, and HR specialists.
Real implementation tips and best practices.
Follow these concrete steps during the Discover phase to align your team for adoption. 1. Conduct structured warehouse change impact assessments focusing on physical movement and process execution changes. 2. Build detailed user persona profiles to track comfort with technology and training needs across shifts. 3. Involve actual warehouse supervisors and key operators directly in Discover workshops to gain early buy-in. 4. Establish a clear upskilling roadmap that treats training as a continuous process, not a one-time event.
Organizational readiness deliverables.
A compliant Discover phase must exit with these concrete change artifacts before starting the blueprint. 1. Organizational change impact matrix. Mapping every affected role, current process, future process, business impact, expected resistance level, and structured mitigation plan. 2. Warehouse change impact assessment. Documenting every physical warehouse process and transaction change from the legacy warehouse solution to SAP S/4HANA EWM. 3. EWM user persona matrix. Mapping all warehouse roles, current skill levels, comfort with technology, and estimated training gaps. 4. Super User Warehouse Network Charter. Identifying and onboarding operational floor leaders from each shift to champion the new solution. Key takeaway. These change deliverables are the foundation for early user buy-in, protecting the project from floor resistance and high hypercare costs.
Change readiness and user adoption KPIs.
A highly structured program uses measurable KPIs during the early phases to track organizational readiness. 1. Change readiness score. Measuring the quantitative survey readiness level across different warehouse locations. 2. Stakeholder buy-in percentage. Tracking executive, supervisor, and operator alignment milestones. 3. Super user coverage. Ensuring sufficient super user coverage across all warehouse shifts and operational areas based on warehouse complexity, operational volume, and shift structure. 4. Training readiness percentage. Verifying prerequisite functional and technical knowledge before the formal training phase begins. 5. Organizational risk rating. Evaluating the likelihood of post-go-live operational disruption based on cumulative survey data. 6. User Adoption Index. Measuring transaction completion time, RF navigation efficiency, exception handling accuracy, and overall process adherence across warehouse operations. Key takeaway. Measuring readiness early allows the program to target change interventions where they are needed most, rather than treating the warehouse as a single, uniform entity.
Follow-up 1. Why is early assessment of change readiness critical in EWM projects?
Answer: because EWM fundamentally changes how floor operators execute tasks, shifting from manual decisions to rigid, system-guided workflows. If you ignore this during Discover, user resistance and muscle memory loss will surface during hypercare, resulting in high scanning error rates, shipment delays, and severe drops in overall warehouse throughput.
Follow-up 2. How do you assess warehouse user readiness effectively?
Answer: I conduct stakeholder interviews, warehouse floor observations, structured change impact assessments, user persona analysis, and role-based readiness surveys. Combined with interactive workshops, these formal activities allow us to quantify operational adoption risks, identify localized resistance, and establish baseline readiness metrics before solution design begins.
Follow-up 3 curveball. What do you do when logistics leadership insists their operational teams are highly skilled and need minimal training?
Answer: I treat that as a significant project risk. I organize a short, interactive demo of the S/4HANA EWM mobile RF interface and standard exception workflows. Allowing leadership and supervisors to physically see the process transition usually changes their perspective. If they still resist, I formally register the organizational adoption risk, quantify its potential impact on go-live readiness and warehouse productivity, and request formal risk acceptance through the project's governance process.
Governance takeaway for this migration incident 7.
Organizational readiness is a governance deliverable, not merely a training activity. Successful SAP EWM transformation programs consistently recognize that organizational adoption, rather than technology, is often the determining factor between a stable go-live and prolonged operational disruption.
Migration incident 8. Unrealistic expectations from the S/4HANA trial system.
During the Discover phase, the business views standard SAP best practices in a S/4HANA trial system and assumes their highly customized legacy warehouse processes can easily adapt to the standard solution with minimal change management. Trial systems showcase perfect processes running under perfect conditions. This creates a dangerous expectation gap when compared to real-world warehouse operations containing broken packaging, damaged barcodes, and manual physical workarounds. Business objective: set realistic expectations regarding the operational and custom development effort required to move from highly customized legacy environments to standard SAP EWM scope items.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this expectation management failure as follows. 1. Complexity: high strategic solution assessment and expectation management failure. 2. Frequency: very common in legacy ERP and LEWM migrations. 3. Business process: solution visioning and best practice expectation alignment. 4. Warehouse area: entire warehouse operations. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise solution architect and change management lead. 8. Business ownership: logistics leadership and program sponsor.
Migration incident analysis and root cause why this happens.
This unrealistic expectation usually stems from the following root causes. 1. Business stakeholders see clean, pre-configured SAP best practices in a sandbox trial system without their custom operational complexities. 2. A failure to demonstrate how highly customized legacy processes would actually map to standard EWM. 3. Weak workshop facilitation that fails to challenge business assumptions about it will be easy to adapt to standard processes. 4. A strong program bias to reduce perceived implementation effort, timeline, and cost by overestimating standard adoption. 5. Operational warehouse floor managers are not invited to trial system demonstrations to provide a reality check. 6. SAP trial systems demonstrate pre-configured reference processes rather than customer-specific operating models, leading stakeholders to incorrectly assume production readiness.
Business, solution, and operational impact.
Unrealistic expectations during Discover create major execution failures later in the lifecycle. 1. Business impact: severe resistance to change during the design phase, massive scope creep, and a rapid decline in business confidence when technical realities surface. 2. Solution impact. Suboptimal EWM process design because the project is forced to build complex, unplanned customizations late in the realize phase. 3. Project impact. Significant project timeline delays, budget overruns, and an emergency increase in training and change management effort before go live.
The trial system versus real warehouse reality.
A standard SAP trial system demonstrates reference business processes under ideal conditions. A real warehouse operates under constant operational exceptions, physical constraints, and years of accumulated business complexity. 1. Trial system demonstration. Clean master data, standard SAP best practice scope items, happy path process execution, and ideal warehouse conditions without operational exceptions. 2. Real enterprise warehouse. Damaged handling units, mixed pallets, blocked bins, inventory discrepancies, manual workarounds, customer-specific packing rules, and physical warehouse constraints. 3. Expectation gap. Business users assume the trial system represents production reality, while architects understand it is only a reference implementation demonstrating standard SAP capabilities. 4. Fit to standard decision. The objective of Discover is not to copy the trial system, but to determine where the business should adopt the SAP standard, redesign its processes, or justify controlled customization. Key insight. Trial systems demonstrate what SAP can do under standard conditions. Discover workshops must determine whether those standard processes realistically support your warehouse before committing to a fit-to-standard strategy.
Governance and accountability.
Clear ownership is essential to align operational expectations before designing the blueprint. 1. Decision owner. Enterprise solution architect and change management lead, jointly accountable for presenting a realistic, unbiased gap analysis. 2. Business sponsor. Program sponsor, responsible for enforcing a strict fact-based fit-to-standard evaluation. 3. Supporting teams. EWM functional lead, training lead, and key warehouse operations supervisors.
Real implementation tips and best practices.
Follow these 4 guidelines during the Discover phase to establish a realistic scope. 1. Actively demonstrate the visual gap between legacy custom transactions and standard EWM best practice scope items. 2. Use real, highly complex scenarios from the physical warehouse floor during trial system walkthroughs. 3. Conduct structured process fit workshops focused exclusively on handling exceptions, automation, and custom packaging. 4. Include a quantitative standard adoption assessment as a mandatory deliverable of the Discover phase. 5. Validate trial system demonstrations using actual warehouse master data, exception scenarios, and operational KPIs rather than standard SAP demo content.
Fit to standard governance deliverables.
A successful Discover phase should conclude with governance artifacts that objectively evaluate standard SAP capabilities before solution design begins. 1. Fit to standard assessment report. Documents which warehouse processes can adopt SAP standard functionality, which require business process redesign, and which require approved customization. 2. Process exception register. Captures operational exceptions, warehouse constraints, automation dependencies, regulatory requirements, and legacy business scenarios not supported by standard SAP best practices. 3. Fit gap decision register. Records every approved fit, gap, workaround, business process change, and custom development decision together with business justification and governance approval. 4. Steering Committee Scope Alignment Charter. Formally approves the target standard adoption strategy, customization boundaries, and implementation scope before entering the Explore phase. Key takeaway. These governance deliverables prevent unrealistic expectations from becoming uncontrolled customization during the Realize phase.
Fit to standard governance KPIs.
Enterprise SAP programs use measurable governance indicators during Discover to determine whether the project is genuinely adopting SAP best practices or gradually drifting toward excessive customization. 1. Standard adoption percentage. Percentage of warehouse business processes that can be implemented using standard SAP EWM functionality without custom development. 2. Fit Gap Complexity Index. Measures the number and business criticality of identified process gaps requiring configuration, business process redesign, or custom development. 3. Approved custom development forecast. Estimated number of approved RICEFW developments remaining after completion of the fit to standard assessment. 4. Business process alignment score. Percentage of business stakeholders who formally agree that the proposed future state warehouse processes satisfy operational requirements. 5. Scope Stability Index. Measures the number of new business requirements introduced after completion of fit to standard workshops. Key takeaway. These KPIs provide objective evidence that the Discover phase has established a realistic implementation scope before the project enters Explore, reducing late scope expansion and unnecessary customization.
Follow-up 1. Why do businesses often develop unrealistic expectations from S/4HANA trial systems?
Answer. S/4HANA trial system showcase pre-configured standard SAP best practice scope items under perfect conditions with perfect master data. This creates a false impression that the software will easily support highly customized, complex legacy warehouses out of the box. In reality, mature warehouses run on process exceptions, physical space constraints, and carrier guidelines that standard scope items simply do not address.
Follow-up 2. How do you manage expectations effectively during Discover phase workshops?
Answer. I run structured fit to standard preparation workshops where we map legacy processes against standard EWM scope items like 1FS and 1G2. I explicitly force the business to walk through their most complex exceptions, such as damaged handling units, multi-batch splits, and shipping deviations, rather than just reviewing standard happy path flows.
Follow-up 3 curveball. What do you do when the steering committee demands a zero customization standard implementation, but your EWM assessment shows major physical exceptions?
Answer. I do not fight the mandate directly. Instead, I prepare an objective, detailed process gap analysis with quantified business impacts. I show them exactly how forcing standard EWM onto a highly complex physical process, such as complex multi-vendor returns, will drop daily throughput and increase manual operator errors. If the steering committee still chooses a zero customization strategy, I formally document the residual business risk, record the decision, and obtain executive sign-off before entering Explore.
Governance takeaway for this migration incident 8.
Unrealistic expectations set during Discover become the root cause of user resistance and customization scope explosions during Realize. Managing operational expectations honestly is a core program governance responsibility. Fit to standard is not about forcing the business to accept SAP. It is about making informed governance decisions based on quantified business trade-offs.
Migration incident 9. Budgeting generic SAP resources without realizing that complex labor management, yard logistics, or MFS require rare, niche EWM experts.
During the Discover phase, the project team plans the budget and resource model using generic SAP EWM functional consultants, assuming they can seamlessly implement advanced niche submodules such as material flow systems, labor management, and yard logistics. These specialized submodules require deep technical skills in automation engineering, socket communications, industrial engineering, and carrier scheduling. Underestimating this skill chasm leads to severe project stalls during the Realize phase. Business objective. Establish a highly accurate and realistic project resource model that aligns specialized EWM consultant skill sets with the targeted automation and operational scope.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this resourcing and capability planning failure as follows. 1. Complexity. High resourcing and governance failure. 2. Frequency, very common in highly automated warehouses. 3. Business process, resource sourcing and capability planning. 4. Warehouse area, entire warehouse organizational structure. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, program manager and enterprise solution architect. 8. Business ownership, program sponsor and IT steering committee.
Migration incident analysis and root cause why this happens.
This strategic resourcing failure stems from several key architectural and project management blind spots. 1. Executive leadership assumes that any senior S/4HANA EWM consultant can configure any sub-module of the system. 2. A structured capability assessment of the required specialist roles was never performed before budgeting and vendor selection. 3. A complete failure to analyze the technical depth required for PLCs, socket communications, and automated conveyor handshakes during the discover phase. 4. System integrators propose generic resource templates to keep their bids competitive, hiding the need for specialized architects. 5. The program budget does not allocate premium rates or contingency buffers for rare MFS, labor, or yard logistics specialists.
Business, program, and operational impact.
Sourcing standard resources for niche EWM modules creates compounding bottlenecks across the lifecycle. 1. Program impact. Immediate project stalls during the realize phase leading to delayed system integration testing, intense vendor contract disputes, expensive post-blueprint change requests, and missed milestone targets. 2. Financial impact. Unplanned billing leakage, premium emergency contractor procurement costs, and an extended hypercare support period that severely dilutes the transformation ROI. 3. Operational impact. Unstable warehouse automation messaging, inaccurate labor reports, and a compromised yard flow that together raise the probability of post-go-live operational disruption.
The Enterprise EWM Capability Matrix.
A standard project plan must explicitly map these 8 distinct technical and functional capability domains. 1. Core functional. Standard configuration of storage types, bin layouts, warehouse process types, and picking and put-away strategies. 2. Technical development and extensibility. Deep custom ABAP development, BADI enhancements, and S/4HANA-specific repository adjustments. 3. RF mobility and UX. Zebra or Honeywell device configurations, screen personalizations, ITS mobile deployment, and custom Fiori applications. 4. Middleware and integration. Mapping QRFCQs, standard ERP stock synchronization, IDOC processing, and external API interfaces. 5. Automation and MFS. Automation telegram configuration, TCP or IP socket connection setup, PLC mapping, layout-oriented storage control. 6. Labor management. Modeling engineered labor standards, travel time networks based on physical coordinates and employee metrics. 7. Yard logistics. Gate checkpoint operations, carrier appointment scheduling, vehicle tracking, and trailer staging logic. 8. Solution architecture. Cross-functional process design, enterprise system landscape standards, and overall technical program blueprinting. Key insight. Standard functional consultants excel at core processes. However, automation, labor, and yard are highly technical engineering subdomains that require certified, independent specialists.
Governance and accountability.
We establish clear governance boundaries to enforce resourcing and capability standards. 1. Decision owner. Program manager and enterprise solution architect, jointly accountable for verifying specialized skill requirements in the project plan. 2. Review board. Enterprise architecture review board, responsible for auditing the resource capability matrix against the automation and operational scope. 3. Business sponsor. IT steering committee and program sponsor, accountable for approving the premium funding required to source niche EWM specialists. 4. Supporting teams. HR sourcing team, procurement and system integrator delivery lead.
Real implementation tips and best practices.
Apply these 4 strategic principles during the discover phase to secure your resource model. 1. Identify all advanced automation, labor tracking, and yard management requirements early in the discover phase. 2. Demand a formal audited skill matrix from your system integrator specifically for MFS, labor, and yard management resources. 3. Build explicit budget contingencies to absorb the higher daily rates of verified, independent niche specialists. 4. Perform structured resume reviews and technical interviews before onboarding critical consultants to the implementation team.
EWM capability and resourcing deliverables.
A compliant discover phase must exit with these concrete resourcing deliverables before authorizing blueprint activities. 1. Niche skill demand plan. A detailed timeline mapping the exact weeks and phases where specialized MFS, labor, or yard logistics consultants are required. 2. Capability gap assessment. A formal document identifying required capabilities versus available skills and documenting sourcing gaps before Explore begins. 3. System Integrator RACI and CV Audit Log. A formally verified capability register matching nominated consultant resumes with proven project references. 4. Automation and Labor Scope Blueprint. A high-level technical scope document defining the boundaries of automated conveyor and labor tracking requirements. 5. Niche Resource Sourcing Risk Register. A documented risk register outlining backup hiring strategies and contingency suppliers for rare EWM technical skills. Key takeaway: these resourcing deliverables protect the program timeline from late-stage realization stalls, ensuring that qualified experts are on site when technical builds begin.
Resourcing and skill set KPIs.
We track these 5 quantitative indicators to manage resourcing and capability risks during the early project phases. 1. Niche consultant ratio. The percentage of certified MFS, labor, and yard management specialists relative to standard functional EWM resources in the plan. 2. Critical capability coverage percentage. Measuring the exact percentage of high-risk operational workstreams staffed with validated, certified specialists before realize starts. 3. Automation expert lead time. The average number of days required to source, interview, and onboard a qualified PLC integration specialist. 4. SLA to skill set alignment index. A metric evaluating the system integrator's contract performance in providing qualified specialists. 5. Core Team EWM certifications. The percentage of standard consultants holding active, verified SAP S/4HANA EWM professional certifications. Key takeaway: quantifying specialized resourcing metrics during Discover is how senior architects protect the program from generic, low-skilled implementation teams.
Follow-up 1. Why do standard EWM functional consultants struggle to configure MFS or labor management?
Answer: because MFS and labor management are distinct specializations. MFS requires an understanding of TCP/IP socket communications, PLC telegram structures, and layout-oriented storage control handshakes. Labor management requires deep knowledge of industrial engineering travel time networks and engineered labor standards. These are entirely different career skill sets from standard EWM configuration.
Follow-up 2. How do you perform a proper EWM capability and resourcing audit during the Discover phase?
Answer: I map the EWM functional scope against the skills of the nominated project team. If MFS, labor, or yard logistics are in scope, I conduct structured technical interviews, audit CVs for real-world project references, and demand a clear RACI matrix from the system integrator that shows exactly who owns each complex sub-module.
Follow-up 3 Curveball. What do you do when the system integrator insists they can configure MFS with standard EWM resources, but your assessment shows no automation specialists are on the team?
Answer: I formally document the risk in the program risk register with quantified impacts on the timeline and integration testing. I request a meeting with the system integrator's delivery executive and ask them to demonstrate a working MFS telegram handshake using their proposed resource profile. This usually forces them to bring in a qualified, independent MFS specialist.
Governance takeaway for this migration incident 9.
Budgeting generic SAP resources for specialized SAP EWM capability domains is a catastrophic governance failure. Always align EWM specialized skill sets with the targeted project scope early in the program lifecycle.
Category 1 Strategy and Business Assessment Conclusion.
To summarize Category 1, commercial and strategic alignment represents the most critical gate of the entire transformation lifecycle. Establishing an accurate S/4HANA EWM business case, validating complex licensing models, selecting the correct deployment architecture, and performing an audited niche capability assessment are program-defining activities. If your strategic assumptions are flawed during the Discover phase, no amount of technical configuration in later phases can save the program budget.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 1 to Category 2.
With the macro strategy, licensing limits, and resource models defined, we must now pivot from corporate planning to the physical reality of the warehouse floor. Even the most secure business case will collapse if the underlying solution is built on incomplete process discovery. We will now transition into Category 2, Warehouse Process Discovery, where we analyze the severe operational risks that occur when physical warehouse flows are omitted from the initial project scope.
Category 2, Warehouse Process Discovery.
In S4 HANA EWM, process discovery is the foundation of the core configuration. Far too often, project teams assume legacy warehouse processes will seamlessly fit standard templates without deep process discovery. Category 2 analyzes the critical operational gaps, spanning inbound bottlenecks, outbound DC variations, internal custom logic, production staging delays, and compliance omissions that must be documented early in the discover phase to prevent massive redesign loops during the blueprint.
Category 2. Warehouse Process Discovery Incidents 10 to 15.
To prevent blueprint failures, a thorough discover phase must systematically audit and document these 6 process domains. Incident 10. Critical inbound warehouse processes are missing from the initial discovery scope. Incident 11. Outbound fulfillment process variations across different distribution centers are overlooked. Incident 12. Internal warehouse movement processes are assumed to be standard but contain extensive custom logic. Incident 13. Production supply and manufacturing staging processes are discovered only after project planning has started. Incident 14. Reverse logistics and customer returns processes are not included in the initial business assessment. Incident 15. Compliance, regulatory, and audit requirements such as FDA, GXP, customs, food safety, and hazardous materials are not identified early. Let's dive into Incident 10.
Migration Incident 10. Critical inbound warehouse processes are missing from the initial discovery scope.
During the discover phase, the project team fails to identify and document advanced inbound process complexities in the legacy warehouse landscape. Inbound receiving is frequently assumed to be a standard, direct-to-bin goods receipt. In reality, mature warehouses operate highly complex, multi-step flows involving process-oriented storage control, layout-oriented storage control, mixed pallet deconsolidation, and quality inspection stages. Failing to scope these early leads to severe blueprint revisions during the explore phase. Business objective. Document and validate all legacy inbound warehouse processes and physical handling variations to ensure the future S4 HANA EWM design accurately captures multi-step storage control requirements.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this inbound process discovery failure as follows. 1. Complexity. High inbound process discovery and assessment failure. 2. Frequency. Common in highly customized legacy warehouses. 3. Business process. Inbound warehouse process discovery. 4. Warehouse area. Inbound receiving deconsolidation and put-away zones. 5. EWM deployment type. Not yet decided. 6. Immediate business priority. High. 7. Primary ownership. EWM solution architect. 8. Business ownership. Inbound logistics manager and program sponsor.
Migration incident analysis and root cause why this happens.
This inbound process scoping gap typically arises due to the following root causes. 1. Discovery workshops focus primarily on happy path direct goods receipt processes, ignoring physical anomalies. 2. Discovery workshops rely on conference room discussions instead of structured warehouse floor observations and process mining. 3. Complex multi-step warehouse execution flows involving logical and physical storage controls are overlooked. 4. Quality inspection processes such as S4 HANA quality management and quality inspection engine integrations are assessed too late. 5. Physical warehouse layout constraints, unloading lane limitations, and deconsolidation table capacities are ignored. 6. Legacy custom receiving workarounds, such as manual mixed vendor pallet sorting, are not documented.
Business, program, and operational impact.
Failing to scope complex receiving processes creates compounding issues across the project lifecycle. 1. Business impact. Extended project blueprinting timelines, massive configuration redesigns during the realize phase, and severe post-go-live congestion at the receiving docks. 2. Warehouse impact. Forklift drivers and RF operators cannot perform standard put-aways because mixed pallets cannot be decomposed, causing physical blockages in the unloading lanes. 3. Financial impact. Late discovery of inbound process complexity results in expensive redesign activities, additional consulting effort, change requests, and increased implementation costs that were never included in the original project budget. 4. Operational KPIs affected. Inbound dock-to-stock cycle times skyrocket, daily goods receipt throughput declines by over 50%, and carrier detention charges accumulate rapidly.
Governance and accountability.
We align the lines of operational governance to secure the inbound process scope early. 1. Decision owner, EWM solution architect, accountable for verifying the accuracy of the legacy inbound process assessment. 2. Review board, enterprise architecture review board, responsible for auditing the proposed storage control model against physical layouts. 3. Business sponsor, inbound logistics manager, responsible for providing operational experts to demonstrate current receiving variations. 4. Supporting teams, quality assurance lead, integration architect, and warehouse floor supervisors.
Real implementation tips and best practices.
Apply these 4 operational principles during the discover phase to secure your inbound process baseline. 1. Map all inbound processes systematically from the initial gate check-in and truck arrival to the final storage bin put away. 2. Run dedicated process workshops focused on multi-step storage control flows, including deconsolidation and layout routing. 3. Formally document and validate all quality inspection requirements, including S/4HANA quality management integration. 4. Verify the physical processing steps required for mixed vendor pallets and co-mingled receiving on the active warehouse floor. 5. Perform warehouse walkthroughs during multiple operational shifts, including day, night, weekend, and seasonal peak operations, to capture process variations that are often missed during workshop discussions.
EWM inbound process deliverables.
A compliant discover phase must exit with these concrete process deliverables before starting the blueprint. 1. Inbound process flow blueprint. A detailed process flow diagram detailing multi-step unloading, deconsolidation, and staging workflows using POSC or LOSC. 2. Deconsolidation work center layout. A physical and logical layout blueprint defining deconsolidation table requirements, scale integrations, and split task confirmation steps. 3. Quality inspection integration map. A technical integration document aligning S/4HANA quality management with the quality inspection engine. 4. Inbound exception handling registry. A comprehensive catalog outlining standard system actions for physical discrepancies, such as over-deliveries, damaged cargo, and missing packaging specifications. 5. Inbound process capability assessment. A comprehensive inventory documenting every inbound warehouse process, operational variation, storage control requirement, exception scenario, and business owner before the explore phase begins. Key takeaway. These process deliverables are the foundation for the S/4HANA EWM blueprint, preventing the project team from copying legacy bad habits and ensuring standard compliance.
Follow-up 1. What are POSC and LOSC in EWM, and why are they critical to scope during the discover phase?
Answer. Process-Oriented Storage Control, or POSC, controls the logical sequence of inbound steps, such as unloading, deconsolidation, and quality check. Layout-Oriented Storage Control, or LOSC, controls physical routing based on layout constraints, like moving stock to an intermediate conveyor identification point. If these are not scoped during discover, you will be forced to completely re-engineer your core warehouse structure and work center configuration during the realize phase.
Follow-up 2. How do you identify hidden multi-step inbound processes during discovery workshops?
Answer. I conduct physical warehouse floor observations during active receiving shifts. I track the physical journey of a mixed pallet from the truck bed to its final storage bin. I look for manual sorting, off-system quality control checks, and split pallet operations. These physical workarounds are immediate indicators that the business requires formal deconsolidation or quality inspection engine workflows in EWM.
Follow-up 3 curveball. What if the client insists that EWM only needs to handle direct-to-bin putaways, but your physical audit shows they routinely receive mixed vendor pallets that need sorting?
Answer. I do not debate them theoretically. Instead, I present a process flow showing the standard EWM direct put-away failure mode when a mixed pallet is scanned at the dock. I explain that without deconsolidation work centers configured via POSC, operators will be forced to perform manual, unmonitored splits on the floor destroying inventory accuracy. This immediately demonstrates that standard deconsolidation is a mandatory operational requirement, not an optional customization.
Governance takeaway for this migration incident 10.
Comprehensive inbound process discovery is a fundamental governance responsibility during the discover phase. Failing to identify complex receiving scenarios early creates costly redesigns, delays blueprint approval, and increases operational risk throughout the migration program.
Migration incident 11. Outbound fulfillment process variations across different distribution centers are overlooked.
During the discover phase, the project team assumes that outbound fulfillment processes are standardized across the organization, completely overlooking critical physical and operational process variations across different distribution centers. EWM outbound execution is governed by complex, site-specific rules such as wave picking, specialized packing work centers, and carrier routing guides. Attempting to force a single outbound global template without documenting these distribution center variations early results in extensive, costly redesign loops during the blueprinting phase. Business objective: document and analyze all local outbound process variations across the distribution center network to establish a realistic, standard-aligned global template that accommodates physical operational realities.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this outbound process discovery failure as follows. 1. Complexity: high multi-site outbound process discovery failure. 2. Frequency: very common in global SAP rollouts. 3. Business process: outbound fulfillment process discovery. 4. Warehouse area: outbound picking, packing, staging, and shipping lanes. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM solution architect. 8. Business ownership: global logistics director and distribution center managers.
Migration incident analysis and root cause why this happens.
Failing to document local outbound variations typically stems from several key architectural gaps. 1. Discovery workshops are held exclusively with headquarters executives, ignoring the physical realities of different distribution centers. 2. An inaccurate assumption that outbound fulfillment is a generic process of picking, packing, and shipping across all sites. 3. A failure to analyze the technical impact of site-specific warehouse order creation rules and wave release strategies. 4. Underestimating the complexity of localized carrier integrations, regional shipping label designs, and dynamic routing guides. 5. Ignoring the physical space and staging lane constraints of individual distribution centers during initial planning. 6. The project team assumes that one representative warehouse accurately reflects the outbound processes of all distribution centers, eliminating the need for structured multi-site discovery and process validation.
Business, program, and operational impact.
Overlooking local outbound variations creates severe bottlenecks across the project lifecycle. 1. Business impact: extended blueprinting timelines, massive custom development scope creep during the realize phase, and a high probability of post-go-live shipping blocks that directly trigger customer service level agreement fines. 2. Warehouse impact: operators are forced to execute inefficient travel paths because standard picking rules do not align with local physical layouts, causing severe packing and staging lane congestion on the floor. 3. Financial impact: late identification of outbound process variations generates expensive redesign activities, additional consulting effort, localized custom developments, and higher rollout costs across multiple distribution centers. 4. Operational KPIs affected: outbound order-to-ship cycle times degrade, warehouse worker picking productivity drops, shipping dock utilization rates decline, and carrier departure delays accumulate.
The global template versus local outbound gap.
We must analyze how a single outbound template fails to support diverse physical distribution center requirements. 1. Picking and wave strategies: high-volume distribution centers require automated wave picking and consolidation, whereas smaller regional sites require direct pick-to-clean processes to avoid unmanageable staging lane congestion. 2. Warehouse order creation rules: a global template might dictate picking by volume, but a site with narrow aisles and specialized forklifts requires task grouping based strictly on resource and layout constraints. 3. Packing and shipping specifications. Modern automated distribution centers use cartonization and automated packing lines, whereas standard manual sites rely heavily on simplified manual packing work centers. 4. Automation and shipping execution. Highly automated distribution centers may depend on conveyor systems, sorters, automated packing stations, and carrier manifest integrations, whereas manual warehouses execute these activities through RF-guided processes. A single outbound template must define where standardization ends and approved local exceptions begin. Key insight: standardizing outbound processes does not mean ignoring local physical realities. If you do not map these variations during Discover, your global template will fail on the first rollout site.
Governance and accountability.
We establish clear lines of governance to secure multi-site outbound process alignment. 1. Decision owner. EWM solution architect accountable for defining the global template boundaries and standard exceptions. 2. Review board. Enterprise architecture review board, responsible for auditing proposed outbound processes against local physical capabilities. 3. Business sponsor. Global logistics director, responsible for resolving process standardization disputes across different distribution centers. 4. Supporting teams. Outbound operations supervisors, carrier integration leads, and site-specific warehouse managers.
Real implementation tips and best practices.
Apply these 4 architectural guidelines during the Discover phase to secure your outbound template. 1. Conduct structured multi-site process mapping focusing explicitly on picking, consolidation, packing, and carrier integration. 2. Use a standardized process maturity grid to categorize distribution centers based on physical automation and layout complexity. 3. Involve actual shipping floor supervisors and local logistics managers in early fit-to-standard scoping workshops. 4. Perform a detailed audit of localized carrier shipping regulations and regional label printing requirements. 5. Classify distribution centers by business profile, automation maturity, order volume, product characteristics, and customer fulfillment model before defining the global outbound template.
EWM, outbound process deliverables.
A compliant Discover phase must exit with these concrete outbound process deliverables before starting the blueprint. 1. Multi-site outbound process matrix. A detailed document mapping picking, packing, staging, and carrier consolidation flows across all distribution centers. 2. Warehouse order creation rules mapping. A logical design blueprint outlining targeted task grouping rules based on local forklift and layout constraints. 3. Outbound packaging specification catalog. A standardized document outlining global versus localized packaging rules and cartonization strategies. 4. Carrier and label integration register. A comprehensive technical register mapping local carrier routing guides, regional label templates, and printing triggers. 5. Global Template Exception Register, a governance document defining approved local outbound process deviations, business justification, ownership, and architectural approval before entering the Explore phase. Key takeaway: these outbound process deliverables are the foundation for the S/4HANA EWM blueprint, protecting the template from costly late-stage local customization demands.
Outbound excellence and standardization KPIs.
We track these 4 quantitative indicators to manage template standardization risks during the early project phases. 1. Process Standardization Index, the target percentage of outbound warehouse processes running on standard, unmodified global template rules. 2. Warehouse Order Rules Complexity Rating, a metric measuring the variance of custom task grouping rules required across different locations. 3. Wave Release Compatibility Score, a quantitative rating of the physical readiness of all distribution centers to execute standard wave picking. 4. Carrier Label Template Variance, the total number of unique, localized carrier shipping label templates required across the active warehouse network. Key takeaway: measuring process variance early in the Discover phase allows the steering committee to enforce standard adoption before the build phase begins.
Follow-up 1. What is WOCR in EWM, and why does forcing a single rule across multiple sites create project failure?
Answer: Warehouse Order Creation Rules, or WOCR, control how individual warehouse tasks are grouped and assigned to operators. Forcing a single WOCR globally ignores differences in physical warehouse layouts, forklift types, and workforce sizes. A high-volume picking rule forced on a small, narrow aisle warehouse will create empty or highly fragmented tasks, severely reducing day-one operator productivity.
Follow-up 2. How do you identify hidden outbound variations during the discover phase?
Answer: I do not rely on standard questionnaire spreadsheets. I perform physical shift-level observations at the high-priority distribution centers. I track how different product types are picked, routed to packing stations, consolidated for carrier pickup, and loaded onto trucks. This reveals the actual variations in packaging specifications and staging constraints.
Follow-up 3 curveball. What do you do when a local warehouse manager rejects the outbound global template because it does not support their highly customized manual staging process?
Answer: I organize an objective process comparison workshop. I map their manual staging process against standard S/4HANA EWM wave staging logic. I show them that, while standard EWM requires a slight change in physical floor habits, it provides automated staging visibility, reducing manual supervisor tracking. If they still resist, I formally register the risk with a cost-benefit analysis of adapting to standard versus building custom code.
Governance takeaway for this migration incident 11.
Successful global template governance depends on identifying genuine business-driven local variations while preventing unnecessary customization. Comprehensive multi-site outbound discovery is essential to balancing enterprise standardization with operational reality.
Migration incident 12. Internal warehouse movement processes are assumed to be standard but contain extensive custom logic.
During the discover phase, the project team assumes that internal warehouse movement processes, such as replenishment, posting changes, stock consolidation, and physical inventory, are standard and can easily adopt standard S/4HANA EWM processes. In legacy systems, these internal activities are frequently heavily customized using custom transaction codes, automated background scripts, and legacy user exits. Assuming a standard fit without conducting a detailed technical assessment of these internal flows leads to major blueprinting gaps and unplanned custom ABAP development during the realize phase. Business objective: accurately assess and document legacy, custom internal movement logic to align warehouse operations with standard S/4HANA EWM warehouse process types and replenishment engines.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this internal process discovery failure as follows. 1. Complexity: high internal process discovery and technical debt failure. 2. Frequency: common in highly customized legacy warehouse systems. 3. Business process: internal warehouse process discovery. 4. Warehouse area: storage areas, replenishment zones, and counting stations. 5. EWM deployment type: not yet decided. 6. Immediate business priority: medium. 7. Primary ownership: EWM solution architect. 8. Business ownership: warehouse operations managers and program sponsor.
Legacy internal movement inventory.
Experienced architects audit the legacy system for these hidden custom internal movement logics during the discover phase. 1. Custom replenishment engine: proprietary background programs triggering stock moves based on non-standard seasonal rules. 2. Custom warehouse process type WPT determination: proprietary rules assigning warehouse process types using custom document attributes, storage characteristics, handling unit data, or customer-specific business logic. 3. Custom queue determination: proprietary logic assigning warehouse tasks to resources based on forklift type, shift, warehouse zone, or operator skill rather than standard queue determination. 4. Custom posting changes: tailored transactions executing stock status transitions and storage bin moves simultaneously. 5. Dynamic stock consolidation: custom automated routines consolidating partially filled storage bins on the fly. 6. Dynamic bin optimization: proprietary algorithms constantly reshuffling stock without standard EWM slotting controls. 7. Custom physical inventory flows: Non-standard counting, threshold tolerance checks, and immediate write-off approval paths. 8. Manual RF stock transfers. Custom mobile screens bypassing standard process-oriented storage controls to speed up floor operations. 9. Legacy user exits. Undocumented ABAP logic modifying warehouse task creation, warehouse order determination, confirmation logic, or stock movement processing. 10. Background stock balancing jobs. Automated scripts running overnight to redistribute inventory across specific zones. 11. Automated emergency replenishment. Real-time triggers bypassing standard minimum thresholds when picking demand spikes. 12. MFS-related item. Custom automation triggers if automation is in scope. Proprietary logic initiating conveyor, ASRS, PLC, or robotics activities outside standard MFS processing enterprise, warehouses with automation, another excellent addition. This is a frequent source of migration complexity. Key takeaway: these undocumented legacy logics are the primary source of process friction. Finding them during discover prevents them from quietly corrupting standard S/4HANA EWM configurations later.
Migration incident analysis and root cause why this happens.
Underestimating the complexity of internal warehouse movements typically stems from several key architectural gaps. 1. Internal warehouse movements are treated as low-risk back-office processes, receiving minimal attention during workshops. 2. An inaccurate assumption that standard EWM process types will automatically cover legacy custom stock consolidation logic. 3. A failure to identify and document custom background programs that trigger automatic replenishment or stock consolidation. 4. Legacy user exits and custom RF transaction screens used for physical inventory and stock adjustments are not analyzed. 5. A lack of understanding regarding how legacy stock status transitions map to S/4HANA EWM storage control configurations.
Business, program, and operational impact.
Overlooking custom internal warehouse logic introduces significant risks across the project lifecycle. 1. Business impact. Extended project blueprinting timelines, unexpected custom development costs during the realize phase, and a high risk of operational disruption if standard replenishment cannot keep pace with outbound picking demands. 2. Warehouse impact. Operators face severe stock outs in the picking areas because standard replenishment triggers do not align with physical warehouse usage patterns, forcing supervisors to execute manual, unmonitored stock moves. 3. Operational KPIs affected. Outbound picking delays accumulate, replenishment warehouse task queue times increase, physical inventory counting accuracy degrades, and overall warehouse labor productivity declines.
The internal movement, custom logic gap.
We must analyze how standard EWM internal movement configurations conflict with legacy customized processes. 1. Standard replenishment engines. Standard EWM uses planned, direct, or order-related replenishment based on fixed thresholds. Legacy custom processes often use complex background scripts that evaluate dynamic constraints like seasonal demands or vendor batch priorities. 2. Posting changes and stock status. Standard EWM handles posting changes through structured process types. Legacy systems often rely on custom transactions to change stock status, such as unrestricted to quality or blocked, while simultaneously triggering non-standard storage control movements. 3. Stock consolidation and slotting. Standard EWM uses systematic slotting and rearrangement. Legacy sites often use custom-developed warehouse processes to dynamically consolidate partially filled storage bins on the fly, bypassing standard system controls. Key insight: internal movements are what keep the warehouse alive. If your replenishment design is built on unvalidated legacy assumptions, your high-volume picking lines will run completely dry.
Governance and accountability.
We establish clear governance boundaries to manage the internal warehouse process scope. 1. Decision owner. EWM solution architect, accountable for mapping legacy custom internal logic to standard EWM process types. 2. Review board. Enterprise Architecture Review Board, responsible for auditing custom internal process development requests against standard capabilities. 3. Business sponsor. Warehouse operations managers, responsible for identifying all active background custom movement scripts. 4. supporting teams, inventory control specialists, integration architect, and functional configuration lead.
Real implementation tips and best practices.
Apply these 4 architectural guidelines during the discover phase to secure your internal processes. 1. Perform a detailed audit of all custom transaction codes, background jobs, and user exits related to stock movements. 2. Map legacy replenishment triggers against standard EWM replenishment engines, including direct and plan models. 3. Involve physical inventory control specialists and replenishment supervisors directly in early fit to standard scoping workshops. 4. Verify all stock status transition rules, including posting change configurations and quality inspection blocks.
EWM internal process deliverables.
A compliant discover phase must exit with these concrete process deliverables before starting the blueprint. 1. Internal process mapping and custom logic matrix. A detailed document mapping all legacy internal movements, replenishment rules, ad hoc moves, and their custom parameters. 2. Standard EWM replenishment fit gap analysis. A technical fit gap report comparing legacy replenishment triggers to standard EWM planned and direct replenishment engines. 3. Posting change and stock status transition blueprint. A logical design blueprint detailing how stock status changes and process-oriented storage controls execute. 4. Inventory adjustments and physical inventory governance. A standardized document outlining target counting procedures, tolerance limits, and stock consolidation logic. Key takeaway: these internal process deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and customization demands.
Internal process excellence and standardization KPIs.
We track these 4 quantitative indicators to manage internal process standardization risks during the early project phases. 1. Internal process customization rate. The target percentage of internal process types planned to run on standard, unmodified global templates. 2. Replenishment efficiency score. A metric evaluating the alignment of proposed EWM replenishment triggers with legacy physical execution times. 3. Warehouse process type proliferation rating. The total number of unique, custom warehouse process types planned relative to standard templates. 4. Inventory adjustment reconciliation delta. A quantitative measurement of baseline discrepancies in counted stock between legacy processes and target EWM standards. Key takeaway: measuring process variance early in the discover phase allows the steering committee to enforce standard adoption before the build phase begins.
Follow-up 1. What is a warehouse process type in EWM, and why does legacy custom internal logic complicate its design?
Answer: the warehouse process type, or WPT, is the core engine of EWM, controlling the physical execution, stock updates, storage control, and confirmation logic of every task. Legacy custom internal logic, such as automated ad hoc consolidation or custom stock status changes, bypasses standard WPT routing. Attempting to implement these custom flows without redesigning them to fit standard WPT structures results in unstable, complex technical debt.
Follow-up 2. How do you identify hidden legacy custom replenishment logic during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform a deep dive audit of active background job schedules and custom transaction logs in the legacy system. I track how, when, and why replenishment tasks are physically triggered on the warehouse floor during peak picking shifts. This reveals the actual, non-standard exception rules being used by the business.
Follow-up 3 curveball. What do you do when the warehouse floor team insists on keeping a highly customized dynamic bin consolidation process, but the standard EWM slotting and rearrangement processes cannot support it?
Answer: I demonstrate standard EWM bin consolidation and rearrangement logic in a live sandbox system. I show them that while standard EWM uses systematic, optimized batch run parameters, it eliminates the need for their manual, risky, on-the-fly custom consolidation transactions. If they still resist, I formally register the risk with a comparative analysis showing how standard EWM standardizes labor tracking and reduces system deadlocks.
Governance takeaway for this migration incident 12.
Assuming internal processes are standard without a technical audit of legacy custom movement logic is a costly governance failure. Secure your core warehouse process type design during discover to protect long-term system stability.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 13. Production supply and manufacturing staging processes are discovered only after project planning has started.
During the discover phase, the project team assumes that the target warehouse operates as a standalone distribution center, failing to identify active production supply and manufacturing staging processes. In legacy systems, supply to line-side staging bins is frequently managed by manual workarounds, custom material reservation scripts, or third-party shop floor systems. Discovering these complex integration touchpoints late in the planning cycle triggers immediate project delays and massive budget revisions. Business objective: ensure comprehensive project scoping by identifying all production supply and line-side staging requirements early, aligning warehouse capabilities with standard S/4HANA PP and EWM integration designs.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this production supply discovery failure as follows. 1. Complexity: high cross-functional integration and discovery failure. 2. Frequency: common in manufacturing connected warehouses. 3. Business process: production supply and manufacturing staging discovery. 4. Warehouse area: production supply areas, line-side staging bins, and shop floor work centers. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise architect and EWM solution architect. 8. Business ownership: manufacturing operations director and program sponsor.
Typical production supply and staging complexities.
Experienced architects audit the legacy shop floor and manufacturing interfaces for these hidden custom staging logics during the discover phase. 1. Custom MES integration: third-party manufacturing execution systems initiating line staging and stock movements outside standard SAP control. 2. Dynamic PSA assignment: custom logic dynamically allocating production supply areas based on real-time line capacity. 3. Staging via custom Kanbans: physical bins using non-standard electronic triggers to request material from the main warehouse. 4. Commingled staging bins: physical locations shared by different manufacturing lines, creating inventory ownership conflicts. 5. Custom backflushing routines: automated scripts executing raw material consumption based on non-standard custom transaction triggers. 6. Dynamic pick parts routing: custom programs determining whether to stage material as order-specific pick parts or bulk crate parts. 7. Emergency line-side replenishment: manual workarounds used by operators to bypass standard system controls when a stockout occurs at the line. 8. Manufacturing returns handling: non-standard processes used to return unused raw materials or scrap back to the main warehouse. 9. Line-side staging limits: custom rules restricting the physical volume of raw stock allowed at a work center at any given time. 10. Legacy reservation scripts: undocumented background jobs utilizing custom material reservations instead of standard delivery documents. 11. Production version dependencies: legacy staging rules depend on production versions, alternative BOMs, or routing selections that are not documented. 12. Priority-based production staging: custom logic allows urgent manufacturing orders to bypass normal warehouse staging priorities. Key insight: production supply bridges two completely different operational cultures. Finding these complex staging behaviors during discover prevents manufacturing line shutdowns later.
Migration incident analysis and root cause why this happens.
Failing to scope complex production supply integrations typically stems from several key planning gaps. 1. Discovery workshops are held exclusively with logistics managers, completely excluding the manufacturing and shop floor teams. 2. An inaccurate assumption that warehouse operations end at the distribution dock door, ignoring manufacturing connected facilities. 3. A complete failure to identify legacy interfaces between the warehouse system and third-party manufacturing execution systems. 4. Overlooking legacy custom material staging methods, such as manual Kanbans and unmonitored line-side storage bins. 5. Lack of early involvement from cross-functional architects who understand the tight integration between SAP PP and EWM. 6. Existing production supply documents, PMR, or warehouse staging requests are never inventoried during discover.
Business, program, and operational impact.
Ignoring production supply requirements introduces critical risks across the entire project landscape. 1. Business impact. Extended project blueprinting timelines, severe budget overruns, and a catastrophic risk of manufacturing line shutdowns if EWM cannot stage materials fast enough. 2. Warehouse impact. Staging lanes become congested, line-side inventories run completely dry, and operators are forced to execute manual emergency deliveries on the fly. 3. Downstream ERP impact. Production orders are delayed, manufacturing schedules slip, and customer deliveries are affected. 4. Operational KPIs affected. Manufacturing line downtime increases, order-to-stage cycle times degrade, line-side inventory accuracy drops, and overall warehouse labor productivity declines.
Governance and accountability.
We establish clear governance boundaries to manage the cross-functional production supply scope. 1. Decision owner, enterprise architect and EWM solution architect, jointly accountable for mapping cross-functional boundaries in the project plan. 2. Review board, enterprise architecture review board, responsible for auditing the proposed integration architecture. 3. Business sponsor, manufacturing operations director, responsible for providing shop floor experts and documenting active staging variations. 4. Supporting teams, PP functional architect, warehouse operations lead, MES integration lead, manufacturing planning lead, or PP production planning lead.
Real implementation tips and best practices.
Apply these 4 architectural guidelines during the discover phase to secure your staging baseline. 1. Identify all manufacturing connected warehouses and line-side staging locations early in the discover phase. 2. Conduct structured, cross-functional workshops involving both warehouse operations and shop floor manufacturing teams. 3. Perform a detailed audit of all legacy interfaces between the warehouse and any active manufacturing execution systems. 4. Map all legacy manual staging methods against standard S/4HANA PP and EWM integration capabilities, including production material requests. 5. Perform physical shop floor observations across all production shifts to identify undocumented staging workarounds.
EWM production supply deliverables.
A compliant discover phase must exit with these concrete staging deliverables before starting the blueprint. 1. Production supply and staging matrix. A detailed document mapping all active manufacturing lines, physical production supply areas, and staging methods. 2. EWM to PP integration blueprint. A logical design blueprint defining the use of production material requests versus legacy outbound deliveries. 3. Manufacturing execution system interface map. A comprehensive technical register outlining the data boundaries between S/4HANA, EWM, and the shop floor system. 4. Production consumption and return governance plan. A standardized document outlining physical backflushing, scrap handling, and unused material return procedures. Key takeaway: these staging deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and customization demands.
Production staging excellence KPIs.
We track these 4 quantitative indicators to manage integration and staging risks during the early project phases. 1. Production staging automation rating. The target percentage of manufacturing lines planned to run on standard EWM system-guided staging. 2. Production supply standardization rate. Percentage of production supply scenarios implemented using standard PMR processes without customization. 3. Shop floor interface message volume. The estimated daily IDOC or API message volumes between EWM and the shop floor manufacturing execution system. 4. Line-side inventory accuracy delta. A quantitative measurement of baseline discrepancies in counted stock between legacy staging bins and standard system records. Key takeaway: measuring process variance early in the discover phase allows the steering committee to enforce standard adoption before the build phase begins.
Follow-up 1. What is a production material request in EWM, and why does it represent a major shift from legacy ERP staging?
Answer: a production material request, or PMR, is the S/4HANA EWM document that reads manufacturing orders directly from S/4HANA PP to plan and execute staging. In legacy ERP systems, staging is managed by standard outbound deliveries or manual reservations. Shifting to PMRs enables precise, system-guided staging, crate part replenishment, and clear line-side inventory visibility directly inside EWM.
Follow-up 2. How do you identify legacy custom staging and consumption logic during the discover phase?
Answer: I conduct structured, cross-functional workshops with both the warehouse operations team and the shop floor manufacturing supervisors. I perform physical floor walks of the manufacturing staging areas to track exactly how raw material is called, physically staged, and consumed. I then audit active background jobs and any legacy interfaces connecting EWM to third-party shop floor systems.
Follow-up 3 curveball. What do you do when the manufacturing team insists on using a third-party MES to manage staging, but the IT team wants EWM to handle line-side staging directly?
Answer: I do not take a purely technical stance. I map out a clear data boundary and responsibility diagram showing both scenarios. I demonstrate that while the manufacturing execution system is the master of shop floor scheduling, EWM is the master of physical inventory. I show them that standard EWM can send staging messages to the MES, ensuring both systems remain synchronized without custom code. This aligns both teams on an objective, standard-based architecture.
Governance takeaway for this migration incident 13.
Assuming a warehouse is a standalone distribution center without auditing connected manufacturing lines is a severe governance failure. Always establish your cross-functional staging and integration boundaries during discover to prevent catastrophic blueprint delays.
Migration incident 14. Reverse logistics and customer returns processes are not included in the initial business assessment.
During the discover phase, the project team fails to include customer returns and reverse logistics in the initial business and process assessment. Returns are frequently assumed to be a minor, low-volume activity that can be handled using standard inbound goods receipt. In reality, modern multi-channel warehouses process highly complex return flows requiring S/4HANA Advanced Returns Management, dedicated triage work centers, and the quality inspection engine. Omitting this scope during discover guarantees major design and structural gaps during the blueprinting phase. Business objective: ensure a comprehensive process scope by documenting all reverse logistics and customer return flows early, aligning physical sorting and inspection steps with standard S/4HANA EWM capabilities.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this reverse logistics discovery failure as follows. 1. Complexity: high process discovery and quality inspection failure. 2. Frequency: common in retail, e-commerce, and consumer goods migrations. 3. Business process: reverse logistics and customer returns discovery. 4. Warehouse area: returns triage stations, quality inspection work centers, and scrap zones. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM solution architect. 8. Business ownership: reverse logistics manager and program sponsor.
Typical reverse logistics and returns complexities.
Experienced architects audit the legacy warehouse and customer service interfaces for these hidden custom returns logics during the discover phase. 1. Unplanned return sorting: processing physical packages that arrive without a standard return material authorization number. 2. Custom return to vendor flows: managing direct returns to external suppliers with non-standard shipping documents. 3. Manual triage and quarantine: physical sorting areas where stock is manually classified before system inspection occurs. 4. Customer-specific refund holds: temporary inventory locks that delay financial credits until physical inspection is complete. 5. Refurbishment and repackaging: light assembly work centers used to clean, rebox, and relabel returned goods for restocking. 6. Dangerous goods returned classification: dynamic safety checks required for returning hazardous or regulated materials. 7. Unmarked parcel processing: Custom workarounds used to identify and process unknown packages with damaged shipping labels. 8. Customer portal integrations. Custom APIs exchanging return authorizations, shipment notifications, and inspection status updates with the warehouse receiving system. 9. Custom quality inspection logic. Legacy user exits bypassing standard quality checks to immediately credit VIP customers. 10. Immediate scrap routines. Automatic routing based on inspection decisions, product condition, or regulatory requirements. 11. Warranty validation. Returned products require warranty entitlement checks before repair, replacement, or customer credit. 12. Serial number validation. Legacy processes validate serialized products before inspection, refurbishment, or replacement. Key insight. Returns are master data poor and physically chaotic. Auditing these custom return handling workarounds during discover prevents floor congestion and inventory blind spots later.
Migration incident analysis and root cause why this happens.
Failing to scope complex reverse logistics typically stems from several key planning gaps. 1. Discovery workshops are held exclusively with wholesale logistics leads, ignoring retail and e-commerce return channels. 2. An inaccurate assumption that customer returns are simply standard inbound deliveries, ignoring the inspection and triage steps. 3. A failure to identify and document legacy interfaces, connecting third-party customer service portals to the warehouse. 4. Overlooking legacy custom quality inspection routines, unmonitored triage areas, and manual sorting workarounds. 5. Lack of early involvement from cross-functional architects who understand S/4HANA Advanced Returns Management and Quality Inspection Engine integrations. 6. Return volumes and reverse logistics KPIs are never requested during business discovery workshops, leading to incorrect scoping assumptions.
Business, program, and operational impact.
Ignoring reverse logistics requirements introduces critical risks across the entire project landscape. 1. Customer experience. Customer refunds, warranty replacements, and service-level commitments are delayed because inspection and disposition decisions cannot be completed efficiently. 2. Business impact. Extended project blueprinting timelines, severe budget overruns, and a massive risk of floor congestion as uninspected return stock blocks active receiving lanes. 3. Warehouse impact. Triage areas become physically overwhelmed, uninspected inventory remains locked in system blind spots, and operators are forced to perform manual scrap decisions without system guidance. 4. Operational KPIs affected. Return to stock cycle times degrade, customer credit lag times increase, physical inventory accuracy drops, and overall warehouse labor productivity declines.
Governance and accountability.
We establish clear governance boundaries to manage the cross-functional reverse logistics scope. 1. Decision owner. EWM solution architect, accountable for mapping legacy returns logic to standard EWM and S/4HANA Advanced Returns Management. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed quality inspection architecture. 3. Business sponsor. Reverse logistics manager, responsible for providing operational experts and documenting active sorting variations. 4. Supporting teams. Quality lead, S/4HANA sales architect, integration specialist, customer service lead, or after-sales operations manager.
Real implementation tips and best practices.
Apply these 4 architectural guidelines during the discover phase to secure your returns baseline. 1. Identify all return channels, including customer, store, and vendor to warehouse return flows early in the discover phase. 2. Conduct structured, cross-functional workshops involving both warehouse operations and customer service teams. 3. Perform a detailed audit of all legacy interfaces between the warehouse and any active customer portals. 4. Map all legacy manual sorting and triage methods against standard S/4HANA Advanced Returns Management and Quality Inspection Engine capabilities. 5. Observe physical inspection and disposition activities during peak returns periods to identify undocumented manual workarounds.
EWM, reverse logistics deliverables.
A compliant discover phase must exit with these concrete returns deliverables before starting the blueprint. 1. Multi-channel returns process matrix. A detailed document mapping standard customer, store, and vendor to warehouse return flows across all locations. 2. Quality Inspection Engine, an S/4HANA ARM integration blueprint. A logical design blueprint defining inspection documents, decision codes, and logical follow-on workflows. 3. Returns Work Center and Triage Area Layout. A physical and logical layout blueprint defining return stations, sorting bins, repackaging tables, and scrap zones. 4. Logistical Follow-up Action Register. A standardized document outlining system, guided decisions for restocking, scrap, or vendor quarantine. Key takeaway: these returns deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and customization demands.
Reverse logistics excellence KPIs.
We track these 4 quantitative indicators to manage integration and staging risks during the early project phases. 1. Standard Returns Adoption Index. The target percentage of returns processes planned to run on standard, unmodified advanced returns management. 2. First Pass Returns Processing Rate. Percentage of return products correctly processed without manual intervention. 3. Average Return to Stock Lead Time. A quantitative measurement of the target baseline duration for sorting, inspecting, and restocking return material. 4. Unplanned Return Incident Rate. The estimated volume of unexpected packages arriving without standard return material authorization numbers. Key takeaway: measuring process variance early in the discover phase allows the steering committee to enforce standard adoption before the build phase begins.
Follow-up 1. What are standard logistical follow-up actions in S/4HANA Advanced Returns Management, and why are they critical?
Answer: standard logistical follow-up actions define the system-guided physical destination of returned stock after inspection, for example, put away to scrap, transfer to unrestricted, return to vendor, split stock. They are critical because they automate physical routing inside EWM. Omitting them from the design phase forces operators to perform manual, unmonitored stock moves on the floor.
Follow-up 2. How do you identify legacy custom returns and triage logic during the discover phase?
Answer: I conduct structured, cross-functional workshops with both the warehouse operations team and the customer service supervisors. I perform physical floor walks of the receiving and triage areas to track exactly how return parcels are received, sorted, and inspected. I then audit active background jobs and any legacy interfaces connecting EWM to third-party customer portals.
Follow-up 3 curveball. What do you do when the client insists that EWM only needs to handle simple scrap or restock decisions, but your physical audit shows they routinely process complex refurbishment and repackaging steps?
Answer: I demonstrate standard S/4HANA Quality Inspection Engine and advanced returns management workflows in a live sandbox system. I show them that while standard EWM uses systematic optimized follow-up parameters, it eliminates the need for their manual, risky, on-the-fly custom triage transactions. If they still resist, I formally register the risk with a comparative analysis, showing how standard EWM standardizes labor tracking and reduces system deadlocks.
Governance takeaway for this migration incident 14.
Assuming a warehouse is a standalone distribution center without auditing customer returns and reverse logistics is a severe governance failure. Always establish your cross-functional returns and integration boundaries during discover to prevent catastrophic blueprint delays.
Migration incident 15. Compliance, regulatory, and audit requirements. Country-specific warehouse compliance, such as FDA, GXP, customs, food safety, and hazardous materials are not identified early.
During the discover phase, the project team fails to identify and document country-specific warehouse compliance, regulatory guidelines, and audit requirements. Complex constraints such as dangerous goods segregation, bonded customs warehouse integration, and FDA-validated audits are treated as post-go-live operational details. Failing to map these strict guidelines early results in severe compliance liabilities, illegal operational layouts, and massive blueprint redesigns during the explore phase. Business objective: identify and validate all regional warehouse compliance, customs, safety, and audit regulations early, Aligning physical storage layouts with standard S/4HANA EWM security and tracking configurations.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this compliance and regulatory discovery failure as follows. 1. Complexity. High compliance regulatory and security audit failure. 2. Frequency. Common in global multi-country EWM implementations. 3. Business process. Compliance, regulatory, and audit discovery. 4. Warehouse area. Hazardous material storage, bonded zones, and temperature-controlled storage areas. 5. EWM deployment type. Not yet decided. 6. Immediate business priority. High. 7. Primary ownership. EWM solution architect. 8. Business ownership. EWM compliance director and program sponsor.
Typical warehouse compliance and regulatory complexities.
Experienced architects audit the legacy warehouse and local regulatory requirements for these critical compliance areas during the discover phase. 1. Dangerous goods storage segregation. Physical and logical partition of incompatible storage classes, preventing chemicals like flammables and oxidizers from mixing. 2. Regulated audit trails. System-enforced audit logging supporting FDA 21 CFR Part 11, GXP, and other strict regulatory industry requirements. 3. Electronic signature controls. Mandatory electronic approvals and double approver handshakes for regulated inventory or quality-related transactions. 4. Customs reference tracking. Tracking customs declaration references, bonded stock identifiers, and customs document numbers throughout internal warehouse processing. 5. Bonded warehouse compliance. Segmenting duty paid versus duty unpaid stock under customs control, requiring automated customs compliance processing through SAP GTS or other customs management platforms. 6. Controlled substance storage. Vaulted storage structures requiring strictly monitored physical access, specialized handling process types, and multi-user logging. 7. Product recall traceability. End-to-end downstream tracking of contaminated or non-compliant batches to execute rapid, targeted product recalls. 8. Shelf life expiration date checks. System-enforced first expired first out strategies to comply with local food safety and pharmaceutical laws. 9. Cold chain temperature tracking. Continuous monitoring and logging of temperature-controlled zones with automated system alerts on variants. 10. Regulatory batch segregation rules. Preventing different supplier batches of the same active pharmaceutical material from mixing in a single storage bin. Key insight. Warehouse compliance is non-negotiable. Auditing these strict regulatory rules during discover prevents illegal storage layouts, government shutdowns, and severe financial fines.
Migration incident analysis and root cause why this happens.
Failing to scope complex warehouse compliance typically stems from several key planning gaps. 1. Discovery workshops are held exclusively with standard warehouse managers, ignoring regional quality and legal officers. 2. An inaccurate assumption that compliance requirements are simply local standard operating procedures, ignoring system integration needs. 3. A failure to identify and document legacy interfaces connecting the warehouse system to customs and environmental platforms. 4. Overlooking legacy custom segregation rules, manual temperature logs, and physical paper-based audit checklists. 5. Lack of early involvement from cross-functional architects who understand S/4HANA EHS and GTS integrations. 6. Regulatory teams are not included in solution discovery because compliance is incorrectly viewed as an operational responsibility rather than a solution architecture requirement.
Business, program, and operational impact.
Ignoring warehouse compliance requirements introduces critical risks across the entire project landscape. 1. Business reputation. Regulatory violations may result in product recalls, reputational damage, and loss of customer trust in addition to financial penalties. 2. Business impact. Catastrophic regulatory fines, government-enforced warehouse shutdowns, loss of customs bonded licenses, and immediate project suspension during blueprinting. 3. Warehouse impact. Physical layout configuration is declared invalid, incompatible hazardous materials are unsafely co-mingled on the floor, and operators lack systematic electronic signature guidance. 4. Operational KPIs affected. Customs clearance times degrade, batch status reconciliation speed drops, inventory tracking accuracy declines, and overall warehouse audit readiness fails.
Governance and accountability.
We establish clear governance boundaries to manage the cross-functional compliance scope. 1. Decision owner. EWM solution architect, accountable for mapping legacy compliance rules to standard EWM, GTS, and EHS integrations. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed compliance and security architecture. 3. Business sponsor. Warehouse Compliance Director, responsible for providing regional legal and quality experts to define local constraints. 4. Supporting teams. Quality lead, S/4HANA EHS architect, GTS integration lead, corporate compliance officer, or regulatory affairs lead.
Real implementation tips and best practices.
Apply these 4 architectural guidelines during the discover phase to secure your compliance baseline. 1. Identify all country-specific warehouse regulatory requirements, customs guidelines, and quality standards early in the discover phase. 2. Conduct structured, cross-functional workshops involving warehouse operations, local quality directors, and legal compliance officers. 3. Perform a detailed audit of all legacy interfaces between the warehouse and any active customs or regulatory platforms. 4. Map all legacy manual segregation and audit methods against standard S/4HANA GTS, EHS, and S-led capabilities. 5. Review recent external audit findings and regulatory observations before defining the future state solution.
EWM compliance and regulatory deliverables.
A compliant discover phase must exit with these concrete compliance deliverables before starting the blueprint. 1. Multi-site warehouse compliance registry. A detailed document mapping standard FDA, GXP, customs, and hazardous material regulations across all locations. 2. Dangerous goods and segregation logic blueprint. A logical design blueprint defining EWM storage classes, physical partition rules, and EHS segregation strategies. 3. GTS bonded warehouse integration map. A comprehensive technical register outlining customs boundaries, customs ID tracking, and GTS interface triggers. 4. Audit trail and electronic signature specification. A standardized document outlining mandatory, change tracking transaction logs, validation rules, and double approver workflows. Key takeaway: these compliance deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from legal liabilities, warehouse closures, and design rebuilds.
Compliance and safety KPIs.
We track these 4 quantitative indicators to manage compliance and regulatory risks during the early project phases. 1. Standard Compliance Adoption Index. The target percentage of regulatory processes planned to run on standard, unmodified GTS or EHS modules. 2. Audit trail and log coverage percentage. A metric verifying that all critical inventory modification transactions have strict, validated change tracking logs active. 3. Dangerous goods segregation compliance rate. A quantitative rating of how successfully proposed EWM storage structures prevent incompatible chemical mixing. 4. Bonded stock reconciliation accuracy. The target matching precision between S/4HANA EWM stock records and external governmental customs reports. 5. Regulatory requirement coverage. Percentage of identified regulatory requirements mapped to approved solution designs. Key takeaway: measuring process variance early in the discover phase allows the steering committee to enforce standard adoption before the build phase begins.
Follow-up 1. How do you design warehouse processes for bonded inventory while maintaining customs compliance?
Answer: I design a clear logical and physical segregation strategy within EWM. We configure dedicated storage types and customs reference tracking fields to capture customs declarations and bonded stock identifiers throughout warehouse inventory movements. I then establish a standardized, real-time interface boundary between EWM and a customs management platform, such as SAP GTS or a local broker system, to automate duty, unpaid stock changes, and customs clearance triggers.
Follow-up 2. How do you identify legacy warehouse compliance and regulatory rules during the discover phase?
Answer: I do not rely on standard configuration documentation. I conduct structured workshops with local quality directors, legal counsel, and environmental officers. I perform physical floor walks to identify placard warnings, physical segregation walls, and custom labels. I then audit legacy interfaces connecting EWM to customs portals or compliance systems.
Follow-up 3 curveball. What do you do when a local quality manager demands custom transaction logs and electronic signatures, but the IT team wants to use standard EWM audit trails?
Answer: I demonstrate standard S/4HANA system enforced change logs, standard audit trails, and integrated platform electronic signature frameworks in a live sandbox system. I show them how S/4HANA uses systematic, GXP-compliant parameters and broader SAP electronic signature and approval capabilities, minimizing the need for custom developments. If they still resist, I formally register the risk with a comparative analysis, showing how standard SAP platform capabilities satisfy FDA requirements.
Governance takeaway for this migration incident 15.
Assuming warehouse operations have no regulatory boundaries without auditing country-specific compliance is a severe governance failure. Always establish your legal and environmental integration boundaries during discover to prevent warehouse closures.
Category 2. Warehouse Process Discovery Conclusion.
To summarize Category 2, granular process discovery is the only way to safeguard your future S/4HANA EWM configuration. Documenting multi-step storage control flows, work center layouts, production supply integrations, reverse logistics, and regional compliance guidelines during the discover phase is non-negotiable. Skipping this level of process diligence ensures that the project team will face highly expensive, disruptive redesign loops during the blueprinting phase.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, They all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 2 to Category 3.
With our core receiving, picking, internal staging, returns, and compliance processes fully mapped, we must now lift our gaze to the physical and systemic boundaries of the enterprise network. A single warehouse process is only as strong as the broader landscape it operates within. We will now transition into Category 3, Warehouse Landscape Discovery, where we analyze the architectural risks of multi-site warehouse planning, satellite facilities, and hybrid legacy landscapes.
Category 3, Warehouse Landscape Discovery.
In S4 HANA EWM, Landscape Discovery defines the physical and systemic boundaries of the transformation program. Category 3 deep dives into the critical risks of multi-site warehouse planning, including the accidental omission of satellite facilities, unmapped cross-warehouse transfers, underestimated storage structures, and poorly scoped hybrid landscapes running on non-SAP warehouse management systems.
Category 3, Warehouse Landscape Discovery Incidents 16 to 20.
To prevent blueprint failures, a thorough discover phase must systematically audit and document these 5 landscape domains. Incident 16. One or more satellite warehouses are accidentally excluded from the migration scope definition. Incident 17. Cross-warehouse stock transfer processes are not identified during landscape discovery. Incident 18. Warehouse storage type complexity is significantly underestimated during initial assessment. Incident 19. Existing warehouse organizational structure contains hidden business rules that are not documented anywhere. Incident 20. Third-party WMS or legacy warehouse dependencies. Hybrid landscapes where some warehouses still run on non-SAP WMS are not properly scoped. Let's dive into Incident 16.
Migration Incident 16. One or more satellite warehouses are accidentally excluded from the migration scope definition.
During the discover phase, the project team accidentally excludes one or more satellite warehouses, offsite overflow yards, or leased seasonal storage locations from the migration scope definition. IT scoping often focuses exclusively on primary distribution centers, ignoring the physical network of secondary buildings that support daily logistics. Excluding these nodes from the initial assessment results in incomplete S/4HANA enterprise structure configurations, blocked inventory transfers, and severe physical stock bottlenecks during peak operating seasons. Business objective: accurately identify and map all active physical storage locations and satellite nodes to ensure complete coverage in the S/4HANA EWM enterprise structure design.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this landscape discovery failure as follows. 1. Complexity. high enterprise landscape and scoping failure. 2. Frequency, very common in complex multi-site logistics networks. 3. Business process, warehouse landscape discovery. 4. Warehouse area, satellite warehouses, leased yards, and overflow storage locations. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, enterprise architect and lead solution architect. 8. Business ownership, logistics operations director and program sponsor.
Typical warehouse landscape boundaries.
Experienced architects audit the legacy enterprise structure and physical operations for these hidden landscape nodes during the discover phase. 1. Overflow yards and lease storage, temporary physical buildings leased during peak seasons to hold excess raw materials or finished goods. 2. Third-party logistics sites, warehouses managed by external partners that require stock synchronization but are often left out of core scoping. 3. Consignment stock locations, vendor-managed inventory locations or customer consignment hubs physically near the main distribution center. 4. Transit and cross-dock hubs, intermediate staging points used for regional consolidation before final customer dispatch. 5. Returns processing centers, off-site reverse logistics facilities separated physically from the main inbound and outbound flow. 6. Production buffer warehouses, internal production supply areas, supermarkets, or line-side storage facilities located outside the primary warehouse boundary. 7. Co-manufacturing yards, staging areas situated at external partner manufacturing sites. 8. Obsolete stock holding areas, physical zones used to quarantine expired, damaged, or litigation-held stock. 9. Spare parts storage areas, dedicated maintenance, repair, and operation storage zones managed outside standard inventory. 10. Quality testing facilities, dedicated laboratories or inspection areas supporting destructive and non-destructive quality testing. 11. Intercompany distribution warehouses, facilities owned by another legal entity but operationally integrated into the logistics network. Key insight: IT teams think in terms of ERP plants, but logistics operates in physical yards. Auditing these physical landscape nodes during discover prevents blind spots in your S/4HANA enterprise structure.
Migration incident analysis and root cause why this happens.
Failing to scope secondary warehouse nodes typically stems from several key planning gaps. 1. Scoping sessions rely entirely on corporate ERP organizational charts, which rarely document physical yards and leased buildings. 2. An inaccurate assumption that because a satellite yard lacks standard RF network coverage, it does not require system configuration. 3. Underestimating the volume of stock transferred between the main warehouse and off-site overflow facilities. 4. A failure to involve local shift-level transportation and staging supervisors who manage daily off-site shuttles. 5. Excluding third-party logistics nodes and external toll manufacturer warehouses from the initial S/4HANA migration scope. 6. Project scope is defined from ERP organizational data, without validating the physical logistics network with warehouse operations.
Business, program, and operational impact.
Omitting satellite warehouse locations introduces critical risks across the entire project landscape. 1. Financial reconciliation. Inventory valuation and financial reconciliation become increasingly difficult when stock is physically stored in locations outside the approved enterprise structure. 2. Business impact. Severe budget overruns, forced post-blueprint change requests during the realize phase, and a catastrophic loss of stock visibility during peak shipping seasons. 3. Warehouse impact. Physical gridlock at the main distribution center as operators cannot shuttle excess stock to unconfigured, system-invisible satellite yards. 4. Operational KPIs affected. Inventory tracking accuracy degrades, outbound fulfillment cycle times increase, and internal material transfer speeds decline dramatically.
Governance and accountability.
Establish clear governance boundaries to manage the cross-functional landscape scope. 1. Decision owner, enterprise architect and lead solution architect, jointly accountable for verifying the complete physical and systemic boundary maps. 2. Review board, enterprise architecture review board, responsible for auditing the proposed enterprise structure against actual physical properties. 3. Business sponsor, Logistics Operations Director, responsible for providing a comprehensive inventory of all leased and external storage facilities. 4. Supporting teams, warehouse managers from all sites, third-party logistics integration lead, and S/4HANA basis team.
Real implementation tips and best practices.
Apply following architectural guidelines during the discover phase to secure your landscape boundaries. 1. Execute a comprehensive physical audit of all active storage nodes, including off-site buildings, yards, and third-party facilities. 2. Conduct structured landscape workshops involving both corporate IT architects and local warehouse operations managers. 3. Map all active plant and storage location codes in the legacy system against actual physical locations. 4. Formally evaluate the technical and operational feasibility of integrating satellite yards into S/4HANA EWM versus standard inventory management. 5. Validate every physical storage location using both site visits and inventory movement history, rather than relying solely on organizational documentation.
EWM landscape discovery deliverables.
A compliant discover phase must exit with these concrete landscape deliverables before starting the blueprint. 1. Enterprise Warehouse Node Registry, a comprehensive catalog documenting all physical buildings, yards, satellite sites, third-party logistics facilities, and leased spaces. 2. S/4HANA Enterprise Structure Map, a logical architecture map aligning all legacy plants and storage location codes with target EWM warehouse numbers. 3. Multi-Site Inventory Ownership Blueprint, a standardized document outlining inventory ownership, valuation boundaries, and transaction flows across all nodes. 4. Landscape Boundary Risk Register, a documented risk register outlining potential scoping exclusions, integration constraints, and clear mitigation paths. Key takeaway: these landscape deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and enterprise structure redesigns.
Landscape sourcing and integration KPIs.
We track these 4 quantitative indicators to manage landscape scoping risks during the early project phases. 1. Landscape scoping coverage percentage, the target percentage of physically active storage nodes formally documented and approved in the project scope. 2. Enterprise Structure Deviation Score, a metric measuring the number of legacy plant and storage location combinations currently unmapped to target warehouse numbers. 3. External Partner Integration Readiness, a quantitative assessment of the technical readiness of third-party logistics nodes to connect to the target landscape. 4. Physical Node Discovery Variance, the total discrepancy count between the physical warehouse audit and the initial IT project scope documentation. Key takeaway: quantifying landscape scope metrics during discover is how senior architects protect the program from late-stage enterprise structure changes.
Follow-up 1. What is the S/4HANA enterprise structure, and why does excluding a satellite warehouse during discover ruin its design?
Answer: the S/4HANA enterprise structure defines the organizational links between plants, storage locations, and EWM warehouse numbers. If a satellite warehouse is excluded during discover, it will not be mapped to an EWM warehouse number. This means standard ERP to EWM stock transfers, delivery replication, and goods movements cannot be executed systemically, completely breaking the physical flow of stock to that yard.
Follow-up 2. How do you identify hidden legacy warehouse locations and satellite yards during the discover phase?
Answer: I do not rely on high-level IT organizational charts. I conduct physical operational interviews with floor supervisors and transportation coordinators. I track physical yard movements, shuttle trucks, and off-site storage logs. I then perform a thorough audit of all active storage location codes in the legacy system to identify unmapped physical nodes.
Follow-up 3 curveball. What do you do when the PMO refuses to expand the project scope to include a newly discovered satellite yard because the budget is already frozen?
Answer: I do not argue against the budget. Instead, I prepare an objective, detailed process impact document. I show them that excluding the satellite yard from the EWM enterprise structure means they will be physically storing stock in an unmapped building, creating a total inventory blind spot in S/4HANA. I ask them to choose between approving a controlled scope adjustment now or accepting severe audit failures and stock write-offs during go-live.
Governance takeaway for this migration incident 16.
Assuming the enterprise warehouse landscape consists only of primary distribution centers without auditing satellite warehouses, overflow facilities, and external storage locations is a severe governance failure. Always establish complete enterprise landscape boundaries during discover to prevent costly scope gaps and enterprise structure redesigns.
Migration incident 17. Cross-warehouse stock transfer processes are not identified during landscape discovery.
During the discover phase, the project team fails to identify and analyze the critical cross-warehouse stock transfer processes within the legacy landscape. Stock movements between different plants and warehouses are frequently assumed to be standard, independent inbound and outbound deliveries. In reality, transferring inventory between EWM-managed sites requires complex S/4HANA integration, including stock transport orders, in-transit stock visibility, batch attribute retention, and opportunistic cross-docking. Omitting these flows during discover leads to severe inventory blockages, lost transit visibility, and massive blueprint redesigns. Business objective: document and map all cross-warehouse stock transfer processes early to ensure seamless integration between S/4HANA ERP, issuing warehouses, and receiving warehouses.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this cross-warehouse discovery failure across the following strategic boundaries. 1. Complexity: high cross-functional landscape and integration failure. 2. Frequency: common in complex multi-site warehouse networks. 3. Business process: cross-warehouse stock transfer discovery. 4. Warehouse area: outbound staging, inbound receiving, and stock in transit yards. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM solution architect and lead integration architect. 8. Business ownership: logistics operations director and transportation manager.
Typical cross-warehouse transfer complexities.
Experienced architects audit the legacy landscape and transport networks for the following hidden cross-warehouse transfer logics during the discover phase. 1. Stock transport orders STOs, standard inter-plant transfer processes generating synchronized outbound and inbound delivery documents across issuing and receiving warehouses. 2. Two-step stock transfer postings, managing transit inventory and in-transit stock visibility across different geographical storage zones. 3. Opportunistic cross-docking, dynamically routing inbound stock transfers directly to outbound staging lanes to bypass physical put-away. 4. Inter-company stock transfers, transfers between legal entities requiring automated customs declarations, trade compliance checks, and inter-company billing. 5. Intra-company transfers with batch retention, retaining physical batch characteristics, shelf life expiration dates, and inspection statuses across warehouses. 6. Transit stock visibility, real-time monitoring of inventory while assigned to transportation units, shipments, or shuttle vehicles. 7. Single-step transfer postings, simplified, single-step system postings for co-located, physically connected warehouse buildings. 8. Physical shuttling reconciliation, manual processes used to reconcile physical shuttle truckloads against active system stock transfer documents. 9. Automatic replenishment between satellites, warehouse-to-warehouse automatic replenishment runs driven by central inventory planning systems. 10. Customs bonded transit transfers, moving duty unpaid stock between bonded warehouses without triggering immediate customs duties or tax events. 11. Transportation management TM integration, coordinating stock transfers with transportation planning, freight units, and shipment execution. Key insight: a stock transfer involves two active warehouses, not just one. Auditing these transit and cross-docking rules during discover prevents inventory from getting permanently stuck in transit limbo.
Migration incident analysis and root cause why this happens.
Failing to scope complex stock transfers typically stems from the following root causes. 1. Scoping workshops treat each warehouse as a completely standalone entity, ignoring the physical stock transfers between them. 2. An inaccurate assumption that because a stock transfer is an internal process, it does not require complex delivery replication configuration. 3. Underestimating the volume and frequency of stock shuttled between manufacturing warehouses and regional distribution hubs. 4. A failure to involve transportation planning leads and shuttle coordinators in early discover workshops. 5. Ignoring the impact of inter-company legal entity boundaries, customs processes, and global trade compliance on internal stock transfers. 6. Internal stock transfers are treated as operational warehouse activities instead of enterprise-wide integration processes.
Business, program, and operational impact.
Ignoring cross-warehouse stock transfer requirements introduces critical risks across the project landscape. 1. Customer impact. Customer deliveries are delayed because receiving warehouses cannot consume inventory that remains systemically stuck in transit. 2. Business impact. Severe financial reconciliation errors during month-end close, delayed benefits realization, and a complete loss of stock visibility for products in transit. 3. Warehouse impact. Physical gridlock at the receiving warehouse docks as shuttle trucks arrive with stock that cannot be systematically processed due to missing inbound delivery replication. 4. Operational KPIs affected. Outbound picking cycle times increase. Dock-to-stock transit speeds degrade, receiving lane congestion rises, and overall inventory valuation accuracy drops.
Governance and accountability.
We establish clear governance boundaries to manage the cross-warehouse integration scope. 1. Decision owner. EWM solution architect and lead integration architect, jointly accountable for mapping cross-warehouse delivery replication flows. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed stock transfer and transit architecture. 3. Business Sponsor. Logistics Operations Director, responsible for providing a comprehensive map of all internal and external inventory transfer routes. 4. Supporting Teams. Transportation Manager, Finance Lead, GTS Specialist, Site-specific warehouse managers and transportation management lead, especially if TM is in scope.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your stock transfer boundaries. 1. Execute a comprehensive audit of all internal stock transfer routes, document types, and transit mechanisms. 2. Conduct joint process workshops involving both issuing and receiving warehouse operations leads and transport planners. 3. Map all active stock transport order configurations in the legacy system against actual physical warehouse locations. 4. Formally evaluate the technical feasibility of standard S/4HANA stock and transit tracking to manage stock visibility between yards. 5. Validate all recurring stock transfer routes using historical movement data instead of relying solely on documented business processes.
EWM stock transfer, discovery deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Cross-warehouse transfer process matrix. A comprehensive document mapping all internal stock transfer scenarios, issuing and receiving plants and transit types. 2. S/4HANA ERP to EWM STO integration blueprint. A logical design blueprint defining delivery replication, shipping types, and automated goods issue and receipt triggers. 3. Stock in transit visibility map. A technical architecture document outlining how transit stock will be systematically tracked and valued between physical locations. 4. Intercompany transfer and billing governance plan. A standardized document aligning trade compliance, global trade services, and financial intercompany postings. Key takeaway: these stock transfer deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and delivery replication errors.
Stock transfer excellence and standardization KPIs.
We track the following critical indicators to manage stock transfer and integration risks during the early project phases. 1. Cross-warehouse standardization index. The target percentage of stock transfer processes planned to run on standard S/4HANA STO configurations. 2. Transit inventory reconciliation accuracy. The target precision matching required between transit stock in S/4HANA ERP and physical warehouse states. 3. Opportunistic cross-docking utilization. The expected percentage of inbound stock transfers planned to be routed directly to outbound shipping doors. 4. Cross-warehouse integration message volume. The estimated daily EDI or API message volumes required to support stock transfers between legal entities. Key takeaway: quantifying transfer process metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a stock transport order in S/4HANA, and why does EWM delivery replication represent a critical configuration step?
Answer: a stock transport order, or STO, is the ERP document used to request stock transfer between plants. In EWM, this must replicate as an outbound delivery in the issuing warehouse and an inbound delivery in the receiving warehouse. If the delivery replication, shipping points, or partner mappings are not aligned, EWM cannot create the physical picking and receiving tasks, completely blocking the transfer of stock.
Follow-up 2. How do you identify legacy custom stock transfer and shuttling logic during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical operational interviews with transportation planners and dispatch coordinators. I track physical gate logs, shuttle truck manifests, and manual clipboard registries. I then perform a thorough audit of all active stock transfer document types in the legacy system to identify unmapped systemic flows.
Follow-up 3 curveball. What do you do when a local warehouse manager insists on using a custom, single-step transfer posting to move stock to an off-site yard, but your assessment shows they need full transit stock visibility?
Answer: I do not argue the point conceptually. Instead, I show them that a single-step posting immediately deducts the stock from the issuing warehouse and adds it to the receiving warehouse before the truck has even loaded. I explain that if that truck is involved in an accident, the business has a complete financial and audit blind spot. I demonstrate standard S/4HANA stock in transit tracking, showing how it secures inventory valuation during transit without increasing operator clicks.
Governance takeaway for this migration incident 17.
Ignoring cross-warehouse stock transfer processes during Discover is a severe governance failure. Always establish your technical transport replication and stock in transit boundaries during the initial landscape discovery to prevent massive month-end close delays.
Migration incident 18. Warehouse storage type complexity is significantly underestimated during initial assessment.
During the Discover phase, the project team significantly underestimates the physical and logical complexity of the warehouse storage structures. IT planning teams frequently rely on high-level ERP storage location counts, assuming they can map the warehouse using a few standard storage types. In reality, a single physical warehouse rack often requires multiple EWM storage types to manage separate levels, automated handling systems, hazardous materials, and temperature-controlled zones. Underestimating this structural complexity leads to a massive multiplication of warehouse process types, search sequences, and physical inventory rules during blueprinting. Business objective: accurately assess and document the physical and logical warehouse storage structures early to prevent downstream scope explosions in the S/4HANA EWM core design.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this structural discovery failure across the following strategic boundaries. 1. Complexity: high warehouse structural discovery and assessment failure. 2. Frequency: very common in complex multifunctional warehouses. 3. Business process: warehouse landscape and structural discovery. 4. Warehouse area: entire warehouse physical and logical storage structures. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM solution architect. 8. Business ownership: warehouse operations managers and program sponsor.
Typical warehouse storage type complexities.
Experienced architects audit the legacy warehouse and physical floor layouts for the following logical storage structures during the Discover phase. 1. Automated high bay storage: demands complex multi-depth capacity checks, pallet height classifications, and tight integration with automated conveyor systems. 2. Temperature-controlled zones: requires separate, isolated storage types with distinct physical inventory and stock movement rules for chilled, frozen, or deep freeze rooms. 3. Hazardous material vaults demands specific fire compartment storage types and strict logical segregation rules to prevent chemical cross-contamination. 4. Automated mini-load and ASRS systems requires dynamic high-frequency interim storage types designed to handle rapid bin updates and automated sorting. 5. Gravity-fed flow racks demands specialized stock removal strategies, physical replenishment triggers, and front picking and rear stocking layouts. 6. Mezzanine picking areas requires separate storage types to manage floor weight limits, split picking tasks, and localized resource queue assignments. 7. Dynamic interim storage types. Dynamic interim storage areas supporting goods receipt, goods issue, staging, deconsolidation, and packing. 8. Bulk storage with HU nesting requires configuring bulk storage types with mixed handling unit stacking rules and automated block detection logic. 9. High-value vaulted areas demands strictly controlled storage types with double approver authorization rules and restricted user access lists. 10. Customs bonded storage areas requires logical partitioning to separate duty-paid and duty-unpaid stock within physically shared rack structures. 11. Production supply storage types. Dedicated storage types supporting production supply areas PSAs, line side staging, and manufacturing replenishment. Key insight: the storage type is the logical bedrock of EWM. Auditing these physical structures during Discover prevents the standard process denial that derails the Explore phase blueprint.
Migration incident analysis and root cause why this happens.
Failing to scope storage type complexity typically stems from the following root causes. 1. IT planning teams rely on generic, high-level ERP plan and storage location counts instead of auditing physical floor structures. 2. An inaccurate assumption that a physical rack represents only one logical storage type, ignoring microprocess and automated zoning variations. 3. Failing to conduct detailed on-site physical audits of cold chain, hazardous, and high-value secure storage zones. 4. A complete failure to analyze how physical storage types interact with warehouse process types and storage type search sequences. 5. Project budgets and vendor proposals are finalized using oversimplified legacy warehouse blueprint documents. 6. Storage structure design is estimated from ERP organizational data instead of validated warehouse engineering drawings and operational walkthroughs.
Business, program, and operational impact.
Underestimating physical storage complexity introduces critical risks across the project landscape. 1. Testing. Test scope expands significantly because each additional storage type introduces new put-away, picking, replenishment, and exception scenarios. 2. Program impact. Immediate timeline slippage and budget overruns during the Explore phase, as the project team realizes the required configuration scope for search sequences has multiplied by 10. 3. Warehouse impact. Standard put-away and picking strategies fail because EWM cannot logically resolve destination bins for incompatible materials, creating immediate congestion in receiving lanes. 4. Operational KPIs affected. Inventory tracking accuracy drops. Physical storage capacity utilization declines. Pick-to-stock cycle times increase, and warehouse order confirmation speeds degrade.
Governance and accountability.
We establish clear governance boundaries to manage the physical warehouse structure scope. 1. Decision owner. EWM solution architect, accountable for mapping physical warehouse structures to logical EWM storage types. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed storage structures against regional safety and operational standards. 3. Business sponsor. Warehouse operations managers, responsible for providing detailed physical blueprints and layout documentations. 4. Supporting teams. Inventory control specialists, quality assurance lead, and warehouse engineering lead or automation engineer.
Real implementation tips and best practices.
Apply the following strategic guidelines during the Discover phase to secure your warehouse structure boundaries. 1. Execute a comprehensive physical audit of all active storage zones, including automated, temperature-controlled, and hazardous materials areas. 2. Conduct structured landscape workshops involving both corporate IT architects and local warehouse shift supervisors. 3. Map legacy storage structures against standard EWM storage type capabilities, evaluating capacity check and replenishment models. 4. Formally evaluate the technical feasibility of standardizing storage structures to reduce the total number of unique warehouse process types. 5. Validate every proposed storage type against actual operational processes rather than physical warehouse layouts alone.
EWM storage structure, discovery deliverables.
A compliant discover phase must exit with the following concrete structural deliverables before starting the blueprint. 1. Physical to logical storage type map. A comprehensive document mapping actual physical warehouse zones to target EWM storage types and sections. 2. Storage type search sequence matrix. A detailed logical flow defining destination search priorities for put away, picking, and replenishment. 3. EWM warehouse structure blueprint. A validated architecture document outlining storage structures, physical sections, bin layouts, and work center locations. 4. Storage structure risk and mitigation register. A documented risk register outlining potential capacity, automation, or hazard segregation risks and mitigation paths. Key takeaway: these structural deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and storage structure redesigns.
Structural complexity and standardization KPIs.
We track the following critical indicators to manage structural and configuration risks during the early project phases. 1. Storage Type Standard Adoption Index. The target percentage of storage types planned to run on standard, unmodified global templates. 2. Storage Type Complexity Ratio. A metric measuring the total number of required logical storage types relative to physical warehouse zones. 3. Search Sequence Proliferation Rating. The total number of planned put away, picking, and replenishment search sequences. 4. Physical bin structural variance. The total discrepancy count between legacy bin structures and standard EWM coordinate-based bin formats. Key takeaway: quantifying structural complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a storage type in EWM, and why does underestimating its complexity during Discover ruin the blueprint?
Answer: the storage type is the core building block of the EWM warehouse, controlling physical behavior, put-away rules, picking strategies, and capacity checks. If you underestimate its complexity during Discover, the blueprint will stall. You will find that a single physical rack requires multiple logical storage types to handle separate levels or automated interfaces, multiplying the number of required process types, search sequences, and test scripts.
Follow-up 2. How do you identify hidden legacy warehouse storage type complexities during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical warehouse floor walks during active peak shifts. I inspect the storage areas for placard warnings, fire doors, temperature boundaries, and automated interfaces. I then audit active material master data in the legacy system to identify dynamic bin assignments and unmapped storage sections.
Follow-up 3 Curveball. What do you do when the PMO insists on keeping the storage structure configurations simple to save budget, but your physical audit shows the business requires complex automated and hazardous storage types?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when dynamic automated zones or hazardous chemicals are unsafely co-mingled in a single storage type. I explain that forcing simple storage types onto complex physical processes will drop daily throughput, violate environmental regulations, and cause incorrect put-away decisions, inefficient picking routes, and reduced warehouse throughput. I ask them to choose between standard process safety or physical warehouse capacity.
Governance takeaway for this migration incident 18.
Ignoring physical and logical storage type complexities during Discover is a severe governance failure. Always establish your core EWM structural and search sequence boundaries during the initial landscape discovery to prevent massive blueprint and testing delays.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 19. Existing warehouse organizational structure contains hidden business rules that are not documented anywhere.
During the Discover phase, the project team designs the high-level S/4HANA EWM enterprise structure, assuming the legacy warehouse layout operates strictly on standard documented processes. In reality, Mature warehouses operate on a web of undocumented, tribal business rules embedded in legacy custom user exits, hard-coded database tables, and informal floor-level agreements. Discovering these hidden organizational rules late in the project forces major re-architecting of storage types, bin section searches, and activity areas during the realize phase. Business objective: systematically identify, analyze, and document all hidden legacy warehouse organizational rules and tribal behaviors early to align them with standard S for HANA EWM structural configurations.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this structural discovery failure across the following strategic boundaries. 1. Complexity: high enterprise structure and tribal knowledge discovery failure. 2. Frequency: extremely common in long-standing warehouse operations. 3. Business process: warehouse landscape and structural discovery. 4. Warehouse area: entire warehouse physical and logical organizational structure. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM solution architect. 8. Business ownership: warehouse operations managers and program sponsor.
Typical hidden legacy organizational rules.
Experienced architects audit the legacy system and physical floor operations for the following logical hidden rules during the discover phase. 1. Dynamic aisle allocation overrides: custom user exits dynamically redirecting high bay putaways based on floor loading limits, rack height restrictions, or temporary operational constraints. 2. Uncoded shift-based queue routing: custom programs splitting and routing warehouse orders based on informal shift patterns and team lead preferences. 3. Priority vendor stocking overrides: undocumented agreements to bypass standard quality inspection staging lanes for specific trusted suppliers. 4. Tribal material grouping segregations: physical storage practices where operators separate materials based on brand or origin rather than system-defined attributes. 5. Manual bin type choice bypasses: RF terminal customizations allowing operators to manually override system-suggested bins to speed up operations. 6. Dynamic staging lane consolidations: informal, system-invisible packing rules used by staging supervisors to combine different shipping lanes.
Typical hidden legacy organizational rules.
Experienced architects audit the legacy system and physical floor operations for the following logical hidden rules during the discover phase. 7. Ambient hazard storage rules: undocumented safety rules where flammables are dynamically relocated to cooler zones based on seasonal temperatures, environmental conditions, or local safety procedures. 8. Custom storage section searches: hard-coded custom Z tables bypassing standard storage section checks during peak seasonal volumes. 9. Equipment-specific task assignment: custom logic assigning warehouse tasks based on forklift capacity, attachment type, operating zone, or equipment restrictions. 10. Informal quality release bypasses: local procedures allowing emergency raw stock to be routed directly to the manufacturing line before formal system release. 11. Customer-specific allocation rules: informal warehouse practices prioritizing strategic customers during inventory shortages without system-controlled allocation logic. Key insight: the standard EWM structure relies on system-guided discipline. Auditing these undocumented rules during discover prevents major user resistance and system rejection during testing.
Migration incident analysis and root cause why this happens.
Underestimating hidden organizational rules typically stems from the following root causes. 1. Scoping workshops focus exclusively on corporate standard operating procedures, which rarely reflect physical floor adjustments. 2. A complete failure to audit legacy custom code, user exits, and hard-coded custom database tables early in the project. 3. An inaccurate assumption that because a process is managed on paper, it has no impact on EWM configuration. 4. Failing to conduct structured physical shadow sessions with active, shift-level warehouse operators and team leads. 5. PMOs and steering committees prioritize rapid, administrative phase exits over boots on the ground operational diligence. 6. Legacy operational knowledge exists only with experienced warehouse personnel, and is never formally documented during project discovery.
Business, program, and operational impact.
Overlooking hidden organizational rules introduces critical risks across the entire project landscape. 1. Change management. User confidence in the new system declines because operators believe the solution ignores proven operational practices. 2. Program impact. Immediate timeline delays and massive budget overruns during the realize phase as developers attempt to rebuild legacy exits as S/4HANA EWM enhancements. 3. Warehouse impact. Massive user adoption failure as operators reject system-guided tasks because standard EWM bins and search sequences do not reflect local physical rules. 4. Operational KPIs affected. Outbound picking cycle times increase, put-away execution accuracy drops, and overall warehouse labor productivity declines.
Governance and accountability.
We establish clear governance boundaries to manage the legacy custom logic scope. 1. Decision owner. EWM solution architect, accountable for mapping physical legacy rules to standard S/4HANA EWM capabilities. 2. Review board. Enterprise architecture review board, responsible for auditing custom development and exception handling requests. 3. Business sponsor. Warehouse operations managers, responsible for identifying and documenting all active floor-level tribal rules. 4. Supporting teams. Legacy development lead, change management lead, local shift supervisors, and business process owner or warehouse excellence lead.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your enterprise structure boundaries. 1. Perform a detailed audit of all custom transaction codes, user exits, and background programs related to warehouse execution processes. 2. Conduct structured physical shadowing sessions with warehouse operators and shift supervisors across all major working shifts. 3. Map all active plant and storage location configurations in the legacy system against actual physical storage layout rules. 4. Formally evaluate the technical and operational feasibility of standardizing storage structures to reduce the total number of unique process types.
EWM, organizational governance deliverables.
A compliant discover phase must exit with the following concrete structural deliverables before starting the blueprint. 1. Warehouse Organizational Rules Registry, a comprehensive document cataloging all undocumented floor-level rules, exceptions, and shift-based movements. 2. Standard EWM Enterprise Map, a logical architecture map aligning all physical storage areas and work centers with standard EWM structures. 3. Legacy User Exit and Custom Table Audit Log, a validated technical inventory detailing all custom ABAP enhancements impacting legacy stock routing. 4. Tribal Knowledge Mitigation and Alignment Charter, a formally signed document aligning business operations on which legacy custom rules will be standard adopted. Key takeaway. These structural deliverables are the foundation for the S/4HANA EWM blueprint, protecting the template from costly late-stage technical debt and customization demands.
Organizational excellence and standardization KPIs.
We track the following critical indicators to manage organizational standardization risks during the early project phases. 1. Organizational structure standardization rate, the target percentage of storage structures planned to run on standard unmodified templates. 2. Tribal Process Conversion Index, a metric evaluating the progress of mapping undocumented legacy rules to standard system-guided processes. 3. Custom Rule Integration Risk Score, a quantitative rating of the program risk created by unmapped custom legacy database tables. 4. Business Rule Standardization Rate, the percentage of documented legacy business rules successfully mapped to standard SAP EWM functionality without requiring custom development. Key takeaway. Quantifying organizational complexity metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the S/4HANA EWM enterprise structure, and why does undocumented legacy logic complicate its design?
Answer. The S/4HANA EWM enterprise structure defines the organizational links between physical bins, storage sections, activity areas, and warehouse numbers. Undocumented legacy logic, such as manual queue split rules or custom bin selection overrides, operates outside standard configurations. Trying to implement these custom rules without standardizing them in EWM creates highly unstable, complex configuration conflicts.
Follow-up 2. How do you identify hidden legacy, warehouse organizational rules, and tribal behaviors during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical shift-level observations across different active shifts. I shadow operators to identify manual bin adjustments, off-system staging decisions, and custom mobile transactions. I then conduct technical code audits of active user exits to identify unmapped systemic rules.
Follow-up 3 curveball. What do you do when a local warehouse supervisor refuses to adopt standard EWM bin search rules because they violate an undocumented manual aisle clearance rule?
Answer: I do not argue against their physical experience. Instead, I show them standard EWM storage section and storage bin capacity checking rules in a live sandbox system. I demonstrate how standard EWM can systematically prevent capacity limits, storage section determination, and storage bin validation rules automatically without requiring manual operator memory. If they still resist, I formally register the risk with a cost-benefit analysis of adapting to standard EWM configurations versus building custom code.
Governance takeaway for this migration incident 19.
Ignoring undocumented warehouse business rules and tribal operational knowledge during discover is a severe governance failure. Always distinguish between business-critical rules that must be preserved and informal workarounds that should be standardized before entering explore.
Migration incident 20. Third-party WMS or legacy warehouse dependencies. Hybrid landscapes where some warehouses still run on non-SAP WMS are not properly scoped.
During the discover phase, the project team fails to identify and document legacy warehouse dependencies and hybrid landscape coexistence requirements. Large-scale S/4HANA migrations frequently operate on a phased rollout schedule, where some warehouses migrate to standard EWM on day one, while other sites must temporarily or permanently remain on legacy non-SAP warehouse management systems. Failing to scope these hybrid system boundaries early results in massive technical debt, missing delivery routing logic, and expensive unbudgeted middleware developments. Business objective: document and map all third-party warehouse management systems and legacy dependencies early to ensure seamless integration and parallel stock synchronization across the hybrid S/4HANA ERP landscape.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this hybrid landscape discovery failure across the following strategic boundaries. 1. Complexity: high enterprise landscape and integration architecture failure. 2. Frequency: very common in global phased S/4HANA rollouts. 3. Business process: hybrid landscape and multi-WMS integration discovery. 4. Warehouse area: enterprise multi-WMS warehouse network. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: lead integration architect and enterprise solution architect. 8. Business ownership: logistics IT director and program sponsor.
Typical hybrid landscape and integration complexities.
Experienced architects audit the legacy landscape and external interfaces for the following unmapped integration complexities during the discover phase. 1. Transitional multi-WMS coexistence: managing the active overlap of S/4HANA EWM, legacy SAP LEWM, and third-party non-SAP systems during a multi-year phased rollout. 2. Split outbound delivery routing: configuring ERP-level delivery splits to automatically direct shipping requests to the correct warehouse database based on plant and stock availability. 3. Parallel master data replication: synchronizing material masters, business partners, customers, vendors, and other shared master data across SAP and third-party warehouse platforms. 4. Dual inventory reconciliation: designing nightly background processes to automatically compare S/4HANA ERP accounting books against external non-SAP physical balances. 5. Legacy middleware message mapping: re-engineering existing IDOC or RFC mappings that must continue communicating with S/4HANA ERP during the transitional rollout phases. 6. Customs bonded transit isolation, coordinating duty, unpaid stock transfers between EWM managed and third-party managed warehouse buildings.
Typical hybrid landscape and integration complexities.
Experienced architects audit the legacy landscape and external interfaces for the following unmapped integration complexities during the discover phase. 7. Cross-warehouse stock transport orders, managing STOs where the issuing warehouse is on EWM and the receiving warehouse is on a legacy non-SAP platform. 8. Cross-system operational reporting, consolidating warehouse productivity, inventory, throughput, and operational KPIs across SAP EWM and third-party WMS platforms. 9. Co-mingled yard and staging logistics, physical shipping yards where trailers must be dynamically dispatched to both EWM and legacy managed dock doors. 10. Global trade services customs validation, enforcing export controls and legal compliance checks uniformly across hybrid system boundaries. 11. Exception handling across hybrid landscapes, managing failed interface messages, manual recovery procedures, and cross-system error handling during coexistence. Key insight. A phased rollout means managing a hybrid system. Auditing these non-SAP dependencies during discover prevents your S/4HANA ERP from losing connection with legacy sites on day one.
Migration incident analysis and root cause why this happens.
Failing to scope third-party and hybrid dependencies typically stems from the following root causes. 1. IT scoping sessions assume a single-step big bang go live, ignoring the physical necessity of transitional rollout phases. 2. An inaccurate assumption that because a warehouse runs on non-SAP software, it has no impact on the S/4HANA core ERP design. 3. A complete failure to inventory and audit active legacy middleware message mappings and custom interface points. 4. Overlooking the complexity of parallel master data distribution across mixed SAP and non-SAP databases during transition. 5. Lack of early involvement from integration architects who understand the transactional boundaries between ERP, EWM, and third-party systems. 6. Migration planning assumes all warehouses follow the same rollout timeline, without validating business, contractual, or regional deployment constraints.
Business, program, and operational impact.
Omitting legacy WMS and hybrid landscape dependencies introduces critical risks across the project landscape. 1. Customer service. Customer deliveries are delayed because outbound orders cannot be routed correctly across hybrid warehouse environments. Program impact. Severe project stalls during the realize phase as the team is forced to build unplanned, complex middleware mapping configurations to support legacy system coexistence. 2. Warehouse impact. Physical gridlock at the shipping docks as S/4HANA ERP cannot logically replicate delivery requests to legacy non-SAP warehouse systems, halting outbound truck departures. 3. Operational KPIs affected. Nightly stock reconciliation cycle times degrade, interface message failure rates spike, shipping dock utilization rates decline, and overall data synchronization accuracy drops.
Governance and accountability.
We establish clear governance boundaries to manage the hybrid integration and landscape scope. 1. Decision owner. Lead integration architect and enterprise solution architect, jointly accountable for designing the transitional multi-WMS architecture. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed delivery routing and parallel master data maps. 3. Business sponsor. Logistics IT Director, responsible for providing a complete inventory of all active third-party warehouse systems. 4. Supporting teams. Middleware team, S/4HANA ERP Delivery Lead, third-party system operators and enterprise integration platform lead, or middleware platform owner, especially where SAP Integration Suite, PIPO, MuleSoft, or other middleware platforms are involved.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your hybrid boundaries. 1. Execute a comprehensive audit of all active non-SAP warehouse management systems, legacy interfaces, and middleware mappings. 2. Design a formal transitional architecture map outlining how ERP and multiple WMS systems will coexist during rollout phases. 3. Involve corporate integration specialists and legacy system leads directly in early fit to standard scoping workshops. 4. Formally evaluate the technical and operational feasibility of S/4HANA parallel master data replication to support legacy databases. 5. Identify coexistence timelines and define clear entry and exit criteria for each warehouse transitioning from the legacy WMS to SAP EWM.
EWM, Hybrid Landscape Deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Hybrid Landscape Integration Blueprint, a technical architecture document outlining the complete mapping of ERP, EWM, and legacy third-party non-SAP systems. 2. Multi-WMS Delivery Routing Matrix, a logical design document defining how S/4HANA ERP splits and routes deliveries based on plant, storage location, and WMS type. 3. Parallel Master Data Synchronization Map, a standardized document outlining business partner, material master, and customer replication rules across legacy databases. 4. Transitional Dual Inventory Reconciliation Procedure, a validated design document outlining automated, cross-system audit controls and variance reporting runs. Key takeaway: these landscape deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and routing errors.
Landscape Sourcing and Integration KPIs.
We track the following critical indicators to manage hybrid landscape risks during the early project phases. 1. Hybrid Landscape Standardization Index, the target percentage of warehouses running on standard S/4HANA EWM versus legacy non-SAP platforms. 2. Interface Message Mapping Coverage, a metric verifying that all legacy third-party interfaces are documented and budgeted for conversion. 3. Dual Inventory Reconciliation Accuracy, the target precision matching required between ERP stock balances and external non-SAP database balances. 4. Transitional Interface Performance Rating, the estimated daily API or IDOC message volumes required to support the hybrid landscape during transition. 5. Hybrid Interface Success Rate, percentage of successful cross-system transactions processed without manual intervention. Key takeaway: quantifying landscape scope metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a hybrid warehouse landscape in S/4HANA, and why does excluding third-party WMS dependencies during discover ruin its design?
Answer: a hybrid warehouse landscape operates on multiple warehouse systems such as EWM, legacy LEWM, and non-SAP systems simultaneously. If third-party WMS dependencies are excluded during discover, S/4HANA ERP will be designed without multi-WMS split delivery routing or parallel master data pipelines. When go-live occurs, the ERP cannot logically route shipments to the legacy sites, completely halting operations.
Follow-up 2. How do you identify hidden legacy, non-SAP WMS integration dependencies during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical operational interviews with shipping leads, dispatchers, and system administrators. I track physical gate movements, carrier integration workflows, and manual paper-based dispatch records. I then audit active legacy middleware message mappings to identify unmapped systemic flows.
Follow-up 3 Curveball. What do you do when a project sponsor demands a single-step Big Bang go-live to save budget, but your EWM assessment shows they must support legacy third-party WMS integrations during transition?
Answer: I do not argue the point conceptually. Instead, I present a process impact document showing standard ERP behavior if they attempt to cut over 40 complex warehouses simultaneously on day 1. I explain that a forced Big Bang go-live will drop daily shipping throughput, create severe data synchronization bottlenecks, and create widespread interface failures, reconciliation issues, and operational disruption across multiple warehouse sites. I demonstrate standard, multi-WMS split routing logic, showing how it secures transitional warehouse operations.
Governance takeaway for this migration incident 20.
Ignoring third-party WMS and legacy warehouse dependencies during Discover is a severe governance failure. Always establish your technical split delivery routing, parallel master data, and dual inventory reconciliation boundaries during the initial landscape discovery to prevent operational disruption, inventory synchronization failures, and costly redesign during phased rollout.
Category 3. Warehouse Landscape Discovery Conclusion.
To summarize Category 3, mapping your enterprise landscape boundaries is a foundational architecture gate. Failing to identify satellite warehouses, off-site overflow yards, cross-warehouse stock transfer routes, or hybrid legacy systems running on non-SAP platforms will cause critical disruptions. If these systemic boundaries are drawn incorrectly during the Discover phase, your S/4HANA enterprise structure design will fail to support physical operational realities on day one.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 3 to Category 4.
With our physical warehouse locations, multi-site transfer routes, and legacy system boundaries fully defined, we must now drill down into the digital lifecycle of the data itself. A beautifully mapped landscape with perfect process flows will still fail if the underlying data is corrupt, inconsistent, or unarchived. We will now transition into Category 4, Master Data and Archiving Assessment, where we analyze the severe program risks of uncleaned master records, inconsistent packaging specifications, and ignored transaction volumes.
Category 4, Master Data and Archiving Assessment.
In S/4HANA EWM, master data and archiving are the true runtime engines of the system. While custom processes and layouts are designed in configuration, data quality determines execution performance. Category 4 analyzes the critical risks, spanning incomplete warehouse material attributes, duplicate customer and vendor business partners, inconsistent packaging specifications, unaligned handling unit ranges, differing batch or serial governance, and unarchived transaction histories that must be audited early in the discover phase.
Category 4, Master Data and Archiving Assessment Incidents 21 to 26.
To prevent technical conversion and runtime failures, a rigorous discover phase must audit and document these strategic data domains. Incident 21, Material Master Data Quality Assessment, reveals large numbers of incomplete warehouse-specific attributes. Incident 22, Business Partner Master Data contains duplicate records that will complicate Customer-Vendor Integration (CVI). Incident 23, Packaging Specification Data is found to be inconsistent across multiple warehouse locations. Incident 24, Handling Unit Numbering Standards differ between warehouses without any central governance. Incident 25, Batch and serial number management practices differ across business units and are not standardized. Incident 26, Data Volume and Archiving Strategy. Historical warehouse transaction volume and archiving needs are ignored, leading to unrealistic migration timelines or inflated HANA sizing. Let's dive into Incident 21.
Migration Incident 21, Material Master Data Quality Assessment, reveals large numbers of incomplete warehouse-specific attributes.
During the discover phase, the project team fails to perform a detailed audit of legacy material master data quality, assuming standard ERP material views are sufficient for S/4HANA EWM. EWM does not operate on basic plant or storage location views. It requires extending materials into a detailed warehouse product master. This master requires granular, warehouse-specific attributes like put-away control indicators, stock removal strategies, and precise alternative unit of measure conversions. Discovering massive gaps in these fields late in the project stalls technical conversions and breaks standard put-away and picking logic. Business objective: identify, audit, and document all missing warehouse-specific product attributes early in the migration lifecycle to prevent system-guided execution failures and capacity calculation crashes.
Incident Classification and Relevant SAP, note if applicable.
To establish clear parameters, we classify this master data discovery failure across the following strategic boundaries. 1. Complexity: high master data quality and conversion failure. 2. Frequency: extremely common in legacy ERP and LEWM migrations. 3. Business process: master data assessment and cleansing. 4. Warehouse area: entire warehouse operations and product master database. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM lead architect and master data lead. 8. Business ownership. Master data governance manager and program sponsor.
Typical warehouse product master gaps.
Experienced architects audit the legacy material database and physical packaging specifications for the following logical product master attributes during the discover phase. 1. Put away control indicator. Crucial for executing standard storage type search sequences and directing stock to correct logical storage types. 2. Stock removal control indicator. Mandatory for directing picking sequences, sorting stock, and optimizing operator travel paths. 3. Storage section indicator. Directs inbound stock to specific physical segments such as fast mover or slow mover zones within a storage type. 4. Storage bin type indicator. Restricts the physical material handling units to specific compatible bin dimensions and rack layouts. 5. Bulk storage indicator. Defines stacking limits, block storage parameters, and handling unit stacking rules. 6. Alternative unit of measure conversions. Mandatory for weight, volume, dimensions, and packaging hierarchy capacity checks during put away. 7. Preferred unit of measure. Dictates standard picking, replenishment, or physical inventory counting increments. 8. Cycle counting indicator. Determines the frequency of mandatory physical inventory audits based on material value or movement velocity. 9. Serial number profile. Controls strict traceability tracking levels from inbound goods receipt to final outbound shipping. 10. Batch management requirement indicator. Dictates whether shelf life expiration dates and quality statuses must be systematically tracked. 11. Warehouse process type determination group. Attributes influencing warehouse execution behavior and process determination. Key insight. The warehouse product master is the runtime engine of EWM. Auditing these logical attributes during discover prevents the standard process denial that derails the explore phase blueprint.
Migration incident analysis and root cause why this happens.
Failing to identify warehouse product master data gaps typically stems from the following root causes. 1. IT planning teams assume standard ERP material views are sufficient, completely ignoring EWM-specific product master extensions. 2. An inaccurate assumption that because a material is active in ERP, its physical dimensions and weight attributes are accurate. 3. Failing to conduct detailed master data audits of alternative units of measure and bulk stacking dimensions. 4. Underestimating the custom development and manual effort required to clean and enrich hundreds of thousands of material records. 5. Project budgets and vendor proposals are finalized using over simplified material master counts rather than actual operational quality audits. 6. Master data governance teams are not involved early enough to assess warehouse-specific data quality requirements.
Business, program, and operational impact.
Underestimating material master data complexity introduces critical risks across the project landscape. 1. Testing. Integration and warehouse process testing are delayed because warehouse product records cannot support standard execution scenarios. 2. Program impact. Immediate timeline slippage and budget overruns during the realize phase as the team is forced to build unplanned, complex data cleansing programs to support standard put-away and picking. 3. Warehouse impact. Standard put-away and picking strategies fail because EWM cannot logically resolve destination bins or calculate physical capacity, creating immediate congestion in receiving lanes. 4. Operational KPIs affected. Inbound dock to stock cycle times skyrocket, storage capacity utilization declines, receiving lane congestion rises, and overall warehouse labor productivity drops.
Governance and accountability.
We establish clear governance boundaries to manage the warehouse product master scope. 1. Decision owner. EWM solution architect and master data lead, jointly accountable for mapping legacy material attributes to standard EWM product masters. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed master data governance and cleansing plans. 3. Business Sponsor. Master Data Governance Manager, responsible for providing detailed material databases and physical packaging documentations. 4. Supporting teams. Inventory Control Specialists, Quality Assurance Lead, and Data Migration Lead.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your master data boundaries. 1. Execute a comprehensive physical audit of all active material master attributes, including alternative units of measure and bulk stacking dimensions. 2. Conduct structured data quality workshops involving corporate IT architects and both local master data stewards and warehouse operations SMEs. 3. Map legacy material master attributes against standard EWM product master capabilities, evaluating capacity check and replenishment models. 4. Formally evaluate the technical and operational feasibility of standardizing material master attributes to reduce the total number of unique process types.
EWM product master discovery deliverables.
A compliant discover phase must exit with the following concrete master data deliverables before starting the blueprint. 1. Warehouse Product Attribute Audit Report. A comprehensive document mapping actual physical material attributes to target EWM product master fields. 2. Master Data Cleansing and Enrichment Register. A detailed logical design blueprint outlining the data cleansing and enrichment plan for missing attributes. 3. Alternative Unit of Measure Validation Log. A validated document confirming unit of measure conversions, packaging hierarchies, dimensions, weights, and capacity-related attributes for all warehouse-managed materials. 4. Master Data Governance Framework Blueprint. A governance document defining ownership, data quality standards, stewardship responsibilities, enrichment processes, and approval workflows for warehouse product master data. Key takeaway: these master data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and data conversion delays.
Data complexity and quality KPIs.
We track the following critical indicators to manage master data risks during the early project phases. 1. EWM Attribute Completeness Rate. The target percentage of material master attributes planned to run on standard unmodified templates. 2. Alternative Unit of Measure Dimension Validation Rate. Percentage of warehouse-managed materials with validated unit of measure conversions, dimensions, weights, and packaging hierarchy. 3. Cleansing Backlog Burn Down Rate. The total number of planned material master attributes cleaned and enriched per month. 4. Warehouse Product Data Quality Score. Percentage of warehouse product records meeting mandatory EWM attribute completeness and validation rules. Key takeaway: quantifying master data complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a warehouse product master in EWM, and why does underestimating its complexity during Discover ruin the blueprint?
Answer: the warehouse product master is the core building block of the EWM warehouse, controlling physical behavior, put-away rules, picking strategies, and capacity checks. If you underestimate its complexity during Discover, the blueprint will stall. You will find that standard ERP material master views are completely insufficient for standard EWM warehouse process configurations, resulting in severe data conversion delays.
Follow-up 2. How do you identify hidden legacy warehouse material master complexities during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform a rigorous analysis of legacy material master datasets, review physical packaging specifications, and inspect warehouse engineering drawings. I also run structured workshops with warehouse SMEs to document legacy units of measure, special handling needs, and standard packaging dimensions.
Follow-up 3. Curveball. What do you do when the PMO insists on keeping the material master configuration simple to save budget, but your audit shows the business requires complex alternative units of measure and bulk stacking dimensions?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when standard alternative units of measure are omitted. I explain that forcing simple material master configurations onto complex physical processes will cause incorrect put-away decisions, failed capacity checks, inaccurate warehouse execution, and increased manual intervention. I ask them to choose between data-driven automation or heavy, post-go-live operational friction.
Governance takeaway for this migration incident 21.
Ignoring warehouse product master quality during Discover is a severe governance failure. Always establish complete warehouse product data, ownership, and governance standards before entering Explore to prevent conversion delays and warehouse execution failures.
Migration Incident 22. Business Partner Master Data contains duplicate records that will complicate customer-vendor integration.
During the Discover phase, the project team fails to assess the quality, duplication rate, and structural consistency of legacy customer and vendor master data. S/4HANA mandates the customer-vendor integration process, converting all legacy records into unified business partners. Business partners represent customers, vendors, carriers, and other logistics partners through standardized BP roles, making early data quality assessment essential. EWM relies heavily on business partners to execute core warehouse transactions. Failing to resolve duplicate records and overlapping number ranges during Discover guarantees major CVI conversion blockages and fatal delivery replication errors during later phases. Business objective: identify, analyze, and resolve legacy, customer and vendor master data duplicates early to ensure a flawless customer-vendor integration process that supports EWM transaction execution.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this master data discovery failure across the following strategic boundaries. 1. Complexity: high master data quality and commercial integration failure. 2. Frequency: very common in S/4HANA business partner conversions. 3. Business process: customer-vendor integration planning and cleansing. 4. Business scope: enterprise business partner master data supporting EWM procurement, sales, and logistics. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: master data lead and enterprise solution architect. 8. Business ownership: master data governance manager and program sponsor.
The business partner conversion flow.
We trace the architectural journey of legacy master records through the customer-vendor integration engine. 1. Legacy customer and vendor masters. Legacy systems store customer and supplier accounts in separate unlinked database tables. 2. Customer-vendor integration engine. S/4HANA technical mapping layer executing strict duplicate checks, address validations, and role mappings. 3. Standardized business partner. The CVI engine consolidates legacy records into a single, unified business partner record. 4. SAP EWM transactional deliveries. Standardized business partners successfully replicate, enabling inbound receipts and outbound shipments to process without error.
The business partner data quality matrix.
A rigorous Discover phase must map the target data quality boundaries across these 4 critical areas. 1. Mandatory address attributes. Target status: :*0 blank postal codes or invalid country keys. Owner: :master data stewards. Action: :validate and enrich legacy fields. 2. Business partner role assignments. Target status: :complete, consistent assignment of supplier, customer, and carrier roles. Owner: sales and procurement SMEs. Action: map and verify roles. 3. Overlapping number ranges. Target status: :0 numeric mapping collisions across tables during conversion. Owner: lead integration architect. Action: configure target grouping rules. 4. Contact person relationships. Target status: all customer and supplier contact relationships correctly linked. Owner: business process owners. Action: relink and consolidate databases.
The CVI readiness assessment journey.
We execute the following sequential stages during the Discover phase to secure our technical conversion path. 1. Legacy data profiling. Extracting and auditing legacy customer and vendor records to discover structural gaps and missing fields. 2. Deduplication and merge runs. Running technical algorithms to locate and merge active duplicate records. 3. Standardization and cleansing. Reformatting address fields, country codes, and communication keys to meet S/4HANA standards. 4. Pre-conversion validation checks. Running standard SAP validation reports to simulate the technical conversion on sandbox environments. 5. Business partner activation. Finalizing standard unified business partners to ensure day one transactional readiness.
Typical customer-vendor integration gaps.
Experienced architects audit the legacy customer and vendor databases for the following critical integration complexities during the discover phase. 1. Overlapping number ranges. Customers and vendors sharing identical numeric identifiers, creating mapping collisions during business partner conversion. 2. Duplicate customer and vendor masters. The same physical supplier or customer registered multiple times in the system with minor name or address variations. 3. Missing business partner roles. Required BP roles including supplier, customer, carrier, and ship to party are incomplete or inconsistently assigned. 4. Broken contact relationships. Customer and supplier contact person relationships are incomplete or incorrectly linked in the legacy system. 5. Inconsistent address formats. Missing mandatory postal codes, invalid country keys, or incomplete city fields, violating standard business partner validation rules. 6. Missing tax and tax classification data. Tax identifiers required for business partner registration are missing or unvalidated in the legacy system. 7. Obsolete and inactive records. Thousands of dead customer and vendor accounts still flagged as active, bloating the conversion scope. 8. Missing carrier and LSP master data. Shipping carriers and third-party logistics partners lack proper vendor roles in ERP, blocking EWM shipping integration. 9. Language key omissions. Missing mandatory communication language keys blocking business partner activation and transaction processing. 10. One-time customer and vendor accounts. Bulk dummy accounts that require specialized integration mapping rules to avoid data corruption. Key insight. Business partners are the transactional lifeblood of EWM. Auditing these logical attributes during discover prevents the delivery replication failures that freeze your receiving docs.
Migration incident analysis and root cause why this happens.
Failing to identify customer-vendor integration duplicates typically stems from the following root causes. 1. IT planning teams treat CVI as a purely financial or technical conversion step, completely ignoring EWM transactional dependencies. 2. An inaccurate assumption that because customer and vendor records are active in ERP, they are cleansed and formatted properly for business partner mapping. 3. Master data governance teams are not engaged early enough to define business partner standards and duplicate resolution policies. 4. Failing to conduct detailed master data quality audits of legacy number ranges, address formats, and duplicate records during discover. 5. Underestimating the custom development and manual effort required to clean, merge, and archive thousands of duplicate partner records.
Business, program, and operational impact.
Underestimating business partner master data complexity introduces critical risks across the project landscape. 1. Program impact. Immediate timeline slippage and budget overruns during the realize phase as the team is forced to build unplanned, complex data cleansing programs to support standard CVI mapping. Furthermore, integration testing is delayed because duplicate business partners prevent consistent delivery, procurement, and warehouse transaction processing. 2. Warehouse impact. Standard inbound and outbound deliveries fail to replicate to EWM because S/4HANA cannot correctly determine or replicate required business partners, creating immediate congestion on the physical warehouse floor. 3. Operational KPIs affected. Inbound goods receipt cycle times skyrocket, carrier assignment speed drops, shipping dock utilization rates decline, and overall warehouse labor productivity drops.
Governance and accountability.
We establish clear governance boundaries to manage the business partner master data scope. 1. Decision owner. Master data lead and enterprise solution architect, jointly accountable for mapping legacy customer and vendor attributes to standard S/4HANA business partners. 2. Review board. Enterprise architecture review board, responsible for auditing the proposed CVI mapping, numbering, and cleansing plans. 3. Business sponsor. Master data governance manager, responsible for providing detailed supplier and customer databases and physical carrier documentations. 4. Supporting teams. Data migration lead, MDG team, Sales Master Data team, and Procurement Master Data team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your master data boundaries. 1. Execute a comprehensive physical audit of all active customer and vendor attributes, including carrier records and third-party logistics partners. 2. Conduct structured data quality workshops involving both corporate IT architects and master data stewards, sales operations, procurement SMEs, and logistics SMEs. 3. Map legacy customer and vendor attributes against standard S/4HANA business partner roles, account groups, and CVI mapping rules. 4. Formally evaluate the technical and operational feasibility of standardizing customer and vendor attributes to reduce duplicate business partner records, standardize BP roles, and simplify customer-vendor integration.
Business partner discovery deliverables.
A compliant discover phase must exit with the following concrete master data deliverables before starting the blueprint. 1. CVI Readiness and Duplicate Assessment Report. A comprehensive document mapping actual physical master data quality and duplicate records across customer and vendor databases. 2. Master Data Cleansing and Merge Register. A detailed logical design blueprint outlining the data cleansing, merging, and archiving plan for duplicate records. 3. S/4HANA Business Partner Numbering and Role Blueprint. A validated architecture document outlining target business partner number ranges, grouping structures, and operational roles. 4. CVI Mapping and Configuration Specification. A detailed configuration document defining BP grouping, number ranges, role assignments, CVI mappings, validation rules, and pre-conversion checks. Key takeaway: these master data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and data conversion delays.
Data complexity and quality KPIs.
We track the following critical indicators to manage master data risks during the early project phases. 1. Customer and Vendor Data Quality Index. The target percentage of master data records planned to run on standard unmodified templates. 2. Business Partner Duplicate Rate. Percentage of duplicate customer and vendor records identified before CVI conversion. 3. CVI Cleansing Backlog Burn Down Rate. The total number of planned customer and vendor master data attributes cleaned and enriched per month. 4. CVI Pre-Conversion Validation Error Rate. Number of business partner validation errors identified during pre-conversion checks. Key takeaway: quantifying master data complexity metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is customer-vendor integration in S/4HANA, and why does underestimating its complexity during discover ruin the EWM blueprint?
Answer: customer-vendor integration, or CVI, is the S/4HANA technical process that converts legacy customer and vendor records into unified business partners. EWM relies completely on business partners for delivery processing, carrier assignments, and shipping execution. If CVI is underestimated during discover, duplicate records and overlapping ranges will cause delivery replication to fail, freezing your receiving and shipping docs.
Follow-up 2. How do you identify legacy, customer, and vendor duplicate complexities during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform a deep dive data profiling audit of legacy customer and vendor databases using master data analysis tools. I run structured workshops with master data stewards, procurement SMEs, sales operations, logistics SMEs, and warehouse SMEs to identify redundant carrier records, missing tax classifications, and inconsistent address formats.
Follow-up 3 curveball. What do you do when the PMO insists on bypassing master data cleansing to save budget, but your audit shows the business has massive customer and vendor duplications?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when CVI validation fails. I explain that forcing dirty master data into S/4HANA will cause incorrect warehouse staging, failed delivery replications, inaccurate transactional execution, and a complete halt at the physical shipping docks. I ask them to choose between standard business partner governance, or Costly post-conversion remediation.
Governance takeaway for this migration incident 22.
Ignoring business partner data quality and customer-vendor integration readiness during discover is a severe governance failure. Always establish business partner governance, duplicate resolution, and CVI validation standards before entering Explore to prevent conversion failures and downstream transactional issues.
Migration incident 23. Packaging specification data is found to be inconsistent across multiple warehouse locations.
During the discover phase, the project team assumes that product packaging and palletization standards are identical across the warehouse network, failing to audit the consistency of legacy packaging specification data. EWM uses packaging specifications as a highly structured, multi-level master data engine to drive physical execution, including automated cartonization, deconsolidation routing, and storage bin capacity checks. Discovering that different distribution centers use inconsistent pallet heights, box dimensions, or alternate nesting structures late in the project causes massive process failures and system blockages. Business objective: identify, audit, and document all multi-site packaging specification variations early in the discover phase to establish a standardized global packaging model.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this master data discovery failure across the following strategic boundaries. 1. Complexity: high multi-site master data inconsistency. 2. Frequency: very common in multi-warehouse legacy environments. 3. Business process: packaging specification audit and standardization. 4. Warehouse area: packing stations, deconsolidation work centers, and storage bins. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: EWM lead architect and master data lead. 8. Business ownership: warehouse operations managers and global logistics director.
Typical packaging specification discrepancies.
Experienced architects audit the legacy warehouse databases and physical operations for the following critical packaging discrepancies during the discover phase. 1. Inconsistent nesting hierarchies: one distribution center defining packing levels as eaches to cartons to pallets, while another uses eaches to pallets directly, causing storage control routing failures. 2. Discrepant physical dimensions: minor variances in documented pallet heights or box dimensions across locations leading to failed bin capacity checks during put away. 3. Unstandardized auxiliary packaging materials: different warehouses using varied cardboard boxes, shrink wraps, or plastic bins without a unified packaging material master. 4. Missing minimum and maximum pack quantities: out-of-bounds packing rules leading to unstable pallet builds and picking task fragmentation. 5. Localized customer-specific packing rules: high-value customers requiring custom, undocumented labels or packing arrangements that are not reflected in standard global templates. 6. Obsolete packaging instruction statuses: legacy packing instructions still flagged as active in ERP but physically abandoned by operators on the floor. 7. Unmapped kitting specifications: value-added service kitting instructions that are managed entirely via tribal knowledge instead of system master data. 8. Varying weight and volume tolerances: differences in physical scale tolerances across locations causing weight verification blocks at the pack stations. 9. Systemic unit of measure conflicts: conflicting base or alternative units of measure preventing unified packaging specification replication. 10. Manual off-system packaging bypasses: operators create undocumented packaging structures outside standard packaging specifications to satisfy urgent operational requirements. 11. Inconsistent handling unit types: different warehouse locations define pallets, cartons, and reusable containers differently, creating inconsistent packaging execution. Key insight: packaging specifications are the silent backbone of automated warehouses. Auditing these physical variances during discover prevents standard process denial during the blueprint phase.
Migration incident analysis and root cause why this happens.
Failing to identify packaging specification inconsistencies typically stems from the following root causes. 1. IT planning teams assume standard ERP packing instructions are clean and consistent across all locations. 2. An inaccurate assumption that because a product uses standard boxes, all distribution centers share identical packing heights and nesting rules. 3. Failing to conduct detailed master data quality audits of legacy units of measure and physical packing dimensions. 4. Underestimating the custom development and manual effort required to clean and consolidate packaging specifications for multiple warehouses. 5. Excluding local packaging supervisors, industrial engineers, and work center leads from early discover workshops. 6. Global packaging governance standards do not exist, allowing each warehouse to independently maintain packaging specifications.
Business, program, and operational impact.
Underestimating packaging specification complexity introduces critical risks across the project landscape. 1. Testing. Packaging process testing expands significantly because inconsistent packaging specifications require multiple site-specific validation scenarios. 2. Program impact. Immediate timeline delays and budget overruns during the realize phase as the team is forced to build unplanned, complex data cleansing programs to support standard storage control and cartonization. 3. Warehouse impact. Standard deconsolidation, cartonization, and put-away strategies fail because EWM cannot logically resolve packing hierarchies, creating immediate congestion in receiving and packing lanes. 4. Operational KPIs affected. Inbound goods receipt cycle times skyrocket, picking productivity drops due to poor cartonization. Packing station utilization rates decline, and overall warehouse labor productivity drops.
Governance and accountability.
We establish clear governance boundaries to manage the packaging specification master data scope. 1. Decision owner, EWM solution architect and master data lead, jointly accountable for designing the global packaging specification template and standard exceptions. 2. Review board, enterprise architecture review board, responsible for auditing proposed packaging specifications against regional safety and operational standards. 3. Business sponsor, global logistics director, responsible for resolving process standardization disputes across different distribution centers. 4. Supporting teams, warehouse managers from all major sites, packaging engineers, and master data stewards.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your packaging specification boundaries. 1. Execute a comprehensive audit of all active legacy packing instructions, packaging materials, and physical box or pallet dimensions. 2. Conduct structured data quality workshops involving both corporate IT architects and local warehouse packaging supervisors. 3. Map legacy packaging hierarchies against standard EWM packaging specification capabilities, evaluating cartonization and deconsolidation models. 4. Formally evaluate the technical and operational feasibility of standardizing packaging materials to standardize packaging materials, nesting hierarchies, and packaging specifications across warehouse locations.
EWM packaging specification, discovery deliverables.
A compliant discover phase must exit with the following concrete master data deliverables before starting the blueprint. 1. Multi-site packaging specification audit report. A comprehensive document mapping actual physical packaging nesting hierarchies, dimensions, and variances across all warehouse locations. 2. Global Packaging Specification Governance Blueprint. A detailed logical design blueprint standardizing packaging material codes, levels, and authorization workflows. 3. Localized Exception Packaging Catalog. A validated architecture document outlining required local packing rules for specific distribution centers or high-value customers. 4. EWM Packaging Specification Migration Specification. A detailed migration specification defining packaging specification mappings, determination procedures, packaging material relationships, validation rules, and conversion strategy. Key takeaway. These master data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and data conversion delays.
Data complexity and quality KPIs.
We track the following critical indicators to manage master data risks during the early project phases. 1. Packaging Specification Standardization Index. The target percentage of warehouse products planned to run on standard, unmodified global packaging specifications. 2. Multi-site packaging dimension variance, a metric tracking the discrepancy rates in documented box or pallet dimensions across locations. 3. Pack spec migration cleansing backlog, the total number of legacy packing instructions requiring cleansing, formatting, or enrichment. 4. Packaging specification readiness rate, percentage of warehouse products with validated packaging specifications supporting standard cartonization, deconsolidation, and warehouse execution. Key takeaway: quantifying master data complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a packaging specification in EWM, and why does underestimating its complexity during Discover ruin the blueprint?
Answer: the packaging specification is a critical master data object in EWM that describes how a product should be physically packed. It controls automated cartonization, deconsolidation routing, and storage bin capacity checks. If you underestimate its complexity during Discover, the blueprint will stall. You will find that standard ERP packing instructions are completely insufficient for standard EWM warehouse process configurations, resulting in severe data conversion delays.
Follow-up 2. How do you identify hidden legacy, warehouse packaging specification complexities during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform a rigorous analysis of legacy packaging instructions and packaging material masters, and conduct physical packaging observations of current pallet configurations on the floor. I also run structured workshops with packaging engineers and warehouse SMEs to map out actual operational packaging workflows.
Follow-up 3. Curveball. What do you do when the PMO insists on keeping the packaging specification configuration simple to save budget, but your audit shows the business requires complex packing processes?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when standard packaging specifications are omitted. I explain that forcing simplified packaging specifications onto complex physical processes will cause failed cartonization planning, broken nesting hierarchies, incorrect packaging materials usage, and highly inefficient packing execution. I ask them to choose between system-guided automation or heavy, post-go-live manual workarounds.
Governance takeaway for this migration incident 23.
Ignoring packaging specification consistency during Discover is a severe governance failure. Always establish standardized packaging specifications, packaging material governance, and site-specific exception handling before entering Explore to prevent warehouse execution failures and costly redesign.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 24. Handling unit numbering standards differ between warehouses without any central governance.
During the discover phase, the project team assumes that handling unit numbering can be managed locally by each individual site, failing to establish central numbering governance across the warehouse network. Handling units act as the digital license plates of EWM, tracking physical packages and their contents. If different distribution centers maintain uncoordinated, overlapping internal or external number ranges, stock transport movements between warehouses will trigger duplicate handling unit identification conflicts, completely locking inventory in transit and halting receiving operations. Business objective. Establish a centralized handling unit numbering governance framework during the discover phase to prevent database collisions and secure cross-warehouse transit inventory flows.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this master data discovery failure across the following strategic boundaries. 1. Complexity. High multi-site master data and integration failure. 2. Frequency. Very common in multi-warehouse legacy environments. 3. Business process. Handling unit master data and numbering governance. 4. Business scope. Enterprise handling unit management, packaging operations, and cross-warehouse logistics. 5. EWM deployment type. Not yet decided. 6. Immediate business priority. High. 7. Primary ownership. Lead integration architect and EWM lead architect. 8. Business ownership. Warehouse operations managers and logistics director.
Typical handling unit, numbering discrepancies.
Experienced architects audit the legacy warehouse databases and physical barcodes for the following critical numbering discrepancies during the discover phase. 1. Overlapping internal number ranges. Different warehouses generating identical sequential identifiers, causing immediate database collisions during cross-warehouse transfers. 2. Unstandardized GS1 and SSCC structures. Variations in global packaging numbering structures, such as differing company prefixes or extension digits across sites. 3. Varying character lengths. Some locations using 10-digit alphanumeric keys, while others use standard 18-digit formats, breaking mobile scanning profiles. 4. External vendor number overlaps. Inbound vendor packages arriving with duplicate identifiers because vendor number ranges are not validated or partitioned. 5. Lack of central number range server. Decentralized system, landscapes maintaining independent, uncoordinated local numbering tables. 6. Custom SSCC generation exits. Undocumented legacy, a BAP user exits generating custom barcodes that violate standard global formats. 7. Unmapped multi-pack packaging levels. Nested packages such as a box inside a box on a pallet, having unaligned or overlapping internal serial identifiers. 8. Reused handling unit number cycles. Local numbering cycles that are too short, causing the system to reuse identifiers before they have been archived. 9. Systemic barcode prefix mismatches. Differing warehouse mobile scanner configurations, failing to parse non-standard local packaging barcodes. 10. Manual off-system labeling workarounds. Operators physically printing and applying duplicate dummy labels to resolve system blocks on the floor. 11. Inconsistent handling unit type definitions. Different warehouses assign identical number ranges to different HU types cartons, pallets, reusable containers, creating identification ambiguity during cross-site operations. Key insight: the handling unit is the logical passport of your inventory. Auditing these physical and structural numbering variances during discover prevents transactional blocks during cross-warehouse transfers.
Migration incident analysis and root cause why this happens.
Failing to identify handling unit numbering inconsistencies typically stems from the following root causes. 1. IT planning teams treat handling unit numbering as a local, site-specific configuration step, completely ignoring transit dependencies. 2. An inaccurate assumption that because a warehouse runs on standard barcodes, all distribution centers share identical numbering lengths and formats. 3. Failing to conduct detailed master data quality audits of legacy, sequential ranges, and global company prefixes. 4. Underestimating the custom development and coordination effort required to establish a centralized numbering server across different systems. 5. Excluding local inventory controllers, transport planners, and shipping leads from early discover workshops. 6. Enterprise-wide handling unit numbering standards and ownership are never formally defined, allowing each warehouse to implement independent numbering strategies.
Business, program, and operational impact.
Underestimating handling unit numbering complexity introduces critical risks across the project landscape. 1. Integration testing. Integration testing expands significantly because duplicate handling unit identifiers generate inconsistent results across warehouse interfaces and stock transfer scenarios. 2. Program impact. Immediate timeline delays and budget overruns during the realize phase, as the team is forced to rebuild uncoordinated number range configurations and redesign stock transport interfaces. 3. Warehouse impact. Physical gridlock at the receiving docks as inbound trucks are blocked because EWM rejects standard transfer scans due to duplicate database identifiers. 4. Operational KPIs affected. Inbound goods receipt cycle times skyrocket. Outbound picking productivity drops due to manual relabeling. Receiving lane congestion rises, and overall inventory accuracy drops.
Governance and accountability.
Establish clear governance boundaries to manage the handling unit numbering master data scope. 1. Decision owner. Lead integration architect and EWM lead architect, jointly accountable for designing the global handling unit numbering structure and standards. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed numbering ranges against GS1 and regional corporate standards. 3. Business sponsor. Global Logistics Director, responsible for resolving process standardization disputes across different distribution centers. 4. Supporting teams. Warehouse managers from all major sites, master data stewards, and master data governance team or integration team or warehouse operations SMEs.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your numbering boundaries. 1. Execute a comprehensive physical audit of all active legacy handling unit barcode labels, sequential ranges, and vendor-provided packaging tags. 2. Conduct structured data quality workshops involving both corporate integration architects and local warehouse shipping supervisors. 3. Map legacy numbering structures against standard GS1 and SSCC formatting capabilities, evaluating global company prefix assignments. 4. Formally evaluate the technical and operational feasibility of implementing a centralized number range server to prevent multi-site collisions.
EWM HU discovery deliverables.
A compliant discover phase must exit with the following concrete master data deliverables before starting the blueprint. 1. Multi-site handling unit numbering audit report. A comprehensive document mapping all active, legacy, internal and external numbering structures and ranges across all locations. 2. Global GS1 and SSCC numbering standard specification. A detailed logical design blueprint defining a globally unique packaging numbering hierarchy and barcode format. 3. Cross-warehouse transfer inventory flow blueprint. A validated architecture document outlining transaction validation rules to prevent numbering collisions during stock transfers. 4. Central EWM Number Range Governance Charter, a formally signed document outlining the ongoing maintenance, allocation procedures, and ownership of global numbering tables. Key takeaway: these master data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and database reconciliation delays.
Sourcing and capability KPIs.
We track the following critical indicators to manage master data risks during the early project phases. 1. Global handling unit standardization rate. The target percentage of warehouse locations planned to run on a unified, standard GS1 SSCC framework. 2. Multi-site number range overlap index. A metric measuring the collision risk across current active internal and external numbering tables. 3. Barcode scanning compatibility score. A quantitative rating of the percentage of legacy label formats compatible with standard mobile scanning profiles. 4. Handling unit identifier reuse period. The minimum retention period before archived handling unit identifiers become eligible for reuse. Key takeaway: quantifying master data complexity metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a handling unit in EWM, and why does underestimating its numbering complexity during discover ruin the blueprint?
Answer: the handling unit is the core transactional passport in EWM, tracking physical packages and their contained inventory. If you underestimate its numbering complexity during discover, the blueprint will stall. You will find that uncoordinated local ranges across warehouses will cause stock transport orders to fail with duplicate ID errors, freezing your shipping and receiving docks.
Follow-up 2. How do you identify hidden legacy warehouse handling unit numbering complexities during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform a rigorous analysis of legacy sequential number range tables, review physical shipping label specifications, and inspect barcode scanning configurations. I also run structured workshops with shipping supervisors and master data SMEs to map out actual operational printing and vendor receiving workflows.
Follow-up 3 curveball. What do you do when the PMO insists on keeping the handling unit numbering simple to save budget, but your audit shows the business has massive multi-site numbering overlaps?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when stock transport receiving scans fail. I explain that forcing simplified local numbering profiles onto multi-site operations will cause database collisions, failed inbound delivery confirmations, inaccurate warehouse inventory tracking, and highly inefficient manual relabeling workarounds. I ask them to choose between enterprise standard HU governance and costly post-go-live operational workarounds.
Governance takeaway for this migration incident 24.
Ignoring enterprise handling unit numbering governance during discover is a severe governance failure. Always establish globally unique numbering standards, ownership, and lifecycle management before entering explore to prevent cross-warehouse identification conflicts and transaction failures.
Migration incident 25. Batch and serial number management practices differ across business units and are not standardized.
During the discover phase, the project team assumes that batch and serial number management can be managed locally by each individual business unit, failing to establish central traceability governance across the organization. Batch and serial number management directly influences warehouse traceability, scanning requirements, inventory control, and regulatory compliance and picking logic inside EWM. If different business units maintain uncoordinated, unstandardized serialization profiles and batch classification rules, cross-warehouse transfers will fail, floor operators will face severe scanning bottlenecks, and legal regulatory audits will be compromised. Business objective: establish a centralized batch and serial number governance framework during the discover phase to prevent transaction blocks and secure cross-warehouse traceability flows.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this master data discovery failure across the following strategic boundaries. 1. Complexity: high multi-site master data and regulatory traceability failure. 2. Frequency: very common in multi-business unit S4 HANA transformations. 3. Business process: batch and serial number master data governance. 4. Business scope: enterprise traceability, warehouse operations, product master data, and quality management. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: lead integration architect and EWM lead architect. 8. Business ownership: warehouse operations managers and quality assurance director.
Typical batch and serial number discrepancies.
Experienced architects audit the legacy warehouse databases and physical barcodes for the following critical numbering discrepancies during the discover phase. 1. Inconsistent batch creation rules: some business units generating internal batch numbers at goods receipt, while others reuse the supplier batch directly. 2. Varying serial number profiles: different sites enforcing serial numbers in stock requiring bin-level scans versus standard document item-level tracking. 3. Unaligned batch classification fields: missing or unstandardized batch characteristics such as manufacturing country or expiration dates across databases. 4. Differing expiration date rules: discrepant shelf life calculations and first expired first out picking strategies across warehouse layouts. 5. Unmapped split batch putaways: lack of standard rules governing whether multiple batches of the same material can occupy a single storage bin. 6. Legacy serial number screen exits: undocumented legacy RF customizations bypassing standard serial number scans during packing or shipping. 7. Manual batch status overrides: local supervisors manually changing restricted and unrestricted batch statuses on paper without system replication. 8. Barcode scan format conflicts: differing handheld scanner configurations failing to parse merged batch and serial barcodes on the floor. 9. Uncoordinated serial number ranges: independent warehouses generating duplicate serial ranges, causing collisions during stock transfers. 10. Legacy traceability reports: highly customized, unmapped Z programs used to generate regulatory audit reports for external compliance agencies. 11. Inconsistent batch determination rules: different business units use different batch determination strategies, resulting in inconsistent batch selection during picking and outbound processing. Key insight: batch and serial numbers dictate the physical scanning workload on your floor. Auditing these rules during discover prevents manual workarounds and scanning gridlock at go live.
Migration incident analysis and root cause why this happens.
Failing to identify batch and serial number inconsistencies typically stems from the following root causes. 1. IT planning teams treat serialization and batching as standard master data fields, completely ignoring physical execution and scanning workloads. 2. An inaccurate assumption that because a product is batched, All business units share identical batch status and shelf life tracking rules. 3. Failing to conduct detailed master data quality audits of legacy serial number profiles and active batch classification characteristics. 4. Underestimating the custom development and change management effort required to establish a centralized serial number hierarchy across different systems. 5. Excluding local quality controllers, shift supervisors, and inventory audit teams from early discover workshops. 6. Enterprise traceability governance and serialization standards are never formally defined across business units before migration planning begins.
Business, program, and operational impact.
Underestimating batch and serial number complexity introduces critical risks across the project landscape. 1. Validation testing. Regulatory validation and traceability testing expand significantly because inconsistent serialization and batch rules require additional business unit-specific scenarios. 2. Program impact. Immediate timeline delays and budget overruns during the realize phase, as the team is forced to rebuild uncoordinated serial number profiles and redesign batch replication interfaces. 3. Warehouse impact. Physical gridlock at the shipping and packing stations, as EWM rejects standard picking scans due to mismatched batch characteristics or missing serial numbers. 4. Operational KPIs affected. Outbound picking cycle times increase, shipping accuracy degrades, receiving lane congestion rises, and overall warehouse labor productivity drops.
Governance and accountability.
We establish clear governance boundaries to manage the batch and serial numbering master data scope. 1. Decision owner, lead integration architect and EWM lead architect, jointly accountable for designing the global serialization and batching structure. 2. Review board, enterprise architecture review board, responsible for auditing proposed numbering ranges against regional regulatory standards. 3. Business sponsor, global quality assurance director, responsible for resolving process standardization disputes across different business units. 4. Supporting teams, warehouse managers from all major sites, master data stewards and quality assurance team or master data governance team or regulatory compliance team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your traceability boundaries. 1. Execute a comprehensive physical audit of all active legacy batch classifications, serial number profiles, and barcode label formats. 2. Conduct structured data quality workshops involving both corporate integration architects and local warehouse inventory managers. 3. Map legacy numbering structures against standard EWM serialization capabilities, evaluating the physical scanning impact of stock level tracking. 4. Formally evaluate the technical and operational feasibility of standardized batch creation rules, status management, serial number profiles, and traceability processes across business units to prevent multi-site collisions.
EWM traceability discovery deliverables.
A compliant discover phase must exit with the following concrete master data deliverables before starting the blueprint. 1. Multi-site traceability audit report, a comprehensive document mapping all active, legacy, internal and external batching and serialization structures across all locations. 2. Global Batch and Serial Number Standard Specification, a detailed logical design blueprint defining a globally unique serialization hierarchy and batch classification format. 3. Enterprise Traceability Process Blueprint, a validated architecture document defining batch creation, serial number management, traceability checkpoints, and cross-system validation rules. 4. Enterprise Batch and Serial Governance Charter, a governance document defining ownership, batch creation standards, serialization policies, lifecycle management, and audit responsibilities. Key takeaway: these master data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and database reconciliation delays.
Traceability and standardization KPIs.
We track the following critical indicators to manage master data risks during the early project phases. 1. Global Traceability Standardization Rate, the target percentage of warehouse locations planned to run on a unified standard serialization framework. 2. Batch Classification Standardization Rate, Percentage of business units using standardized batch characteristics and classification structures. 3. Barcode scanning compatibility score, a quantitative rating of the percentage of legacy label formats compatible with standard mobile scanning profiles. 4. Traceability data completeness score, percentage of batch and serial records meeting enterprise traceability standards. Key takeaway: quantifying master data complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is serial number in stock in EWM, and why does underestimating its numbering complexity during Discover ruin the blueprint?
Answer: serial number in stock is the highest level of EWM serialization, tracking individual serials down to the exact storage bin. If you underestimate its complexity during Discover, the picking and packing lines will stall. You will find that operators are forced to perform extensive, unexpected physical scans for every single movement, severely reducing daily throughput.
Follow-up 2. How do you identify hidden legacy warehouse serialization and batching complexities during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform a rigorous analysis of legacy batch classification tables and audit current serialization profiles in active business units. I also run structured workshops with quality inspection leads and warehouse SMEs to map out actual RF scanning procedures and end-to-end warehouse traceability workflows.
Follow-up 3. Curveball. What do you do when the PMO insists on keeping the serialization configuration simple to save budget, but your audit shows the business requires complex, bin-level tracking to satisfy regulatory audits?
Answer: I do not argue the point on configuration complexity. Instead, I present a process impact document showing standard EWM behavior when regulatory traceability is bypassed. I explain that forcing simplified serialization profiles and batch management rules onto complex warehouse operations will trigger an increased scanning workload on the floor, incorrect picking task generation, and major regulatory audit failures. I ask them to choose between standard regulatory traceability or costly post-conversion remediation.
Governance takeaway for this migration incident 25.
Ignoring enterprise batch and serial number governance during Discover is a severe governance failure. Always establish standardized traceability rules, ownership, and lifecycle management before entering Explore to prevent regulatory compliance issues, warehouse execution failures, and audit risks.
Migration incident 26. Data volume and archiving strategy. Historical warehouse transaction volume and archiving needs are ignored, leading to unrealistic migration timelines or inflated HANA sizing.
During the Discover phase, the project team fails to assess legacy warehouse transaction volume and archiving needs, assuming all historical warehouse transactional data should be migrated directly into the target S/4HANA database. High-volume warehouses generate millions of physical warehouse tasks, deliveries, and packaging records over time. Migrating this massive, unclean database footprint severely inflates S/4HANA hardware hosting costs and causes the Software Update Manager technical conversion runtime to exceed approved cutover downtime limits, risking a project rollback. Business objective: establish a strict warehouse data archiving and volume management strategy early in the Discover phase to shrink the database footprint, minimize target hosting costs, and secure cutover timelines.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this data volume discovery failure across the following strategic boundaries. 1. Complexity: high strategic data archiving and sizing failure. 2. Frequency: common in high-volume distribution warehouses. 3. Business process: data archiving and database volume management. 4. Business scope: enterprise warehouse transaction history, data archiving, database volume management, and HANA sizing. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: lead basis architect and master data lead. 8. Business ownership: IT infrastructure director and program sponsor.
Typical warehouse data volume complexities.
Experienced architects audit the legacy warehouse database tables for the following critical archiving objects during the Discover phase. 1. Closed warehouse tasks: millions of historical confirmed warehouse tasks in table/SCWM/ORDIM_C remaining unarchived in the hot database tier. 2. Warehouse delivery documents, historical inbound and outbound delivery records in table/SCWM/DLV_DOC, bloating the database size. 3. Physical inventory counting records, historical warehouse physical inventory counting documents in table/SCWM/PI_DOC_DB remaining unarchived. 4. Change document history. Large volumes of historical change documents and audit records significantly increase database size while providing little operational value after migration. 5. Warehouse monitor log history. Obsolete execution logs, warehouse monitor statistics, and trace histories filling up the database tables. 6. Queue and message history. Years of old, processed transactional queue and messaging logs that were never cleaned or truncated. 7. Handling unit transactional data. Closed handling unit master records and physical packing histories occupying active memory tiers. 8. Stock transfer documentation history. Legacy intra-company or inter-company transport documentation history logs remaining unarchived. 9. Value-added service worksheets. Historical kitting, specialized labeling, and packaging worksheets remaining active in the database. 10. Labor management performance records. Years of individual worker physical task tracking and performance records left unarchived. 11. Application log history. General SAP application logging and system trace data in SLG1, bloating the database size. Key insight. The Software Update Manager executes conversions based on database volume. Archiving these high-volume tables during Discover is how senior architects shrink the go-live downtime window.
Migration incident analysis and root cause why this happens.
Failing to identify data volume and archiving complexities typically stems from the following root causes. 1. IT teams assume all legacy transaction history must be migrated to S/4HANA to maintain long-term operational reporting. 2. Enterprise data retention policies are never reconciled with migration objectives, resulting in unrealistic assumptions about historical data that must remain online. 3. A complete failure to audit and analyze EWM-specific high-volume database tables like /SCWM/ORD, IM_C or /SCWM/DLV_DOC during the Discover phase. 4. Disregarding EWM-specific archiving objects in the initial project scope, scheduling, and budget allocations. 5. Underestimating how unarchived database sizes extend the Software Update Manager technical conversion runtime.
Business, program, and operational impact.
Ignoring database volume and archiving requirements introduces critical risks across the project landscape. 1. Program impact. Extended technical conversion downtime during the go-live weekend, leading to project rollbacks, expensive cloud hosting overruns, and delayed benefits realization. Larger databases also extend system refreshes, test cycles, and environment provisioning throughout the project. 2. Warehouse impact. Day 1 transaction response times degrade across RF terminals and desktop stations, as the database optimizer struggles with 10 years of unarchived history in the active memory tier. 3. Operational KPIs affected. Outbound picking confirmation speeds degrade, receiving transaction response times drop, and night batch warehouse replenishment runs exceed operational windows.
Governance and accountability.
We establish clear governance boundaries to manage the database volume and archiving scope. 1. Decision owner. Lead basis architect, accountable for executing data footprint analysis and projecting technical conversion runtimes. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed data tiering and archiving strategies. 3. Business sponsor. IT Infrastructure Director, responsible for providing S/4HANA hardware sizing approvals and cloud hosting budgets. 4. Supporting teams. EWM Solution Architect, Data Migration Lead, and Finance Compliance Director.
Real implementation tips and best practices.
Apply the following strategic guidelines during the Discover phase to secure your database boundaries. 1. Execute a comprehensive database table analysis in the legacy system, identifying high-volume EWM-specific transactional tables. 2. Design an archiving project plan to run in parallel with early preparation phases, archiving data before the technical conversion begins. 3. Map standard EWM archiving objects, including warehouse tasks and delivery documents, against legacy data retention requirements. 4. Formally evaluate the technical and operational feasibility of using SAP Information Lifecycle Management to tier data into warm or cold storage.
EWM, data volumetry and archiving deliverables.
A compliant discover phase must exit with the following concrete data deliverables before starting the blueprint. 1. EWM Database Analysis Report. A comprehensive document mapping actual table sizes, database growth rates, and archiving potentials. 2. S/4HANA Data Tiering and Temperature Strategy. A logical design blueprint defining hot, warm, and cold data storage rules using SAP Information Lifecycle Management. 3. EWM-specific archiving object configuration. A validated architecture document outlining standard EWM archiving objects, retention periods, and execution schedules. 4. Technical Conversion Downtime Estimation Report. A validated assessment documenting projected software update manager runtime, database migration duration, downtime assumptions, and mitigation recommendations. Key takeaway: these data deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Volume and archiving standardization, KPIs.
We track the following critical indicators to manage data volume risks during the early project phases. 1. Source database footprint reduction rate. The target percentage reduction of legacy database size achieved before technical conversion. 2. HANA hot tier sizing optimization ratio. A metric measuring target HANA memory requirements relative to legacy database volumes. 3. Archiving object enablement rate. Percentage of required standard SAP archiving objects configured, tested, and approved before migration. 4. Technical conversion downtime duration. The estimated hours required to complete the software update manager and database migration option technical conversion. Key takeaway: quantifying data volume metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is EWM data archiving, and why does underestimating its complexity during discover ruin the blueprint?
Answer: data archiving is the process of removing closed transactional data from the active database and storing it securely. If you underestimate its complexity during discover, the S/4HANA conversion will stall. Unarchived legacy tables, containing millions of warehouse tasks, will drastically inflate target HANA memory requirements and extend the technical conversion downtime past approved go-live windows.
Follow-up 2. How do you identify legacy warehouse, database volume, and archiving complexities during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform a deep dive database analysis in the legacy system, identifying high-volume EWM-specific tables like /SCWM/ORD, IM_C, and legacy application logs. I then review existing archiving jobs, retention policies, and archive administration history to identify unmapped archival gaps.
Follow-up 3 curveball. What do you do when the PMO insists on bypassing legacy data archiving to save budget, but your audit shows the technical conversion will exceed the go-live downtime window?
Answer: I do not argue the point on archiving costs. Instead, I present a technical conversion downtime simulation showing standard software update manager behavior when high-volume tables are migrated. I explain that bypassing archiving will cause extended conversion runtimes, infrastructure cost overruns, and unacceptable cutover duration, directly leading to a go-live rollback. I ask them to choose between standard data archiving or a compromised, high-risk go-live cutover.
Governance takeaway for this migration incident 26.
Ignoring enterprise warehouse data volume and archiving requirements during discover is a severe governance failure. Always establish a clear data retention, archiving, and volume management strategy before entering explore to reduce database footprint, control infrastructure costs, and protect technical conversion timelines.
Category 4, Master Data, and Archiving Assessment Conclusion.
To summarize Category 4, securing your master data quality and data volume footprints represents a mandatory prerequisite for technical system conversions. Standardizing material master attributes, establishing robust business partner customer vendor integration data mappings, auditing packaging specifications, and executing pre-migration data archiving are vital activities. If your data foundation is corrupted, uncleaned, or unarchived during the discover phase, your S/4HANA EWM implementation will face severe transaction execution failures and extended downtime overruns.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The Elite Transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 4 to Category 5.
With our master data quality, global packaging standards, and technical archiving thresholds defined, we must now pivot our focus from data records to legacy custom code. A beautifully structured database and mapped physical landscape will still experience catastrophic failures if legacy custom code, user exits, and undocumented custom transactions are blindly converted. We will now transition into Category 5, Custom Development Discovery, where we analyze the architectural risks of unmapped legacy custom developments, undocumented enhancements, and obsolete custom transactions.
Category 5, Custom Development Discovery.
In S/4HANA EWM, Custom Development Discovery represents the technical cleanup gate of the technical system conversion. Legacy ERP and warehouse management systems often contain decades of custom developments, obsolete enhancements, and undocumented transactions that must be evaluated. Category 5 analyzes the critical risks, spanning undocumented custom enhancements, ownerless custom transactions, unmapped custom RF transactions, and legacy user exits with obsolete logic that must be audited early in the discover phase.
Category 5, Custom Development Discovery Incidents 27 to 30.
To prevent technical conversion and repository activation failures, a rigorous discover phase must audit and document these custom technical domains. Incident 27. Hundreds of custom enhancements are identified without functional or technical documentation. Incident 28. Critical Z programs supporting warehouse operations have no identifiable business owner. Incident 29. Custom RF transactions have been modified repeatedly without source design documentation. Incident 30. Legacy user exits and baddie implementations contain business logic that nobody fully understands. Let's dive into Incident 27.
Migration Incident 27. Hundreds of custom enhancements are identified without functional or technical documentation.
During the discover phase, the project team identifies hundreds of legacy custom enhancements, user exits, and custom Z objects in the database repository, but discovers they completely lack any functional or technical documentation. Over decades of operation, legacy SAP warehouse solutions accumulate extensive custom developments, enhancements, user exits, baddies, and Z objects to manage physical processes on the floor. Without clear documentation, the project team cannot determine what operational processes these enhancements support, whether they are still active, or how to re-engineer them. This technical debt creates massive estimation and scheduling risks before the blueprinting phase begins. Business objective: perform a complete audit and technical inventory of all legacy custom code and enhancements early in the discover phase to establish a realistic RICEFW remediation and standard adoption plan.
Incident Classification and Relevant SAP Note if applicable.
To establish clear parameters, we classify this custom code discovery failure across the following strategic boundaries. 1. Complexity: high custom code and technical debt discovery failure. 2. Frequency: very common in mature, highly customized legacy warehouses. 3. Business process: custom code quality assessment and scoping. 4. Business scope: enterprise custom developments, technical debt assessment, RICEFW inventory, and SAP extensibility landscape. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise technical architect and custom code lead. 8. Business ownership: IT applications manager and program sponsor.
Typical undocumented legacy EWM enhancements.
Experienced architects audit the legacy repository and custom ABAP packages for the following critical custom warehouse enhancements during the discover phase. 1. Custom baddie implementations: Undocumented business add-in implementations overriding standard SAP EWM processing logic for warehouse execution and integration. 2. Custom enhancement framework objects, implicit enhancements, explicit enhancement spots, and enhancement implementations modifying standard SAP execution logic. 3. Custom picking path overrides, legacy user exits modifying standard transfer order creation to enforce non-standard travel paths on the floor. 4. Dynamic put-away bin selection exits, custom ABAP code extending standard capacity checks and put-away determination to support site-specific operational constraints. 5. Automated packing material validation, custom RF screens validating container dimensions against legacy database tables before confirmation. 6. Specialized label and printing spools, highly customized print programs bypassing standard output management to trigger regional carrier labels. 7. Manual replenishment trigger bypasses, legacy background scripts dynamically adjusting minimum and maximum bin thresholds on the fly. 8. Co-mingled bin stacking validations, undocumented custom code governing whether multiple vendor batches can physically share a single storage bin. 9. Automated warehouse task confirmations, custom user exits automatically confirming specific logical movements without manual operator scans. 10. Legacy quality inspection interfaces, custom messaging logs used to update stock statuses based on external quality system decisions. Key insight: custom enhancements represent the legacy operational deviations. Auditing these custom objects during discover is how senior architects prevent massive blueprint design rewrites.
Migration incident analysis and root cause why this happens.
Failing to document legacy custom enhancements typically stems from the following root causes. 1. Decades of unstructured, decentralized developments executed without enforcing mandatory documentation standards. 2. A structured capability and documentation assessment of required custom code roles was never performed before project budgeting. 3. An inaccurate assumption that legacy custom code will easily migrate to S/4HANA EWM without structural or functional refactoring. 4. The original developers and functional consultants who built the custom enhancements are no longer with the organization. 5. Governance gap. Enterprise custom development standards, documentation policies, and technical ownership were never consistently enforced across multiple implementation projects.
Business, program, and operational impact.
Underestimating custom development complexity introduces critical risks across the project landscape. 1. Program impact. Immediate timeline delays and budget overruns during the realize phase as developers are forced to analyze, debug, and rebuild hundreds of undocumented legacy custom objects. Larger repositories also extend system refreshes, test cycles, and environment provisioning throughout the project. 2. Validation testing, integration testing, regression testing, and end-to-end warehouse process validation expand significantly because undocumented custom enhancements require extensive technical verification across multiple business scenarios. 3. Operational impact. Standard picking and put-away configurations fail during integration testing because the system lacks the custom operational rules that the warehouse floor relies on daily. 4. Operational KPIs affected. Outbound picking cycle times increase, inventory receiving lane congestion rises, post-go-live support ticket volumes spike, and overall warehouse labor productivity drops.
Governance and accountability.
We establish clear governance boundaries to manage the custom development and repository scope. 1. Decision owner, enterprise technical architect and custom code lead, jointly accountable for executing data footprint analysis and custom code complexity assessments. 2. Review board, enterprise architecture review board, responsible for auditing proposed custom development remediation plans and standard adoption strategies. 3. Business sponsor, IT applications manager, responsible for providing legacy development documentation and approving RICEFW budgets. 4. Supporting teams, data migration lead, custom code quality team, SAP basis team, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your custom code boundaries. 1. Execute a comprehensive repository analysis in the legacy system, utilizing tools like custom code lifecycle management. 2. Conduct structured data quality workshops involving legacy developers, corporate IT architects, and local warehouse shift supervisors. 3. Technical usage analysis. Analyze runtime usage statistics, transaction traces, and execution frequency to distinguish actively used custom objects from obsolete developments. 4. Formally evaluate the technical and operational feasibility of standardizing custom developments to reduce the total number of custom objects.
EWM custom code, discovery deliverables.
A compliant discover phase must exit with the following concrete custom code deliverables before starting the blueprint. 1. Custom code repository audit log. A comprehensive technical inventory documenting all custom Z objects, enhancements, user exits, and their usage statistics. 2. Functional and technical code remediation plan. A detailed design blueprint outlining which legacy custom developments will be standard adopted, refactored, or retired. 3. Legacy enhancement dependency map. A validated architecture document outlining how custom code touchpoints integrate with physical warehouse processes and standard layouts. 4. Custom code modernization roadmap. A governance document defining which custom developments will be retired, refactored, rebuilt, or replaced by standard SAP functionality across each migration phase. Key takeaway: these custom code deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Custom code complexity and quality KPIs.
We track the following critical indicators to manage custom code risks during the early project phases. 1. Custom code documentation coverage. The target percentage of legacy custom enhancements and Z objects possessing active, validated functional or technical documentation. 2. Standard adoption rate. Percentage of legacy custom developments successfully replaced by standard SAP functionality. 3. Technical debt complexity rating. A quantitative assessment of the custom code footprint relative to standard EWM out-of-the-box capabilities. 4. CCLM Object Decommissioning Index. The total number of unused, obsolete, or duplicate legacy custom objects targeted for decommissioning before technical conversion. Key takeaway: quantifying custom code complexity metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a custom code assessment in S/4HANA, and why does underestimating its complexity during discover ruin the EWM blueprint?
Answer: a custom code assessment is the technical process of auditing legacy custom developments to check for compatibility with S/4HANA database structures. If you underestimate its complexity during discover, the blueprint will stall. You must identify incompatible custom developments, obsolete APIs, unsupported database access patterns, deprecated enhancement techniques, and extension points requiring remediation before conversion.
Follow-up 2. How do you identify hidden legacy, warehouse custom code, and repository complexities during the discover phase?
Answer: I do not rely on standard documentation. I perform a deep dive technical audit of legacy custom development packages using a BAP test cockpit and custom code lifecycle management tools. I then review existing custom code modification logs, functional designs, and transaction usage statistics to identify unmapped custom code dependencies.
Follow-up 3 curveball. What do you do when the PMO insists on bypassing legacy custom code analysis to save budget, but your audit shows the technical conversion will encounter hundreds of undocumented custom objects?
Answer: I do not argue the point on custom code analysis costs. Instead, I present a technical conversion simulation showing standard software update manager behavior when uncleaned. Highly customized databases are converted. I explain that bypassing custom code analysis will cause extended conversion runtimes, infrastructure cost overruns, and unacceptable cutover duration. I ask them to choose between standard custom code audits or a compromised, high-risk go-live cutover.
Governance takeaway for this migration incident 27.
Ignoring enterprise custom code complexity during discover is a severe governance failure. Always establish a complete inventory of legacy custom developments, technical ownership, and modernization strategies before entering Explore to minimize technical debt, reduce remediation effort, and protect blueprint stability.
Migration Incident 28. Critical Z programs supporting warehouse operations have no identifiable business owner.
During the Discover phase, the project team identifies critical custom Z programs, automated background batch scripts, and proprietary reports supporting warehouse operations, but discovers they have no identifiable business owner or operational stakeholder. Over decades of operation, legacy warehouse systems accumulate custom background programs to patch operational gaps or automate queue clearing. Without an active business owner, the project team cannot validate if these programs are still required, how to test them, or how to re-engineer them. This governance gap results in severe technical and scheduling risks during the conversion. Business objective: identify and map active business owners to all legacy custom Z programs early in the Discover phase to establish a structured decommissioning, testing, and modernization plan.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this custom code ownership failure across the following strategic boundaries. 1. Complexity: high technical governance and code ownership failure. 2. Frequency: very common in long-standing ERP and SCM landscapes. 3. Business process: custom code ownership and technical debt scoping. 4. Business scope: enterprise custom program ownership, background job governance, technical debt assessment, and operational accountability. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise technical architect and custom code lead. 8. Business ownership: business process owner and IT applications manager.
Typical ownerless legacy warehouse Z programs.
Experienced architects audit the legacy background job logs and repository tables for the following critical custom programs during the Discover phase. 1. Ownerless interface monitoring jobs: background programs monitoring warehouse interfaces without an assigned business or technical owner to validate failures or processing exceptions. 2. Legacy scheduled housekeeping jobs: automated cleanup and database maintenance jobs continuing to execute without documented ownership, review procedures, or operational approval. 3. Automated stock queue clearing scripts: background batch jobs automatically purging or restarting hanging queues in transaction SMQ2. 4. Custom inventory adjustment programs: proprietary programs executing inventory write-offs and stock adjustments directly without standard approvals. 5. Custom shipping manifest consolidation reports: legacy reporting programs consolidating outbound deliveries across different carriers and plants. 6. Automated replenishment trigger scripts: background routines bypassing standard minimum thresholds when active picking demand spikes. 7. Custom billing and freight charge calculations: legacy billing programs calculating logistics services and internal warehouse charging. 8. Obsolete material master update jobs: background batch jobs modifying warehouse-specific attributes without proper master data governance. 9. Custom handling unit relabeling routines: programs dynamically generating new packaging identifiers to bypass physical stock blocks. 10. Legacy quality status sync jobs: unmonitored background jobs attempting to synchronize quality inspection results with legacy ERP tables.
Migration incident analysis and root cause why this happens.
Failing to identify active business owners for legacy custom programs typically stems from the following root causes. 1. Decades of operational turnover where original business sponsors, process owners, and developers left without transferring ownership. 2. Lack of a centralized IT and business master data governance framework to enforce continuous technical ownership. 3. Background batch jobs running silently in transaction SM37 without active operational review or business validation. 4. System integrators and business leads prioritize standard operational output, completely neglecting technical debt and custom code ownership. 5. Governance gap: enterprise custom development standards, documentation policies, and technical ownership, were never consistently enforced across multiple implementation projects.
Business, program, and operational impact.
Carrying ownerless custom programs introduces critical risks across the project landscape. 1. Program impact. Project blueprinting and design activities stall during explore as the technical team cannot decommission, test, or refactor high-risk custom code due to missing business validation. 2. Operational governance. Production incidents take significantly longer to resolve because no accountable business owner exists to explain, validate, or approve the behavior of legacy custom programs. 3. Validation testing. Integration testing, regression testing, and end-to-end warehouse process validation expand significantly because undocumented custom enhancements require extensive technical verification across multiple business scenarios with no active business SMEs to validate results. 4. Operational impact. High risk of carrying obsolete, buggy custom code into S/4HANA EWM, creating day-one system stability risks, increased production support effort, and inflated long-term hosting and maintenance costs.
Governance and accountability.
We establish clear governance boundaries to manage the custom development and repository scope. 1. Decision owner, enterprise technical architect and custom code lead, jointly accountable for executing data footprint analysis and custom code complexity assessments. 2. Review board, enterprise architecture review board, responsible for auditing proposed custom development remediation plans and standard adoption strategies. 3. Business sponsor, business process owner and IT applications manager, jointly accountable for identifying and validating active business owners. 4. Supporting teams, data migration lead, custom code quality team, SAP basis team, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your custom code boundaries. 1. Execute a comprehensive repository analysis in the legacy system, utilizing tools like custom code lifecycle management. 2. Technical usage analysis. Analyze runtime usage statistics, transaction traces, and execution frequency to distinguish actively used custom objects from obsolete developments. 3. Business ownership validation. Conduct structured workshops with business process owners to formally assign ownership, validate operational necessity, and approve the retirement of every active custom program. 4. Formally evaluate the technical and operational feasibility of standardizing custom developments to reduce the total number of custom objects.
EWM custom code. Discovery deliverables.
A compliant discover phase must exit with the following concrete custom code deliverables before starting the blueprint. 1. Custom code ownership register. A comprehensive technical inventory mapping every custom Z program and background batch job to an active, accountable business owner. 2. Business process validation map. A documented register outlining the physical warehouse processes, inputs, and validation rules supported by each custom program. 3. Decommissioning and retirement blueprint. A formal plan outlining which unowned or obsolete custom programs will be permanently retired before Explore begins. 4. Custom code modernization roadmap. A governance document defining which custom developments will be retired, refactored, rebuilt, or replaced by standard SAP functionality across each migration phase. Key takeaway: these custom code deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Custom code complexity and quality KPIs.
We track the following critical indicators to manage custom code risks during the early project phases. 1. Custom code ownership rate. The target percentage of active legacy custom programs and batch jobs mapped to verified active business owners. 2. Standard adoption rate. Percentage of legacy custom developments successfully replaced by standard SAP functionality. 3. Verified business ownership coverage. Percentage of active custom programs with confirmed business ownership, technical ownership, and operational approval. 4. CCLM Object Decommissioning Index. The total number of unused, obsolete, or duplicate legacy custom objects targeted for decommissioning before technical conversion. Key takeaway: Quantifying custom code complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. Why is identifying a business owner for every legacy custom program critical before starting Explore?
Answer: because without an active, accountable business owner, it is impossible to validate whether a custom program is still operationally required, who should test its behavior during validation cycles, or who has the authority to approve its decommissioning. Carrying ownerless code into S/4HANA EWM introduces high-risk technical debt and severely inflates your long-term hosting and maintenance footprint.
Follow-up 2. How do you identify legacy warehouse custom code and repository complexities during the Discover phase?
Answer: I combine technical repository analysis with structured interviews involving business process owners, application support teams, and operations managers. Every active custom program is mapped to a verified business owner, business process, execution frequency, and operational justification before modernization decisions are made.
Follow-up 3 Curveball. What do you do when the PMO insists on bypassing legacy custom code analysis to save budget, but your audit shows hundreds of active custom programs have no accountable business owner?
Answer: I present a risk assessment showing the technical debt and testing bottlenecks of carrying hundreds of unowned programs. I explain that without active business owners to validate these custom processes, SIT and UAT cycles will stall because nobody can sign off on test results or verify if a system-guided process has succeeded. I ask them to choose between a controlled ownership assignment sprint now or a costly post-go-live stabilization program driven by unresolved ownership and technical debt.
Governance takeaway for this migration incident 28.
Ignoring business ownership of legacy custom programs during Discover is a severe governance failure. Always assign accountable business and technical owners before entering Explore to ensure every retained custom program has a justified business purpose, testing strategy, and modernization path.
Migration incident 29. Custom RF transactions have been modified repeatedly without source design documentation.
During the Discover phase, the project team identifies extensive legacy custom RF transactions and mobile screen developments, but discovers they have been modified repeatedly over decades without any source design documentation. The RF framework is the operational core of EWM. Operators depend entirely on these mobile screens to execute physical movements. Failing to document how these screens have been customized, what physical validations they enforce, or what custom logic is hidden inside their screen programs, creates a massive risk of floor-level operational disruption during the migration. Business objective: perform a complete audit and technical inventory of all legacy custom RF transactions early in the Discover phase to establish a standardized, standard-aligned mobile user experience roadmap.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this mobile process discovery failure across the following strategic boundaries. 1. Complexity: high mobile architecture and user experience discovery failure. 2. Frequency: extremely common in long-standing legacy warehouse environments. 3. Business process: RF framework usability and customization discovery. 4. Business scope: enterprise RF architecture, mobile user experience, warehouse execution processes, and RF framework standardization. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise technical architect and RF solution architect. 8. Business ownership: warehouse operations managers and IT applications director.
Typical undocumented RF framework customizations.
Experienced architects audit the legacy mobile transactions and screen programs for the following critical custom RF modifications during the Discover phase. 1. Custom barcode verification logic: custom screen validation rules verifying GTIN, UPC, or custom serial layouts before allowing task confirmation. 2. Screen field omissions and bypasses: custom RF layout skipping mandatory confirmation steps to speed up physical floor scans. 3. Custom step loop sequences: multi-step screen flows altered to run on non-standard picking or replenishment paths. 4. ITS Mobile HTML and CSS style sheet hacks. Legacy HTML template modifications built to enforce high contrast layouts on obsolete screen resolutions. 5. Dynamic queue switching prompts. Handheld terminal prompts dynamically changing operator queues based on on-the-fly supervisor requests. 6. Custom material label printing triggers. Immediate, printer-level triggers executed directly from standard RF picking screens. 7. Unmapped physical inventory counting steps. Non-standard counting checks and tolerance validations embedded in custom RF DynPros. 8. Automated handling unit splitting screens. Proprietary RF screens used to split or merge handling units without standard EWM POSC routing. 9. Legacy RF user exits. Hard-coded ABAP routines in screen flow logic overriding standard error messaging. 10. Third-party scanner key mappings. Custom device-level key assignments mapped directly to obsolete transaction flows.
Migration incident analysis and root cause why this happens.
Failing to identify legacy custom RF complexities typically stems from the following root causes. 1. Decades of unstructured, localized RF screen modifications executed without enforcing mandatory design documentation standards. 2. A complete failure to audit legacy custom screen programs and /SCWM/RFU illogical transactions early in the discover phase. 3. An inaccurate assumption that because a mobile process runs on standard handheld scanners, it matches out-of-the-box SAP EWM behavior. 4. The original developers and operational teams who built and configured the custom RF layouts are no longer with the organization. 5. Mobile process governance gap. RF screen modifications evolved independently across warehouse sites without centralized usability standards, mobile design governance, or periodic architectural reviews.
Business, program, and operational impact.
Carrying ownerless, undocumented RF custom screen programs introduces critical risks across the project landscape. 1. Program impact. Project blueprinting and design activities stall during explore as the technical team cannot decommission, test, or refactor high-risk custom screen code due to missing business validation. 2. Operator productivity. Warehouse operators require additional keystrokes, repeated scans, and manual workarounds because inconsistent RF screen behavior reduces execution efficiency. 3. Warehouse execution. Picking, put-away, replenishment, and inventory processes slow significantly because inconsistent RF transactions create operator confusion and scanning failures. 4. User adoption. Operator training effort increases substantially because each warehouse follows different RF screen layouts, navigation paths, and validation sequences. 5. Validation testing. User acceptance testing, device compatibility testing, and end-to-end warehouse execution validation expands significantly because custom RF screen flows require extensive verification across multiple handheld devices and warehouse scenarios.
Governance and accountability.
We establish clear governance boundaries to manage the custom development and repository scope. 1. Decision owner. Enterprise technical architect and RF solution architect, jointly accountable for executing RF custom screen and repository audits. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed custom development remediation plans and standard adoption strategies. 3. Business sponsor. Business process owner and IT applications manager, jointly accountable for identifying and validating active business owners. 4. Supporting teams. Warehouse operations SMEs, RF solution architect, mobile infrastructure team, and SAP basis team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your custom code boundaries. 1. RF screen walkthroughs. Observe warehouse operators executing real RF transactions to document navigation flow, validation logic, and usability bottlenecks. 2. RF usage analysis. Analyze transaction frequency, screen navigation paths, and device usage statistics to identify active versus obsolete RF customizations. 3. Operator experience workshops. Conduct workshops with warehouse supervisors and operators to validate which RF customizations provide genuine operational value. 4. Formally evaluate the technical and operational feasibility of standardizing custom developments to reduce the total number of custom objects.
EWM Custom RF Discovery Deliverables.
A compliant discover phase must exit with the following concrete custom code deliverables before starting the blueprint. 1. RF Framework Customization Audit Log. A comprehensive technical inventory documenting all customized /SCWM/RFUI screens, DIME pros, and custom logical transactions. 2. RF Process and Usability Mapping Registry, a documented register outlining the physical warehouse processes, inputs, and validation rules supported by each custom RF program. 3. Standard EWM RF Screen Fit Gap Assessment, a logical design blueprint comparing legacy custom screens with standard S/4HANA EWM screen profiles. 4. RF User Experience Modernization Roadmap, a phased roadmap defining which RF customizations will be retired, standardized, redesigned, or rebuilt using standard SAP EWM mobile capabilities. Key takeaway: these custom code deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
RF Architecture and Mobile Usability KPIs.
We track the following critical indicators to manage custom code risks during the early project phases. 1. RF Screen Standardization Rate, the target percentage of RF logical transactions running on standard unmodified EWM screen profiles. 2. Standard Adoption Rate, percentage of legacy custom developments successfully replaced by standard SAP functionality. 3. Custom RF Screen Complexity Score, a quantitative rating of the development debt within legacy screen program DIME pros. 4. RF Usability Testing Pass Rate, expected percentage of operators successfully executing test scripts on standard EWM screens without assistance. Key takeaway: quantifying custom code complexity metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the SAP EWM RF framework, and why does underestimating custom RF screen complexity during discover create operational risks after go live?
Answer: the SAP EWM RF framework is the transactional engine for mobile warehouse execution, managing scan-to-scan workflows, screen DIME pros, and device-level mappings. Underestimating its custom complexity during discover leads to immediate post-go-live failures. Without standardizing these screens early, operators encounter incorrect validation rules, missing field defaults, and disrupted muscle memory, which drops picking and shipping throughput on day 1.
Follow-up 2. How do you identify undocumented legacy RF transaction and mobile screen complexities during the discover phase?
Answer: I combine technical analysis of /SCWM/RFU, logical transactions with warehouse floor observations, and structured workshops involving supervisors and RF operators. Every active RF customization is mapped to the warehouse process, validation logic, operator dependency, and business justification before modernization decisions are made.
Follow-up 3 Curveball. What do you do when the PMO insists on bypassing legacy custom code analysis to save budget, but your audit shows hundreds of active custom RF screen modifications have no accountable business owner?
Answer: I present a risk assessment showing the technical debt and testing bottlenecks of carrying hundreds of unowned RF modifications. I explain that without active business owners to validate these custom processes, SIT and UAT cycles will stall because nobody can sign off on test results or verify if a system-guided process has succeeded. I ask them to choose between a controlled ownership assignment sprint now or a costly post-go-live stabilization program driven by unresolved RF customization risks.
Governance takeaway for this migration incident 29.
Ignoring custom RF transaction complexity during discover is a severe governance failure. Always establish a complete inventory of RF customizations, usability standards, and mobile execution requirements before entering Explore to protect warehouse productivity, operator adoption, and blueprint stability.
Migration incident 30. Legacy user exits and baddie implementations contain business logic that nobody fully understands.
During the discover phase, the project team uncovers highly complex legacy user exits and business add-in implementations, only to realize that the original developers have left and current business users do not understand the underlying logic. This creates a technical black box. The business simply knows the warehouse functions daily, but the project team has no documentation detailing what parameters trigger these enhancements, what operational safety checks they bypass, or how they interact with standard processes. Attempting to migrate black box code blindly into S/4HANA introduces catastrophic regression risks and violates modern clean core extensibility strategies. Business objective: systematically isolate, reverse engineer, and validate undocumented legacy custom logic during discover to establish a safe modernization and decommissioning strategy.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this custom code discovery failure across the following strategic boundaries. 1. Complexity, high technical debt and reverse engineering failure. 2. Frequency, extremely common in systems older than 5 years. 3. Business process, custom code quality assessment and extensibility scoping. 4. Business scope, enterprise clean core strategy, technical debt assessment and code modernization. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, enterprise technical architect and SAP extensibility lead. 8. Business ownership, business process owner and IT applications manager.
Typical black box extensibility traps.
Experienced architects audit the legacy ABAP repository for the following critical undocumented logic traps during the discover phase. 1. Hard-coded operational bypasses, baddie implementations containing hard-coded plant codes or vendor IDs to bypass standard quality inspections. 2. Implicit enhancement commits, highly dangerous implicit enhancements modifying standard SAP database commit cycles, causing silent data corruption. 3. Dynamic process type overwrites, user exits rewriting standard warehouse process types in the background based on undocumented shift timing logic. 4. Cascading automation triggers, custom exits triggering secondary, undocumented outbound IDOCs to third-party logistics partners. 5. Silent task auto confirmations, logic automatically confirming warehouse tasks without operator scans to artificially inflate daily throughput metrics. 6. Custom status table updates, unmapped routines directly updating custom Z tables that downstream financial reports quietly depend upon. 7. Unmanaged exception swallows, BAD is designed to intercept standard SAP error messages and suppress them, hiding critical operational failures from the floor. 8. Dynamic printer rerouting, embedded code evaluating specific material groups to dynamically change label printer destinations on the fly. 9. Undocumented enhancement spot chains, multiple enhancement implementations triggering one another across different execution points, making business behavior extremely difficult to trace and validate. Key insight: black box code masks operational reality. If you do not reverse engineer these baddies during discover, you will face unexplainable process failures during integration testing.
Migration incident analysis and root cause why this happens.
Failing to decode legacy custom implementations typically stems from the following root causes. 1. High organizational turnover resulting in the complete loss of the original technical developers and functional consultants. 2. A deeply ingrained IT culture of if it is not broken, do not touch it, allowing undocumented code to survive for decades. 3. Failing to activate application lifecycle management tools, such as ABAP call monitors, to track whether legacy code is actually executing. 4. Project estimation models focus entirely on standard process activation, allocating zero budget for reverse engineering legacy complexity. 5. Clean core governance gap. The enterprise lacks a structured technical debt strategy, continuously extending obsolete code rather than refactoring to standard SAP capabilities.
Business, program, and operational impact.
Carrying black box user exits into a migration introduces critical risks across the project landscape. 1. Program impact. Project blueprinting stalls entirely because functional consultants cannot map future state designs without understanding the hidden rules overriding the current system. 2. S/4HANA clean core violations. Lifting and shifting tightly coupled legacy BADs directly violates modern S/4HANA extensibility models, locking the enterprise out of future cloud upgrades. 3. Validation testing blockers. Integration testing fails repeatedly because test scripts cannot be written for logic that nobody understands, making SIT and UAT sign-offs impossible. 4. Operational impact. Unpredictable warehouse behavior on day one as obsolete custom logic collides with new S/4HANA standard processes, paralyzing inbound and outbound operations.
Governance and accountability.
We establish clear governance boundaries to manage the reverse engineering and modernization scope. 1. Decision owner, enterprise technical architect and SAP extensibility lead, jointly accountable for reverse engineering legacy code and designing the clean core roadmap. 2. Review board, enterprise architecture review board, responsible for auditing proposed BADI retirements and standard adoption strategies. 3. Business sponsor, business process owner and operations director, jointly accountable for validating the business necessity of decoded custom logic. 4. Supporting teams, SAP basis team, custom code remediation team or SAP development team, and EWM functional lead.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to illuminate black box code. 1. Activate usage procedure logging and the ABAP call monitor in the legacy production system immediately to identify which BADs are actually executing. 2. Dead code retirement strategy. If usage logs show a custom exit has not executed in 13 months, classify it for controlled retirement after business validation. 3. Conduct structured reverse engineering workshops where ABAP developers run debug traces on active BADs, while business SMEs perform physical warehouse tasks. 4. Evaluate every surviving custom exit against the S/4HANA Clean Core strategy, prioritizing in-app or key user extensibility over classic ABAP modifications.
Clean core and extensibility discovery deliverables.
A compliant discover phase must exit with the following concrete technical deliverables before starting the blueprint. 1. Black box remediation register, a comprehensive technical inventory mapping every undocumented user exit and BADI to its decoded business purpose and active usage metrics. 2. Custom code usage audit report, a validated data extract from the ABAP call monitor proving which legacy enhancements are active versus obsolete. 3. Dead code decommissioning blueprint, a formal plan outlining which unowned or obsolete custom programs will be permanently retired before Explore begins. 4. S/4HANA Clean Core Extensibility Roadmap, a governance document defining which required legacy logic will be rebuilt using modern developer extensibility or SAP BTP. Key takeaway: these extensibility deliverables are the foundation for a sustainable S/4HANA landscape, protecting the project from lifting and shifting obsolete technical debt.
Clean core and technical debt KPIs.
We track the following critical indicators to manage technical debt risks during the early project phases. 1. Dead code decommissioning rate, the percentage of legacy user exits and BADs identified as inactive by usage logs and targeted for immediate retirement. 2. Clean Core Adoption Index, the target percentage of surviving custom logic planned for migration to modern S/4HANA extensibility frameworks versus legacy ABAP. 3. Active Object Mapping Rate, the percentage of executing custom enhancements successfully reverse engineered and mapped to a validated business process. 4. Standard Adoption Replacement Rate, the volume of legacy custom logic that will be entirely replaced by new, standard S/4HANA out-of-the-box features. Key insight: quantifying technical debt metrics during Discover is how senior architects protect the program from violating the S/4HANA Clean Core strategy.
Follow-up 1. What is the S/4HANA Clean Core strategy, and why does migrating undocumented legacy BADs threaten it?
Answer: the Clean Core strategy requires keeping the S/4HANA technical core unmodified to ensure seamless future cloud upgrades. Legacy BADs, user exits, and enhancement implementations are often tightly coupled to business processes and legacy technical designs. If you blindly migrate undocumented black box code, you violate Clean Core principles, carrying over obsolete technical debt that will break standard system upgrades and bloat your maintenance costs.
Follow-up 2. How do you identify whether an undocumented legacy user exit is actually required by the business during the discover phase?
Answer: I do not ask the business if they need it, because they often do not know it exists. Instead, I activate usage procedure logging and the ABAP call monitor in the production system to capture hard metrics on execution frequency. If a block of code hasn't fired in a year, I mark it for decommissioning. For active code, I run technical debug traces while shadowing operators to map the code directly to physical floor activities.
Follow-up 3 curveball. What do you do when the business refuses to sign off on decommissioning a black box baddie because they are afraid it might break an unknown edge case process?
Answer: I do not force a conceptual argument. I present the empirical data from the ABAP call monitor proving the baddie has not executed in over a year. If fear persists, I propose a controlled quarantine. We deactivate the baddie in the quality assurance landscape during a controlled SIT and UAT validation cycle. When the business successfully executes all end-to-end warehouse scenarios without the code firing, confidence is restored, and they approve the retirement.
Governance takeaway for this migration incident 30.
Migrating undocumented black box code blindly into S/4HANA is a severe governance failure. Always utilize empirical usage logs to decommission dead code, and reverse engineer active logic before entering Explore to protect your clean core architecture and testing cycles.
Category 5, Custom Development Discovery Conclusion.
To summarize Category 5, auditing and documenting legacy custom developments, user exits, and baddie implementations represents a critical technical hygiene gate during the discover phase. Bypassing custom code discovery and letting technical debt migrate silently to S/4HANA completely violates modern clean core standards. To establish a stable, upgrade-ready architecture, every custom enhancement, unowned Z program, and legacy custom RF screen must be documented, validated, and evaluated for standard adoption before entering the design phase.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from custom code to integration and automation.
With our legacy repository custom code, unowned Z programs, and manual RF transaction modifications fully audited, we must now turn our attention to how the warehouse physically and systemically interacts with the outside world. A warehouse running on clean standard code will still fail if its communication interfaces to external ERPs, transport systems, and complex material flow equipment are unmapped or obsolete. We will now transition into Category 6, Integration and Automation Discovery, where we analyze the massive architectural risks of unmapped material flow systems, obsolete PLC protocols, and missing carrier integrations.
Category 6. Integration and Automation Discovery.
In S/4HANA EWM, Integration and Automation Discovery represents the ultimate physical execution gate of the transformation program. Modern warehouses do not operate in isolation. They are highly integrated ecosystems where the software must drive physical automated equipment in real time. Category 6 deep dives into the critical risks of unmapped material flow systems, unvetted warehouse control systems, obsolete automation communication protocols, undocumented external interfaces, and ignored shipping or printing integrations during the discover phase.
Category 6. Integration and Automation Discovery, Incidents 31 to 35.
To prevent critical integration and physical execution failures, a rigorous discover phase must audit and document these physical and systemic interfaces. Incident 31. Warehouse automation landscape inventory is incomplete, leaving critical automation dependencies undiscovered. Incident 32. MFS and automation depth. Underestimation of MFS configuration complexity or assumption that the existing MFS can be easily reused. Incident 33. Legacy interfaces between SAP EWM and external systems are poorly documented or completely unknown. Incident 34. PLC, conveyor, ASRS, AGV, or robotics integrations depend on obsolete communication protocols. Incident 35. Carrier, shipping, and label printing integrations are missing from the initial integration inventory. Let's dive into Incident 31.
Migration Incident 31. Warehouse automation landscape inventory is incomplete, leaving critical automation dependencies undiscovered.
During the discover phase, the project team fails to compile a comprehensive, physical warehouse automation landscape inventory, leaving critical automation dependencies undiscovered. IT scoping often focuses exclusively on the software application layer, completely ignoring the physical material handling equipment, automated conveyors, and third-party control systems that drive daily operations. Excluding these physical nodes from the initial assessment results in incomplete S/4HANA EWM integration architectures, blocked material flow routing, and severe real-time messaging deadlocks during the technical build. Business objective: accurately identify, catalog, and map all physical warehouse automation assets, controllers, and interfaces early to ensure complete coverage in the S/4HANA EWM material flow system design.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this automation discovery failure across the following strategic boundaries. 1. Complexity: high enterprise automation and integration scoping failure. 2. Frequency: very common in highly automated and conveyor-driven warehouses. 3. Business process: warehouse automation and interface discovery. 4. Business scope: enterprise warehouse automation, material flow systems, warehouse control systems, and physical integration architecture. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: lead integration architect and EWM solution architect. 8. Business ownership: warehouse automation director and program sponsor.
Typical warehouse automation elements.
Experienced architects audit the physical warehouse floor and automated systems for the following critical automation components during the discover phase. 1. Automated storage and retrieval systems: automated cranes and hoists executing high-density storage and retrieval of pallets in high bay structures. 2. Conveyor sorter control loops: high-speed diverter, merge, and routing lanes transporting totes or shipping cartons between physical zones. 3. Print and apply labeling stations: inline, system-triggered labeling systems applying customer shipping labels dynamically during transit. 4. Inline check weigher scales: dynamic weight validation scales sending real-time variance data to EWM to detect picking errors. 5. Automated guided vehicles: laser-guided or wire-guided robotic vehicles transporting raw materials and finished goods across internal staging zones. 6. Pick-to-light and put-to-light systems: physical digital light displays guiding operators to correct bin picking and packing locations. 7. Automated depalletizer robotics: high-speed robotic arms executing structured pallet breakdown and layers picking operations. 8. Obsolete serial interface handshakes: obsolete legacy communication lines connecting older, unnetworked programmable logic controllers. 9. Automated carton erector machines: automated packaging equipment erecting and folding standard shipping cartons on the fly. 10. Voice picking and wearable headsets: legacy voice recognition engines and wireless headsets directing operators without standard mobile screens. 11. Automated shuttle systems: multi-level shuttle systems transporting totes or cartons between storage aisles, requiring real-time coordination with EWM material flow system processes.
Migration incident analysis and root cause why this happens.
Failing to scope physical warehouse automation typically stems from the following root causes. 1. IT scoping sessions rely entirely on high-level software application maps, completely ignoring physical warehouse floor machinery and controllers. 2. An inaccurate assumption that because a legacy warehouse uses a third-party control system, EWM has no direct technical integration dependency. 3. Underestimating the complexity of real-time telegram exchanges, socket communications, and PLC handshake timings. 4. A failure to involve automation engineers, PLC developers, and on-site maintenance supervisors in early discover workshops. 5. Excluding local warehouse control systems and specialized conveyor diagnostics tools from the initial S/4HANA migration scope. 6. Automation governance gap: enterprise automation standards, controller inventories, and integration ownership are not centrally governed, allowing critical warehouse automation dependencies to remain undiscovered during the discover phase.
Business, program, and operational impact.
Omitting physical warehouse automation introduces critical risks across the project landscape. 1. Validation testing: integration testing, automation commissioning, and end-to-end warehouse execution validation expand significantly because every PLC, WCS, MFS telegram and conveyor scenario must be verified under realistic operating conditions. 2. Program impact. Immediate project stalls during the realize phase as the team is forced to build unplanned, complex MFS telegram structures and redesign warehouse process-oriented storage controls. 3. Warehouse impact. Physical gridlock on the conveyor loops as unscoped check weighers and diverters stall cargo because EWM cannot logically resolve real-time handshakes. 4. Operational KPIs affected. Outbound shipping cycle times increase. Automated crane utilization rates decline. Conveyor queue backlogs rise. And overall warehouse throughput drops.
Governance and accountability.
We establish clear governance boundaries to manage the physical automation and integration scope. 1. Decision owner. Lead integration architect and EWM solution architect, jointly accountable for verifying the complete physical and systemic automation maps. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed material flow system against actual PLC and conveyor structures. 3. Business sponsor. Warehouse Automation Director, responsible for providing a comprehensive inventory of all active automated systems, controllers, and WCS software. 4. Supporting teams. Automation engineers, PLC developers, third-party WCS integration lead, and S4 HANA basis team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your automation boundaries. 1. Execute a comprehensive physical audit of all active automated storage areas, conveyor systems, check weighers, and PLC controllers. 2. Conduct structured integration workshops involving both corporate IT architects and local warehouse automation engineers. 3. Map legacy programmable logic controllers and warehouse control systems against standard EWM material flow system capabilities. 4. Formally evaluate the technical and operational feasibility of standardizing communication telegrams to reduce the total number of custom interfaces. 5. Live automation observation. Observe automation equipment during peak operational periods to validate real-world conveyor routing, PLC interactions, and exception handling beyond documented process flows.
EWM automation discovery deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Warehouse Automation Landscape Registry. A comprehensive catalog documenting all physical automated storage and retrieval systems, conveyors, check weighers, and PLC models. 2. Standard EWM to Automation Integration Map. A logical architecture map outlining the use of EWM material flow system telegrams versus third-party warehouse control systems. 3. Physical to logical staging area map. A validated architecture document outlining how physical conveyor drop-off points and pickup stations map to EWM storage sections. 4. Warehouse Automation Integration Strategy. A technical architecture document defining automation boundaries, controller responsibilities, communication protocols, interface ownership, and migration sequencing. Key takeaway. These automation deliverables are the foundation for the S4 HANA EWM blueprint, protecting the project from costly late-stage technical debt and conveyor integration delays.
Automation sourcing and integration, KPIs.
We track the following critical indicators to manage automation and integration risks during the early project phases. 1. Automation scoping coverage percentage. The target percentage of physically active automated warehouse assets formally documented and approved in the project scope. 2. MFS Telegram Compatibility Index, a metric measuring how successfully proposed EWM telegram structures support standard programmable logic controller configurations. 3. External Partner WCS Integration Readiness, a quantitative assessment of the technical readiness of third-party warehouse control systems to connect to the target landscape. 4. Automation Asset Variance, the total discrepancy count between the physical automation audit and the initial IT project scope documentation. Key takeaway. Quantifying automation scope metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is EWM material flow system And why does excluding third-party automation dependencies during Discover ruin its design?
Answer: the EWM Material Flow System, or MFS, allows EWM to communicate directly with programmable logic controllers on the conveyor lines, can communicate directly with programmable logic controllers, or integrate alongside warehouse control systems, depending on the warehouse automation architecture. If these physical dependencies are excluded during Discover, S/4HANA ERP and EWM will be designed without the necessary real-time socket connections or telegram structures. When go-live occurs, the conveyor lines will physically stall because the system cannot exchange handshakes.
Follow-up 2. How do you identify hidden legacy, warehouse automation, and integration dependencies during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical operational floor walks during active, high-volume shifts. I trace the physical path of a tote or carton on the conveyor lines, noting check weigher scales, barcode scan tunnels, and physical diverters. I then audit legacy integration logs and review active background jobs in the legacy system to identify undocumented automation dependencies and interface gaps.
Follow-up 3. Curveball. What do you do when the PMO insists on bypassing physical warehouse automation analysis to save budget, but your audit shows they must support complex conveyor integrations?
Answer: I do not argue the point conceptually. Instead, I present a process impact document showing standard EWM behavior if the conveyor loop experiences a real-time communication failure. I explain that forcing simple goods receipts onto complex automated lines will drop daily shipping throughput, create severe data synchronization bottlenecks, and create widespread interface failures, conveyor stoppages, and warehouse synchronization delays. I demonstrate standard EWM MFS telegram handshakes, showing how they secure automated warehouse operations.
Governance takeaway for this migration incident 31.
Ignoring warehouse automation dependencies during Discover is a severe governance failure. Always establish a complete inventory of automation assets, controller interfaces, communication protocols, and integration ownership before entering Explore to protect warehouse throughput, automation reliability, and blueprint stability.
Migration incident 32. Material flow system and automation depth. Underestimation of MFS configuration complexity or assumption that the existing MFS can be easily reused.
During the Discover phase, the project team significantly underestimates the configuration complexity of the EWM material flow system, assuming legacy automated warehouse controls can be easily reused or direct migrated into S/4HANA. MFS is a highly sensitive, state machine-driven engine built natively into the EWM core. In S/4HANA, the MFS framework requires a complete re-architecture of socket communications using ABAP push channels, layout-oriented storage controls, and modern PLC telegram schemas. Treating this as a simple lift and shift leads to severe communication deadlocks and extensive custom code rewrites during the realize phase. Business objective: ensure accurate budgeting and scheduling by performing a detailed technical assessment of EWM MFS configuration depth, socket communication architecture, and telegram mapping requirements.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this material flow system discovery failure across the following strategic boundaries. 1. Complexity: high enterprise material flow system and automation integration failure. 2. Frequency: common in S/4HANA EWM migrations involving automated high bays. 3. Business process: material flow system and automation capability discovery. 4. Business scope: enterprise material flow system architecture, PLC communication, warehouse automation integration, and real-time messaging. 5. EWM deployment type: not yet decided. 6. Immediate business priority, high. 7. Primary ownership: lead integration architect and EWM MFS solution architect. 8. Business ownership: warehouse automation director and program sponsor.
Typical EWM MFS architectural gaps.
Experienced architects audit the legacy warehouse automation and communication channels for the following logical integration gaps during the Discover phase. 1. Legacy RFC adapter dependencies. Legacy systems depending on obsolete external C-based RFC adapters instead of modern S/4HANA ABAP push channels. 2. Mismatched telegram handshake sequences, incompatible telegram structures, and handshake confirmation timings between legacy WCS and EWM. 3. Layout-oriented storage control alignment. Complex routing logic mapping physical conveyor diverts to EWM logical storage sections. 4. Custom PLC keep alive heartbeats. Non-standard ping and heartbeat intervals causing frequent socket disconnects in S/4HANA. 5. Dynamic destination bin recalculation. Legacy custom Z objects dynamically changing put-away bins mid-conveyor, bypassing standard EWM MFS logic. 6. Weight scale divert logic, missing standard integration to capture check weigher data and automatically trigger a reroute to error lanes. 7. Unmapped crane travel time calculations. Automated ASRS systems utilizing custom velocity curves not supported by standard EWM MFS. 8. Obsolete serial communication gateways. Legacy conveyor loops relying on hardware-based serial to Ethernet converters that introduce network latency. 9. Co-mingled conveyor merge locks. Missing configuration in EWM to manage merge point locking, leading to physical box collisions. 10. Automation exception telegram gaps. Missing logical error handling mappings when a barcode scanner fails to read a label.
Migration incident analysis and root cause why this happens.
Failing to scope MFS configuration depth typically stems from the following root causes. 1. IT teams assume that because legacy PLC telegrams exist, they can be directly uploaded into S/4HANA without re-engineering. 2. An inaccurate assumption that legacy external RFC servers or plant connectivity adapters can be reused, ignoring ABAP push channel upgrades. 3. MFS architecture governance gap. Enterprise standards for socket communication, telegram design, and automation integration are not centrally governed, leading to inconsistent MFS implementations across warehouse sites. 4. A complete failure to map EWM layout-oriented storage control rules to physical conveyor divert points during discover. 5. Underestimating the custom development and testing effort required to build, map, and simulate custom telegram schemas. 6. Excluding automation specialists and PLC developers from early discover workshops, leaving EWM functional consultants to assume standard compliance.
Business, program, and operational impact.
Underestimating EWM MFS complexity introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the team is forced to build socket connections and completely redesign warehouse process-oriented storage controls, leading to timeline delays and expensive RICEFW revisions. 2. Validation testing. Integration testing, PLC simulation, telegram validation, and end-to-end MFS commissioning expand significantly because every communication sequence and automation scenario must be verified before physical go live. 3. Warehouse impact. Physical gridlock on the automated conveyor loops as unmapped heartbeats and mismatched telegrams cause standard crane and ASRS systems to halt, freezing stock in transit. 4. Operational KPIs affected. Outbound picking cycle times increase. Automated crane utilization rates decline. Conveyor queue backlogs rise. And overall warehouse throughput drops.
Governance and accountability.
We establish clear governance boundaries to manage the material flow system integration scope. 1. Decision owner. Lead integration architect and EWM MFS solution architect, jointly accountable for verifying the MFS socket and telegram mappings. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed MFS configurations against actual PLC capabilities. 3. Business Sponsor. Warehouse Automation Director, responsible for providing legacy telegram structures, PLC handshakes, and WCS middleware data. 4. Supporting teams. Automation engineers, PLC developers, third-party WCS integration lead, and S/4HANA basis team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your MFS boundaries. 1. Execute a comprehensive technical audit of all active legacy PLC telegrams, custom handshakes, and TCP or IP socket connections. 2. Design a formal MFS integration blueprint mapping EWM layout-oriented storage controls to physical conveyor ID points. 3. PLC simulation validation. Execute simulated telegram exchanges and communication flow testing before physical commissioning to identify handshake timing issues early in the project. 4. Involve PLC developers and automation specialists directly in early fit-to-standard workshops. 5. Formally evaluate the technical and operational feasibility of standardizing communication telegrams to avoid legacy external RFC adapters.
EWM MFS discovery deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. MFS Architectural Feasibility Report. A comprehensive document comparing legacy WCS and MFS configurations against target S/4HANA standards. 2. ABAP Push Channel APC Communication Architecture Specification. A logical design blueprint outlining target TCP or IP socket parameters and network ports. 3. Telegram Structure and Mapping Specification. A technical register outlining the exact header, payload, and handshake sequence for every PLC controller. 4. Automation Routing and LOSC Integration Blueprint. A validated architecture document defining physical routing, logical storage control, conveyor identifiers, and automation synchronization points. Key takeaway: these MFS deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and conveyor integration delays.
MFS sourcing and integration KPIs.
We track the following critical indicators to manage MFS and integration risks during the early project phases. 1. MFS Standard Configuration Adoption Index. The target percentage of automated warehouse movements planned to run on standard, unmodified EWM MFS. 2. PLC Telegram Mapping Complexity Score. A metric measuring the variance of custom telegram formats across legacy PLC controllers. 3. ABAP Push Channel Socket Readiness Rate. A quantitative rating of the network readiness to support low-latency direct TCP or IP socket connections. 4. Automation Integration Test Lead Time. The estimated duration required to execute end-to-end simulated PLC handshakes before physical testing begins. Key takeaway: quantifying MFS scope metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the S/4HANA EWM material flow system, and why does assuming legacy MFS reusability during discover create major architectural risks?
Answer: the S/4HANA EWM material flow system, or MFS, is the native state machine engine that allows EWM to communicate directly with PLC controllers on automated conveyor lines. Assuming legacy reusability ignores major architectural shifts, particularly the migration from legacy external RFC adapters to native TCP or IP socket communication implemented through ABAP push channels. If this is not assessed during discover, the target blueprint will fail to account for the necessary real-time telegram architecture and physical conveyor automation handshakes, causing severe operational stoppages at go-live.
Follow-up 2. How do you identify legacy, warehouse MFS, and automation complexities during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical operational floor walks during active, high-volume shifts to audit the automated stations. I trace the physical path of a pallet through the high bay area, analyzing how standard crane and PLC handshakes execute. I then perform a thorough technical audit of legacy telegram structures and background job parameters in the legacy system to identify undocumented automation interfaces, telegram dependencies, and controller integration gaps.
Follow-up 3 curveball. What do you do when the PMO insists on reusing legacy external RFC adapters to save budget, but your audit shows the S/4HANA EWM target architecture requires modern ABAP push channels?
Answer: I do not take a purely technical stance. I present a risk and cost impact document showing standard software update manager behavior when legacy, tightly coupled RFC communication methods are converted. I explain that attempting to run legacy adapters on the S/4HANA core will cause communication failures, conveyor stoppages, and synchronization delays across automated warehouse operations. I demonstrate standard ABAP push channels, showing how they secure automated warehouse operations and lower long-term infrastructure costs.
Governance takeaway for this migration incident 32.
Ignoring material flow system architecture complexity during Discover is a severe governance failure. Always establish standardized socket communication, telegram design, controller integration, and MFS architecture before entering Explore to protect warehouse automation, commissioning, and blueprint stability.
Migration incident 33. Legacy interfaces between SAP EWM and external systems are poorly documented or completely unknown.
During the Discover phase, the project team fails to identify and document legacy interfaces and communication channels connecting SAP EWM to external systems. Over decades of operation, legacy warehouse landscapes accumulate extensive custom interfaces, communication protocols, middleware mappings, IDOC extensions, APIs, and file-based integrations connecting SAP EWM with external systems to manage physical processes on the floor. Failing to scope these legacy interfaces early in the program results in incomplete integration architectures, severe transactional blocking, and unbudgeted middleware mapping developments during later phases. Business objective: identify, catalog, and map all active legacy interfaces and communication pathways early in the Discover phase to establish a standardized, secure enterprise integration blueprint.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this integration discovery failure across the following strategic boundaries. 1. Complexity: high enterprise integration architecture and scoping failure. 2. Frequency: very common in mature multi-system enterprise landscapes. 3. Business process: legacy interface and integration discovery. 4. Business scope: enterprise integration architecture, legacy interface discovery, middleware integration, and external system connectivity. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: lead integration architect and enterprise solution architect. 8. Business ownership: logistics IT director and program sponsor.
Typical legacy EWM integration gaps.
Experienced architects audit the legacy application servers and communication logs for the following logical integration gaps during the Discover phase. 1. Legacy IDOC messaging bridges: custom IDOC types or modified segments sending critical shipping or receiving data to external business partners. 2. Direct database RFC connections: external systems executing direct, synchronous remote function calls into EWM to pull stock balances without standard API validation. 3. Custom REST or SOAP APIs: proprietary web services integrated with third-party carrier portals, freight forwarders, or customs filing engines. 4. AL11 directory flat file transfers: scheduled background jobs dumping inventory flat files to local application server directory paths for legacy reporting tools. 5. Custom QRFC queue interfaces: customized inbound or outbound queues synchronizing transactional stock data with legacy ERP systems. 6. Third-party MES event triggers: real-time messages sent from shop floor execution systems to EWM to initiate raw material staging. 7. Automated scale and dimensioner interfaces: proprietary hardware interfaces sending physical weight and volume measurements to EWM packaging work centers. 8. Logistics service provider integration: batch interfaces synchronizing stock balances, storage location, and receipts with external third-party logistics partners. 9. Legacy voice picking middleware bridges: Obsolete middleware platforms translating EWM tasks into voice instructions on the fly, bypassing standard mobile profiles. 10. Serial number validation web services. Proprietary regional compliance interfaces validating serialized stock during packaging.
Migration incident analysis and root cause why this happens.
Failing to identify legacy integration dependencies typically stems from the following root causes. 1. Decades of incremental interface developments executed without maintaining a centralized technical integration catalog. 2. Integration governance gap. Enterprise interface standards, communication protocols, and integration ownership are not centrally governed, allowing undocumented legacy interfaces to remain undiscovered during the discover phase. 3. An inaccurate assumption that because an interface runs quietly in the background, it has no dependency on S/4HANA ERP conversions. 4. Failing to audit legacy application server directories in transaction AL11 and active communication logs during the discover phase. 5. Excluding corporate integration architects, middleware developers, and third-party system leads from early discover workshops.
Business, program, and operational impact.
Omitting legacy integration dependencies introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the team is forced to build unplanned, complex middleware mapping configurations to support legacy system coexistence, causing timeline delays and expensive RICEFW revisions. 2. Validation testing. Integration testing, middleware validation, interface reconciliation, and end-to-end business process testing expand significantly because every legacy communication pathway must be validated before cutover. 3. Warehouse operations. Shipping, receiving, inventory synchronization, and external partner communication are disrupted because undocumented legacy interfaces fail during execution. 4. Operational KPIs affected. Nightly stock reconciliation cycle times degrade. Interface message failure rates spike. Shipping dock utilization rates decline, and overall data synchronization accuracy drops.
Governance and accountability.
We establish clear governance boundaries to manage the legacy integration and interface scope. 1. Decision owner. Lead integration architect and enterprise solution architect, jointly accountable for designing the standard-aligned target integration architecture. 2. Review board. Enterprise architecture review board, responsible for auditing proposed delivery routing, API configurations, and middleware maps. 3. Business sponsor. Logistics IT director, responsible for providing a complete inventory of all active third-party and legacy interfaces. 4. Supporting teams. Middleware team, SAP Integration Suite team, S/4HANA ERP delivery lead, and third-party system operators.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your integration boundaries. 1. Execute a comprehensive technical audit of all active legacy custom transaction codes, background jobs, and application server directories. 2. Interface traffic analysis. Analyze production interface logs, middleware message statistics, and communication frequencies to distinguish active integrations from obsolete legacy interfaces. 3. Design a formal transitional integration map outlining how ERP, EWM, and third-party systems will exchange data during rollout phases. 4. Involve corporate integration specialists, middleware developers, and external system leads directly in early fit-to-standard scoping workshops. 5. Interface dependency mapping. Document every upstream and downstream system dependency, communication protocol, trigger mechanism, and message direction before defining the target integration architecture.
EWM integration discovery deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Enterprise EWM integration and interface registry. A comprehensive technical catalog documenting all active legacy interfaces, communication methods, and transactional boundaries. 2. S/4HANA to external system interface blueprint. A logical design blueprint defining how legacy interfaces will map to modern OData APIs, standard iDocs, or SAP Integration Suite. 3. Interface remediation and modernization plan. A structured roadmap defining which legacy custom interfaces will be retired, refactored, or replaced by standard SAP capabilities. 4. Cross-system data mapping specification. A detailed technical document outlining target data type conversions, field mappings, and communication protocol configurations. Key takeaway. These integration deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and communication routing errors.
Integration complexity and readiness KPIs.
We track the following critical indicators to manage integration risks during the early project phases. 1. Interface documentation coverage rate. The target percentage of active legacy interfaces possessing validated, up-to-date technical specifications and data mapping rules. 2. Standard API adoption rate. Percentage of legacy custom interfaces successfully replaced by standard S/4HANA OData or standard IDOC APIs. 3. Integration complexity index. A quantitative measurement of the total integration footprint, interface diversity, and estimated modernization effort. 4. Legacy interface decommissioning index. The total number of legacy custom interfaces and obsolete application server file directories successfully retired before technical conversion. Key takeaway. Quantifying interface complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a legacy interface in EWM, and why does underestimating its complexity during Discover ruin the blueprint?
Answer. A legacy interface represents any custom communication channel such as custom IDOCs, remote function calls, or AL11 flat file transfers connecting EWM to external systems. If unmapped during Discover, the future S/4HANA ERP and EWM will be designed without these critical connections. When go-live occurs, external systems like carrier portals or packing scales will suddenly lose connection, completely blocking shipping operations.
Follow-up 2. How do you identify hidden legacy warehouse integration dependencies during the Discover phase?
Answer. I do not rely on standard documentation. I perform physical operational floor walks during active, high-volume shifts to audit the shipping and packing work centers. I trace the physical path of a parcel, noting check weigher scales, barcode scan tunnels, and label print triggers. I then perform a thorough technical audit of legacy transaction, AL11 directories, RFC logs, and active background jobs to identify undocumented interfaces, middleware dependencies, communication protocols, and external system integration gaps.
Follow-up 3 curveball. What do you do when the PMO insists on bypassing legacy interface mapping to save budget, but your audit shows they must support complex carrier and third-party WMS integrations?
Answer. I do not argue the point conceptually. Instead, I present a process impact document showing standard ERP behavior if a legacy shipping interface fails. I explain that forcing simplified interface mappings onto complex enterprise integrations will create message failures, data synchronization issues, transaction processing delays, and business process interruptions. I demonstrate standard S/4HANA OData and standard IDOC API integrations, showing how they secure enterprise integration reliability, business continuity, long-term supportability, and lower long-term infrastructure costs.
Governance takeaway for this migration incident 33.
Ignoring legacy interface dependencies during Discover is a severe governance failure. Always establish a complete inventory of communication protocols, integration ownership, middleware architecture, and external system dependencies before entering Explore to protect business continuity, interface reliability, and blueprint stability.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 34. PLC, conveyor, ASRS, AGV, or robotics integrations depend on obsolete communication protocols.
During the discover phase, the project team fails to identify that legacy physical warehouse automation assets, including programmable logic controllers, automated conveyor loops, crane systems, and automated guided vehicles, rely on obsolete, outdated communication protocols. Standard S/4HANA EWM material flow system expects high-speed, low-latency TCP or IP socket connections via ABAP push channels. Older industrial machinery frequently communicates via legacy serial lines, Modbus, or classic OPC-DA servers. Ignoring these obsolete protocols during discover results in total technical incompatibility, high network latency, and physical conveyor stoppages during testing. Business objective. Identify and analyze all active physical automation communication protocols early to ensure complete compatibility with S/4HANA EWM native TCP or IP socket communication standards.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this communication protocol discovery failure across the following strategic boundaries. 1. Complexity. High enterprise industrial network and protocol architecture failure. 2. Frequency. Very common in legacy automated warehouses. 3. Business scope. Industrial communication protocols, warehouse automation networks, PLC connectivity, and MFS communication architecture. 4. EWM deployment type. Not yet decided. 5. Immediate business priority. High. 6. Primary ownership. Lead integration architect and EWM MFS solution architect. 7. Business ownership. Warehouse automation director and program sponsor.
Typical legacy automation protocol gaps.
Experienced architects audit the legacy warehouse machinery and industrial networks for the following unmapped, obsolete communication protocols during the discover phase. 1. Legacy serial communications RS-232 and RS-485. Direct serial connections used by older PLCs, barcode scanners, and check weigher scales, which are incompatible with modern network sockets. 2. Modbus RTU and Profibus fieldbuses. Older fieldbus industrial networks requiring specialized physical gateways to convert serial signals to standard TCP or IP packets. 3. Proprietary non-standard telegram formats. Legacy, vendor-specific message frames lacking standardized headers, block lengths, or checksum validation logic. 4. Classic OPCDA data access servers. Legacy Windows-based COM and DCOM interfaces that are highly vulnerable and difficult to network securely, requiring transition to modern OPC-UA. 5. Custom C-based RFC middleware wrappers. Obsolete, unsupported middleware layers written in custom C code to translate PLC telegrams to SAP RFCs. 6. Obsolete Siemens S5 PLC protocols. Legacy Siemens S5 networks using proprietary communications that cannot support standard EWM MFS handshakes. 7. Unnetworked standalone controllers. Proprietary robotic or pick-to-light controllers operating on isolated local networks with no external IP capability. 8. Legacy web service endpoints HTTP SOAP. High latency. Obsolete XML-based SOAP web services used to connect AGVs or WCS platforms. 9. Hardware-based serial to Ethernet converters. Unmanaged hardware converters that introduce high packet loss, jitter, and communication latency on the floor. 10. Custom socket wrappers on legacy middleware. Non-standard socket polling scripts that are incompatible with S/4HANA ABAP push channels.
Migration incident analysis and root cause why this happens.
Failing to identify obsolete automation protocols typically stems from the following root causes. 1. IT scoping sessions assume that because legacy automation is physically running, its communication protocols are S/4HANA compatible. 2. Protocol governance gap. Enterprise standards for industrial communication protocols, controller connectivity, and network modernization are not centrally governed, allowing obsolete protocol dependencies to remain undiscovered during the discover phase. 3. An inaccurate assumption that any serial to Ethernet hardware converter can bridge legacy PLCs to standard EWM MFS without introducing unmanageable latency. 4. A complete failure to audit the physical communication ports, serial lines, and industrial bus networks on the active warehouse floor. 5. Excluding automation hardware vendors, industrial network specialists, and PLC developers from early discover workshops.
Business, program, and operational impact.
Ignoring legacy communication protocols introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the team is forced to suspend testing, procure unplanned hardware gateways, redesign communication architecture, and reprogram legacy PLC logic. 2. Validation testing. Integration testing, PLC simulation, protocol validation, and end-to-end warehouse automation commissioning expand significantly, because every industrial communication pathway must be verified before physical go live. 3. Warehouse automation. Conveyor systems, cranes, AGVs, robotic work centers, and automated storage equipment experience communication failures, increasing operational downtime and reducing throughput. 4. Operational KPIs affected. Outbound shipping cycle times increase. Automated crane utilization rates decline. Conveyor queue backlogs rise, and overall warehouse throughput drops.
Governance and accountability.
We establish clear governance boundaries to manage the industrial protocol and integration scope. 1. Decision owner. Lead integration architect and EWM solution architect, jointly accountable for verifying the industrial protocol compatibility. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed hardware gateways against standard network and security guidelines. 3. Business sponsor. Warehouse Automation Director, responsible for providing a comprehensive inventory of all physical PLC models, serial lines, and active field buses. 4. Supporting teams. Industrial network specialists, PLC developers, third-party WCS integration lead, and S/4HANA basis team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your automation boundaries. 1. Execute a comprehensive physical audit of all active legacy PLC communication ports, industrial bus networks, and serial connections on the floor. 2. Industrial network assessment. Validate physical network topology, switch capacity, protocol converters, and communication latency under realistic warehouse operating conditions. 3. Design a formal industrial network blueprint mapping standard EWM socket requirements to physical hardware gateways. 4. Involve industrial network specialists and PLC developers directly in early fit to standard scoping workshops. 5. Formally evaluate the technical and operational feasibility of standardizing on modern OPC-UA communication protocols to eliminate DCOM dependencies.
EWM Automation Protocol, Discovery Deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Warehouse Automation Protocol Registry. A comprehensive document mapping all active physical automated assets, PLC, communication protocols, and physical connection ports. 2. Standard EWM socket integration blueprint. A logical design blueprint outlining target TCP or IP socket parameters, RFC 10.06 configurations, and ABAP push channel port mappings. 3. Industrial Communication Architecture Map. A detailed technical document defining protocol standards, controller connectivity, physical network topology, gateways, routers, switches, and communication boundaries. 4. Legacy Controller and Protocol Modernization Plan. A standardized document defining which physical controllers must be upgraded, reprogrammed, or bridged using hardware converters. Key takeaway. These automation deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and conveyor integration delays.
Automation sourcing and integration, KPIs.
We track the following critical indicators to manage automation and integration risks during the early project phases. 1. Standard Protocol Adoption Index. The target percentage of automated warehouse connections planned to run on standard, native TCP or IP protocols. 2. Industrial Network Latency Baseline. A metric measuring average and peak packet round-trip times between proposed application servers and physical PLCs. 3. Controller Upgrade Readiness Rate. A quantitative rating of the physical readiness of all automated warehouse controllers to support Ethernet-based communications. 4. Legacy Protocol Remediation Backlog. The total number of legacy serial or field-based communication pathways requiring hardware or software bridging. Key takeaway. Quantifying automation scope metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is EWM Material Flow System, and why does excluding legacy communication protocols during discover ruin its design?
Answer. The EWM Material Flow System, or MFS, allows EWM to communicate directly with PLCs on the conveyor lines using standard TCP or IP socket connections via ABAP push channels. If legacy protocols such as Modbus or serial lines are excluded during Discover, EWM will be designed without the necessary hardware gateways. When go-live occurs, warehouse automation equipment will fail to communicate reliably, resulting in conveyor stoppages, crane delays, and reduced warehouse throughput.
Follow-up 2. How do you identify hidden legacy, warehouse automation, and communication protocols during the Discover phase?
Answer: I do not rely on standard documentation. I perform physical operational floor walks during active, high-volume shifts to audit the automated stations. I inspect the physical connection ports of PLCs, tracing the serial lines, field buses, and unmanaged hardware converters. I then audit legacy integration logs and review active background jobs in the legacy system to identify undocumented communication protocols, industrial network dependencies, controller interfaces, and protocol conversion requirements.
Follow-up 3 Curveball. What do you do when the PMO insists on using standard serial to Ethernet converters to save budget, but your audit shows they introduce unmanageable latency?
Answer: I do not argue the point conceptually. Instead, I present a process impact document showing standard EWM behavior when real-time PLC handshakes fail. I explain that forcing high-latency serial to Ethernet converters onto conveyor lines will create communication failures, conveyor stoppages, synchronization delays, and widespread warehouse automation disruptions. I demonstrate standard EWM MFS telegram handshakes, showing how they require direct, low-latency socket connections to showing how they require direct, low-latency socket connections to ensure reliable warehouse automation and uninterrupted material flow.
Governance takeaway for this migration incident 34.
Ignoring obsolete industrial communication protocols during Discover is a severe governance failure. Always establish standardized protocol inventories, controller connectivity, network modernization strategies, and communication architecture before entering Explore to protect warehouse automation reliability, commissioning, and blueprint stability.
Migration incident 35. Carrier, shipping, and label printing integrations are missing from the initial integration inventory.
During the Discover phase, the project team fails to identify and document critical carrier, manifesting, and local label printing integrations in the legacy warehouse environment. Outbound shipping is frequently assumed to be a standard, back-office ERP or local hardware task. In reality, modern high-volume shipping requires real-time, synchronous integrations with multi-carrier platforms, inline weigh scales, local thermal label printers, and S/4HANA post-processing framework outputs. Omitting this scope during Discover guarantees major testing deadlocks, unbudgeted hardware expenses, and severe shipping dock blockages at go-live. Business objective: identify and map all active carrier, manifesting, weighing scale, and local printing integrations early in the Discover phase to establish a stable, standard-aligned outbound execution architecture.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this shipping integration discovery failure across the following strategic boundaries. 1. Complexity: high enterprise shipping integration and output infrastructure failure. 2. Frequency: very common in high-volume distribution warehouses. 3. Business scope: enterprise shipping integration, carrier connectivity, label printing architecture, and outbound execution. 4. EWM deployment type: not yet decided. 5. Immediate business priority: high. 6. Primary ownership: lead integration architect and EWM functional lead. 7. Business ownership: outbound shipping manager and program sponsor.
Typical outbound shipping and labeling complexities.
Experienced architects audit the legacy shipping areas and print spools for the following critical shipping components during the Discover phase. 1. Multi-carrier shipping software interfaces: connections to external multi-carrier routing systems, such as Centiro or ProShip, to fetch tracking numbers and shipping costs on the fly. 2. Zebra programming language spooling: legacy custom code sending raw ZPL commands directly to thermal printers, requiring refactoring for S/4HANA Adobe Document Services. 3. Inline weighing scale integrations. Scale software sending real-time weight measurements to EWM packing stations via serial or socket connections. 4. Post-processing framework output actions. Complex PPF rules automatically triggering packing list and manifest printing based on transactional status changes. 5. Dynamic label template variations. Different customer-specific, vendor-specific, or carrier-specific label layouts requiring complex conditional printing rules. 6. Third-party logistics label replication. Replicating external partner formatted labels to local warehouse printer spools without data corruption. 7. Automated print and apply handshakes. Conveyor-level signals triggering inline labeling machines automatically without manual operator clicks. 8. Export customs documentation prints. Automated generation and printing of international GTS trade documents at the shipping door. 9. Local spooler network surcharges. Thermal printing queues saturating high-density network switches during peak outbound shipping shifts. 10. Custom manifest consolidation scripts. Legacy programs running at day end to consolidate shipments and send EDI manifests to external carriers.
Migration incident analysis and root cause why this happens.
Failing to identify outbound shipping integrations typically stems from the following root causes. 1. IT scoping sessions treat label printing as a basic local network task, completely ignoring EWM post-processing framework complexities. 2. Shipping integration governance gap. Enterprise standards for carrier connectivity, label printing architecture, output management, and outbound integration ownership are not centrally governed, allowing critical shipping dependencies to remain undiscovered during the discover phase. 3. An inaccurate assumption that because a carrier can generate standard tracking numbers, its integration with EWM requires zero custom mapping. 4. A complete failure to audit the physical printer models, local spoolers, and packing scales on the active warehouse floor. 5. Underestimating the custom development, form redesign, and network tuning required to migrate legacy ZPL spools to S4 HANA Adobe forms. 6. Business process gap. Shipping operations rely heavily on local warehouse knowledge, leaving carrier-specific printing rules, packaging workflows, and manifesting requirements undocumented.
Business, program, and operational impact.
Ignoring outbound shipping and labeling requirements introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the team is forced to suspend testing, procure unplanned hardware spools, and completely redesign custom PPF output rules. 2. Validation testing. Integration testing, carrier certification, label validation, print quality verification, and end-to-end outbound execution testing expand significantly because every carrier, printer, and shipping workflow must be validated before cutover. 3. Warehouse operations. Packing, shipping, manifesting, carrier communication, and outbound document generation are disrupted because unmapped integrations fail during execution. 4. Operational KPIs affected. Outbound shipping cycle times increase, automated print and apply utilization rates decline, print queue backlogs rise, and overall warehouse throughput drops.
Governance and accountability.
We establish clear governance boundaries to manage the outbound shipping and manifesting scope. 1. Decision owner. Lead integration architect and EWM functional lead jointly accountable for verifying the shipping output and printing maps. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed hardware spools and carrier integrations against security guidelines. 3. Business Sponsor. Outbound Shipping Manager, responsible for providing a comprehensive inventory of all active carrier platforms, scales, and physical printers. 4. Supporting Teams. Warehouse Operations Team, SAP Integration Suite Team, Network Infrastructure Specialist, and local print spooler support.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your shipping boundaries. 1. Execute a comprehensive physical audit of all active legacy thermal printers, packaging scales, and external carrier portals on the floor. 2. Carrier certification assessment. Validate carrier APIs, certification requirements, label specifications, and testing prerequisites before defining the target outbound architecture. 3. Design a formal outbound shipping blueprint mapping standard EWM PPF and Adobe Document Services to local network spools. 4. Involve carrier integration leads, local packaging supervisors, and network hardware engineers directly in early fit to standard scoping workshops. 5. Formally evaluate the technical and operational feasibility of standardizing on modern PDF or ZPL printing models to eliminate custom legacy code.
EWM shipping and labeling discovery deliverables.
A compliant discover phase must exit with the following concrete landscape deliverables before starting the blueprint. 1. Enterprise Outbound Shipping Integration Registry, a comprehensive technical catalog documenting all active carriers, label printers, scales, and shipping software. 2. Standard S/4HANA EWM Output and PPF Blueprint, a logical design blueprint defining output rules, spools, and Adobe Document Services architecture. 3. Multi-carrier shipping API and middleware map, a detailed integration document mapping data flow boundaries between EWM and external shipping systems. 4. Outbound printing infrastructure architecture, a technical architecture document defining thermal printers, print servers, spool management, network topology, and workstation mappings across outbound operations. Key takeaway: these shipping deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt, outbound shipping disruptions, and carrier integration failures.
Shipping complexity and performance KPIs.
We track the following critical indicators to manage shipping and integration risks during the early project phases. 1. Standard Output Adoption Index, the target percentage of shipping labels and documents generated using unmodified standard S/4HANA ADS and PPF capabilities. 2. Carrier API Integration Readiness, sourcing readiness metric for connecting EWM to external shipping APIs. 3. Outbound printing spool latency baseline, measuring average print spool and transmission delays under peak shipping volumes. 4. Custom label template proliferation rating, the total number of unique, non-standard customer or carrier label formats planned. Key takeaway: quantifying shipping complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the S/4HANA EWM post-processing framework, and why does excluding legacy print spools during Discover ruin its design?
Answer: the EWM post-processing framework, or PPF, is the core output engine used to dynamically schedule and trigger label and manifest printing. If legacy print spools and hardware devices are excluded during Discover, the target blueprint will fail to configure the standard spools and Adobe Document Services. When go-live occurs, shipping labels, manifests, and outbound documents fail to print correctly. Carrier communication breaks down, and outbound truck departures are delayed.
Follow-up 2. How do you identify legacy warehouse shipping and label printing complexities during the Discover phase?
Answer: I do not rely on standard configuration documentation. I perform physical operational floor walks during active, high-volume shifts to audit the shipping and packing work centers. I inspect the physical connection ports of packing scales, tracing the serial lines, local spoolers, and unmanaged hardware converters. I then audit legacy integration logs and review active background jobs in the legacy system to identify undocumented carrier integrations, print spool dependencies, label generation workflows, and outbound document processing requirements.
Follow-up 3 Curveball. What do you do when the PMO insists on bypassing legacy printing audits to save budget, but your audit shows they must support complex multi-carrier integrations?
Answer: I do not argue the point on custom printing costs. Instead, I present a process impact document showing how standard S/4HANA output management and carrier integrations behave when legacy printing requirements are ignored. I explain that forcing simplified output management and carrier integration designs onto complex multi-carrier shipping operations will create failed label generation, incorrect shipping documentation, carrier communication failures, and outbound shipment delays. I demonstrate how standard PPF, Adobe Document Services, and supported integration APIs Satisfy these requirements without unnecessary custom developments.
Governance takeaway for this migration incident 35.
Ignoring carrier integrations, shipping outputs, and label printing architecture during discover is a severe governance failure. Always establish standardized carrier connectivity, output management, print infrastructure, and outbound integration architecture before entering Explore to protect shipping continuity, warehouse productivity, and blueprint stability.
Category 6 Integration and Automation Discovery Conclusion.
To summarize Category 6, auditing your warehouse automation landscape and legacy integration interfaces is an absolute prerequisite for a stable EWM deployment. Transitioning to S/4HANA means managing complex real-time messaging, material flow system socket connections, programmable logic controller telegrams, and multi-carrier shipping interfaces. Ignoring these physical touchpoints during the discover phase guarantees that your standard S/4HANA core will experience immediate network latency and mechanical blockages at go live.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 6 to Category 7.
With our physical automation handshakes, material flow system telegram structures, and legacy external interface registries fully assessed, we must now lift our gaze to the underlying technical hosting platform and hardware infrastructure. A perfect process flow supported by clean custom code and mapped interfaces will still fail if the physical wireless network, server sizing, and handheld scanning devices are incompatible or undersized. We will now transition into Category 7, Technical Readiness, Infrastructure and Platform Assessment, where we evaluate the critical infrastructure and hosting boundaries of the transformation program.
Category 7. Technical Readiness, Infrastructure and Platform Assessment.
In S4 HANA EWM, technical readiness and infrastructure assessments define the physical and systemic foundations of the hosting platform. Category 7 deep dives into the critical risks of the technical system conversion, including prerequisite check failures, third-party add-on incompatibilities, unmapped simplification roadmaps, undersized in-memory databases, obsolete mobile scanning hardware, unvalidated disaster recovery strategies, high-density wireless network dead zones, and RISE with SAP hosting assumptions during the discover phase.
Category 7. Technical Readiness, Infrastructure and Platform Assessment Incidents 36 to 43.
To secure the foundational hosting platform and physical device landscape, a thorough discover phase must systematically audit these critical technical areas. Incident 36. SAP readiness check fails or provides misleading results due to missing prerequisite notes on the legacy ECC system. Incident 37. Third-party add-on incompatibility is revealed as critical bolt-on software is incompatible with S4 HANA. Incident 38. SAP roadmap and simplification items such as warehouse management to production planning integration changes are ignored. Incident 39. Existing infrastructure assessment underestimates HANA sizing, network bandwidth, and RF device capacity requirements. Incident 40. RF hardware and device strategy results in existing RF guns and mobile terminals being incompatible with new Fiori-based or S4 HANA EWM RF frameworks. Incident 41. Disaster recovery, high availability, and business continuity requirements are not captured during discovery. Incident 42. Warehouse wireless network coverage assessment ignores high-density RF operating areas. Incident 43. RISE with SAP hosting assumptions conflict with existing warehouse infrastructure, network, and automation requirements. Let's dive into Incident 36.
Migration Incident 36. SAP readiness check fails or provides misleading results. The legacy ECC system is missing prerequisite SAP notes, causing the readiness check to miss critical EWM add-ons or custom code conflicts.
During the discover phase, the project team executes the SAP readiness check for S4 HANA on the legacy ECC system, but fails to implement the latest prerequisite SAP notes beforehand. This results in a highly deceptive, incomplete cloud dashboard. While the check completes successfully, the data collector programs skip critical EWM-specific checks, completely failing to identify incompatible third-party warehouse add-ons or deprecated custom code structures. Discovering these technical conflicts late in the project causes the Software Update Manager technical conversion to halt with fatal errors during the realize phase. Business objective: ensure a comprehensive technical and functional assessment of the legacy ECC system, by validating and implementing all prerequisite SAP notes before executing the S/4HANA Readiness Check data collectors.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this technical readiness discovery failure across the following strategic boundaries. 1. Complexity, high technical system readiness and basis discovery failure. 2. Frequency, common in long-standing outdated legacy ERP landscapes. 3. Business process, S/4HANA technical readiness and platform discovery. 4. Business scope, SAP Readiness Check, Technical System Assessment, Custom Code Analysis, Add-on Compatibility and Basis Readiness. 5. EWM Deployment Type, Not Yet Decided. 6. Immediate Business Priority, High. 7. Primary Ownership, Enterprise Technical Architect and Lead Basis Architect. 8. Business Ownership, IT Applications Manager and Program Sponsor.
Typical readiness check prerequisites and gaps.
To prevent blueprint failures, basis architects audit the legacy ECC system and transport registries for the following logical technical baseline gaps during the discover phase. 1. Outdated simplification item database, the legacy system running on an obsolete version of the simplification catalog, failing to flag EWM structural changes. 2. Missing prerequisite notes, missing core collector notes, such as Note 2758146 or Note 2399707, causing the data extractor program to skip critical custom code and compatibility scans. 3. Unidentified third-party add-on gaps, failure of the scan to detect incompatible third-party warehouse optimization or voice-picking plugins. 4. ATC readiness dependencies, missing or outdated ABAP test cockpit configurations, preventing complete custom code quality and simplification analysis. 5. Obsolete business function valuations, active legacy business functions, such as older warehouse management extensions, not flagged as incompatible with S/4HANA. 6. Incomplete custom code footprint analysis, rushed code scans missing critical legacy user exits and custom ABAP modifications. 7. Obsolete SCM system integration checks, ignoring legacy SCM database connections and decentralized RFC interfaces during the technical scan. 8. Unresolved customer-vendor integration blocks, prerequisite business partner and CVI conversion validation errors ignored during early checks. 9. Incomplete software update manager dry runs, skipping technical mock conversion runs on sandbox environments, hiding repository activation errors. 10. Undersized sizing calculations, standard database sizing calculations failing to account for high-volume EWM active transaction tracking tables.
Migration incident analysis and root cause why this happens.
Failing to obtain accurate readiness check results typically stems from the following root causes. 1. IT teams execute the readiness check collector reports on the legacy ECC system without verifying and implementing the latest prerequisite SAP notes. 2. Technical governance gap. Enterprise standards for prerequisite SAP notes, readiness assessments, and technical validation activities are not centrally governed, allowing misleading readiness check results to influence migration planning. 3. An inaccurate assumption that the readiness check is a completely automated, zero-maintenance tool requiring no technical preparation. 4. Failing to run the automated pre-transition validation checks on the legacy ECC production system before generating the cloud dashboard. 5. Underestimating how outdated simplification catalogs lead to misleading compatibility scores for critical warehouse add-ons.
Business, program, and operational impact.
Ignoring readiness check prerequisite notes introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the SUM technical conversion halts with fatal errors caused by incompatible add-ons, unresolved simplification items, custom code conflicts, and unsupported technical components. 2. Validation testing. Technical conversion validation, sandbox conversion testing, custom code remediation testing, and end-to-end regression testing expand significantly because misleading readiness check results require repeated technical reassessment before production conversion. 3. Technical conversion. Software update manager conversions, add-on compatibility checks, custom code remediation, and technical validation activities are delayed because prerequisite readiness assessments were incomplete. 4. Operational KPIs affected. Nightly stock reconciliation cycle times degrade. Technical conversion downtime duration exceeds approved cutover windows. And overall project benefits realization is severely delayed.
Governance and accountability.
We establish clear governance boundaries to manage the technical readiness and platform scope. 1. Decision owner. Enterprise technical architect and lead basis architect, jointly accountable for verifying the prerequisite notes and executing data collector reports. 2. Review board. Enterprise architecture review board, responsible for auditing the proposed technical readiness and conversion plans. 3. Business sponsor. IT applications manager and program sponsor, accountable for verifying technical diligence before project funding. 4. Supporting teams. S/4HANA Basis Team, a BAP development team, data migration lead, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your technical readiness. 1. Prerequisite validation. Verify that all prerequisite SAP notes, simplification item databases, and readiness check collector versions are fully updated before executing technical assessments. 2. Readiness assessment verification. Execute the readiness check in a controlled sandbox environment first to validate collector completeness before relying on production assessment results. 3. Custom code readiness assessment. Execute ATC analysis and simplification item validation to identify custom developments requiring remediation before technical conversion. 4. Formally evaluate the technical and operational feasibility of executing early sandbox conversion dry runs to identify unmapped technical blocks.
S/4HANA Technical Readiness Deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. Validated SAP Readiness Check Dashboard. A verified, interactive cloud dashboard generated after implementing all prerequisite collector notes. 2. Incompatible add-on and plugin register. A technical assessment documenting every active third-party warehouse plugin and its S/4HANA compatibility status. 3. Custom code remediation roadmap. A detailed design blueprint outlining which custom developments must be retired, refactored, or replaced by standard capabilities. 4. Technical conversion downtime estimation report. A validated assessment documenting projected software update manager runtime, database migration duration, downtime assumptions, and mitigation recommendations. Key takeaway. These readiness deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Technical readiness and sizing KPIs.
We track the following critical indicators to manage technical readiness risks during the early project phases. 1. Readiness check prerequisites compliance rate. The target percentage of required SAP notes implemented before executing the data collector reports. 2. Add-on compatibility validation score. A metric measuring the verification of all third-party warehouse plugins against standard S/4HANA specifications. 3. Custom code simplification alignment score. The percentage of custom ABAP objects successfully validated against the S/4HANA simplification item catalog. 4. Infrastructure sizing accuracy rating. The target matching precision between estimated in-memory database requirements and actual physical system capacity. Key takeaway. Quantifying technical readiness and sizing metrics during discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the S/4HANA Readiness Check, and why does underestimating its prerequisites during discover ruin the blueprint?
Answer. The S/4HANA Readiness Check is a technical self-service tool that analyzes the legacy ECC system to identify functional and technical conversion conflicts. If prerequisite notes are omitted during discover, the data collector reports skip EWM-specific checks, generating a misleading dashboard. The project team proceeds with standard blueprinting, only to face fatal, unbudgeted add-on compatibility halts during the realize phase.
Follow-up 2. How do you identify hidden legacy, warehouse add-ons, and prerequisite note dependencies during the discover phase?
Answer: I do not rely on standard configuration documentation. I perform a deep dive technical audit of the active system catalog in the legacy ECC production system to locate active third-party plugins. I then verify that all prerequisite SAP notes, collector notes, and simplification databases have been implemented, ensuring the data extractor runs with complete, up-to-date simplification databases.
Follow-up 3 curveball. What do you do when the PMO insists on bypassing early technical conversion dry runs to save budget, but your audit shows they have highly customized legacy environments?
Answer: I do not take a purely technical stance. I present a risk and cost impact document showing standard software update manager behavior when uncleaned, highly customized landscapes are converted. I explain that bypassing early technical dry runs will cause extended conversion runtimes, infrastructure cost overruns, and unacceptable cutover duration. I ask them to choose between standard technical readiness audits or a compromised, high-risk go-live cutover.
Governance takeaway for this migration incident 36.
Ignoring SAP readiness check prerequisites during discover is a severe governance failure. Always validate prerequisite SAP notes, collector versions, simplification databases, custom code readiness, and technical assessment results before entering Explore to protect blueprint accuracy, technical conversion planning, and project stability.
Migration incident 37. Third-party add-on incompatibility. The readiness check reveals that critical bolt-on software, such as voice picking solutions or external yard management, is incompatible with S/4HANA.
During the discover phase, the project team executes the SAP readiness check, only to find that critical third-party add-ons and bolt-on software, including voice-picking solutions, specialized carrier manifesting tools, and external yard management systems, are completely incompatible with S/4HANA. Standard software update manager conversions will halt with fatal, unremediable errors if any registered software component namespace is incompatible. Failing to audit these legacy system components early forces the project team to execute emergency deinstallations or expensive, unplanned process redesigns during the realize phase. Business objective: identify, audit, and document all active third-party system components and legacy warehouse add-ons early in the discover phase to establish a standardized modernization or uninstallation roadmap.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this technical readiness discovery failure across the following strategic boundaries. 1. Complexity: high third-party add-ons, custom plugins, SAP component audits, and technical upgrade compatibility. 2. Frequency: common in S/4HANA EWM conversions. 3. Business process: S/4HANA technical readiness and platform discovery. 4. Business scope: third-party software components, add-on compatibility assessment, vendor certification, software component governance, and technical modernization. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise technical architect and lead basis architect. 8. Business ownership: IT applications manager and program sponsor.
Typical legacy, EWM, add-on, and plugin complexities.
To prevent technical blocks, basis architects audit the legacy ECC system and CVERS component tables for the following active third-party add-ons during the discover phase. 1. Voice picking integration plugins: custom ABAP plugins running third-party voice-guided warehouse execution software directly on the core application server. 2. External yard management systems: specialized yard scheduling, gate check-in, and trailer staging systems integrated via custom components. 3. Multi-carrier shipping software connectors: third-party carrier manifest and rate calculation plugins integrated into the EWM delivery pipeline. 4. Automated warehouse control handshakes: proprietary middleware connectors communicating with conveyor and ASRS PLCs. 5. Custom label printing middleware: specialized printing plugins managing thermal labels directly from warehouse process types. 6. Obsolete SCM optimizer extensions: legacy transportation or warehouse optimization engines running on deprecated database views. 7. Advanced scale and dimensioner plugins. Technical interfaces integrating physical weight scales with EWM packing stations. 8. Mobile device management clients. Handheld device tracking and remote support clients running directly inside legacy SAP environments. 9. Regional compliance and customs add-ons. Local legal reporting plugins managing customs declarations for bonded warehouses. 10. Legacy database archiving plugins. Proprietary third-party archiving tools that conflict with standard SAP information lifecycle management.
Migration incident analysis and root cause why this happens.
Failing to obtain accurate third-party software compatibility data typically stems from the following root causes. 1. IT teams proceed with system conversions without executing a formal SAP software component compatibility audit. 2. Software component governance gap. Enterprise standards for third-party software lifecycle management, vendor certification, and component compatibility are not centrally governed, allowing unsupported add-ons to remain active before technical conversion. 3. An inaccurate assumption that because an add-on is certified for ECC, it will automatically run on the S/4HANA database core. 4. Failing to engage with third-party software vendors early in the discover phase to verify their S/4HANA product roadmaps. 5. Underestimating how legacy system component registrations in the CVERS table block software. Update manager technical upgrades.
Business, program, and operational impact.
Ignoring third-party add-on compatibility introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as the SUM conversion run halts with fatal errors, forcing emergency installation of uncertified software components, vendor upgrades, or costly application modernization activities. 2. Validation testing. Add-on certification testing, software compatibility validation, sandbox conversion testing, and end-to-end business process verification expand significantly because every third-party software component must be certified before production conversion. 3. Technical conversion. Software update manager conversions, software component validation, vendor certification activities, and technical remediation are delayed because unsupported third-party add-ons require replacement or modernization. 4. Operational KPIs affected. Outbound picking productivity drops due to missing voice picking capabilities, receiving times skyrocket, and overall project benefits realization is delayed.
Governance and accountability.
We establish clear governance boundaries to manage the third-party add-on and compatibility scope. 1. Decision owner. Enterprise technical architect and lead basis architect, jointly accountable for verifying the prerequisite notes and executing data collector reports. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed technical readiness and conversion plans. 3. Business sponsor. IT applications manager and program sponsor, accountable for verifying technical diligence before project funding. 4. Supporting teams. S/4HANA Basis Team, a BAP development team, third-party software vendors, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your technical readiness. 1. Vendor certification review. Obtain official S/4HANA compatibility statements and supported release roadmaps from every third-party software vendor. 2. Software component inventory. Audit all registered software components, namespaces, and installed add-ons using the CVERS table before technical planning begins. 3. Standard capability assessment. Evaluate whether unsupported third-party add-ons can be retired by adopting standard S/4HANA or SAP EWM functionality before approving modernization investments. 4. Formally evaluate the technical and operational feasibility of executing early sandbox conversion dry runs to identify unmapped technical blocks.
EWM technical readiness deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. Third-party software compatibility register. A comprehensive technical catalog of all installed non-SAP software components and their compatibility statuses. 2. Vendor certification matrix. A formal assessment matrix documenting official vendor certification letters and supported release roadmaps. 3. Software Component Modernization Roadmap. A detailed design blueprint outlining whether legacy plugins will be upgraded, retired, or replaced by standard capabilities. 4. Unsupported Component Retirement Plan. A validated deinstallation and decommissioning plan for all obsolete or uncertified third-party software components. Key takeaway. These readiness deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Third-party software governance KPIs.
We track the following critical indicators to manage technical readiness risks during the early project phases. 1. Vendor certification coverage. The target percentage of third-party software vendors with formal certification letters signed off and approved. 2. Add-on compatibility validation rate. Percentage of registered legacy software components fully validated for S/4HANA conversion. 3. Unsupported component retirement rate. Percentage of uncertified legacy add-ons successfully installed before technical conversion begins. 4. Software component modernization progress. The total percentage volume of legacy custom components successfully transitioned to modern architectures. Key takeaway. Quantifying technical readiness and sizing metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is a registered SAP software component, and why does underestimating third-party, add-on compatibility during Discover create major technical conversion risks?
Answer. A registered software component represents a packaged set of technical objects maintained in a dedicated namespace registered in the CVERS table. If an add-on is incompatible or uncertified for S/4HANA, standard software update manager conversions will strictly refuse to execute. Underestimating this during Discover means the team will face fatal upgrade halts late in the realize phase, requiring emergency, unbudgeted deinstallations, or critical process redesigns.
Follow-up 2. How do you identify legacy, warehouse third-party, add-ons, and component dependencies during the Discover phase?
Answer. I do not rely on standard configuration documentation. I perform a deep dive technical audit of the CVERS table and check active components using SAINT and SPAM transactions. I cross-reference installed software component versions and namespaces against the official SAP compatibility databases and coordinate with external software vendors to verify their certified S/4HANA roadmaps.
Follow-up 3 curveball. What do you do when the PMO insists on keeping an unsupported third-party add-on because replacing or upgrading it is too expensive, but your audit shows it blocks the technical conversion?
Answer. I do not take an administrative stance. I present a clear technical risk assessment showing how standard software update manager checks execute on the CVERS table. I explain that forcing an uncertified third-party namespace onto S/4HANA is technically impossible and will strictly halt the technical upgrade, causing project delays and infrastructure cost overruns. I propose a compromise, such as standardizing on EWM out-of-the-box features or evaluating SAP platform capabilities to eliminate the uncertified add-on safely.
Governance takeaway for this migration incident 37.
Ignoring third-party software compatibility during Discover is a severe governance failure. Always establish a complete inventory of installed software components, vendor certifications, modernization strategies, and retirement plans before entering Explore to protect technical conversion, business continuity, and blueprint stability.
Migration incident 38. SAP roadmap and simplification items ignored. Key S/4HANA simplifications in EWM such as warehouse management to production planning integration changes. New master data objects are not reviewed during Discovery.
During the Discover phase, the project team fails to review and analyze the S/4HANA simplification item catalog and the standard EWM product roadmap, assuming the legacy warehouse layout can execute a direct, one-to-one functional migration. S/4HANA introduces major structural and integration changes in EWM, including the deprecation of ERP warehouse management, the introduction of stockroom management with strict functional limitations, and the complete replacement of legacy production staging with production material requests. Ignoring these roadmap simplifications early results in massive process misalignments and costly blueprint redesigns during the explore phase. Business objective: accurately identify and validate all S/4HANA EWM simplification items and roadmap changes early in the discover phase to establish a standardized, standard-compliant target warehouse architecture.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this technical readiness discovery failure across the following strategic boundaries. 1. Complexity: high strategic architecture and roadmap discovery failure. 2. Frequency: very common in S/4HANA EWM conversions. 3. Business process: S/4HANA technical roadmap and simplification assessment. 4. Business scope: S/4HANA Simplification Catalog, EWM Product Roadmap, Stockroom Management and Integration Architecture. 5. EWM Deployment Type, not yet decided. 6. Immediate Business Priority, high. 7. Primary Ownership, Enterprise Technical Architect and EWM Lead Architect. 8. Business Ownership, IT Applications Manager and Program Sponsor.
Typical EWM simplification and roadmap gaps.
Experienced architects audit the legacy warehouse structures and configuration tables for the following critical simplification items during the discover phase. 1. Deprecation of standard ERP warehouse management. Standard ERP warehouse management is deprecated in S/4HANA, requiring a transition to EWM or stockroom management. 2. Stockroom management functional limitations. Stockroom management has strict usage limits, completely excluding automated storage, task interleaving, and complex replenishment. 3. Embedded EWM adoption strategy. Evaluating whether legacy decentralized SCM EWM capabilities should transition to embedded EWM based on future business requirements and SAP product direction. 4. Simplified production planning integration, transitioning from legacy delivery-based staging to modern EWM production material requests and production supply areas. 5. Mandatory business partner customer vendor integration, converting legacy vendor and customer records to unified business partners used natively by EWM. 6. Unified EWM material master integration, S/4HANA integrated product masters replacing SCM-specific master data replication pipelines. 7. Integrated quality management and inspection, moving from legacy quality checks to the native EWM quality inspection engine and quality management integration. 8. S/4HANA Global Trade Services Alignment, standard S/4HANA customs integrations replacing legacy external customs interfaces. 9. Fiori-based warehouse monitor modernization, transitioning from legacy SAP GUI monitors to modern, touch-enabled Fiori dashboard architectures. 10. Advanced shipping and receiving integration, adopting the modern TM-EWM integration model for inbound and outbound logistics, replacing legacy transportation integration approaches where applicable.
Migration incident analysis and root cause why this happens.
Failing to identify EWM-specific simplification items typically stems from the following root causes. 1. IT teams assume the Brownfield conversion will execute a one-to-one functional copy of legacy LEWM or SCM EWM structures. 2. Roadmap governance gap. Enterprise standards for reviewing SAP product roadmaps, simplification items, and future state architecture are not centrally governed, allowing deprecated functionality and unsupported design assumptions to enter the target blueprint. 3. An inaccurate assumption that legacy warehouse management remains fully supported in S/4HANA without licensing or functional restrictions. 4. Underestimating the functional and process redesign effort required to adopt modern production material requests and business partner roles. 5. Project budgets and vendor proposals are finalized without identifying deprecated warehouse structures and obsolete integrations. 6. Business transformation gap. Legacy business processes are accepted without challenging whether SAP's redesigned standard processes can replace them in S/4HANA.
Business, program, and operational impact.
Ignoring S/4HANA EWM roadmap simplifications introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the explore phase as the team realizes the legacy warehouse structure cannot physically run on stockroom management, forcing a massive, unplanned EWM redesign. 2. Validation testing. Functional validation, integration testing, simplification verification, and end-to-end business process testing expand significantly because every redesign process introduced by S/4HANA simplification items must be validated before go live. 3. Business operations. Warehouse execution, production staging, inventory movements, and cross-functional integrations are disrupted because deprecated legacy processes cannot execute under the S/4HANA operating model. 4. Operational KPIs affected. Outbound shipping cycle times degrade, production staging delays accumulate, inventory accuracy drops, and overall project benefits realization is delayed.
Governance and accountability.
We establish clear governance boundaries to manage the technical roadmap and platform scope. 1. Decision owner, enterprise technical architect and EWM lead architect, jointly accountable for verifying the S/4HANA EWM roadmap and simplification items. 2. Review board, enterprise architecture review board, responsible for auditing the proposed target warehouse architecture against standard capabilities. 3. Business sponsor, IT applications manager and program sponsor, accountable for verifying technical diligence before project funding. 4. Supporting teams, S/4HANA Basis Team, business process owners, quality assurance lead, and data migration lead.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your technical readiness. 1. Audit the active legacy warehouse structures against the latest S/4HANA simplification item catalog early in the discover phase. 2. Roadmap review workshops. Conduct structured workshops with SAP solution architects and business process owners to evaluate every relevant simplification item and determine whether standard S/4HANA functionality satisfies future business requirements. 3. Formally evaluate the technical and operational feasibility of stockroom management before assuming it can support legacy operations. 4. Verify all business partner and customer vendor integration requirements to prevent transactional and master data replication errors.
EWM roadmap and simplification deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. EWM simplification item fit gap analysis. A comprehensive technical document evaluating legacy warehouse features against the S/4HANA simplification catalog. 2. Stockroom management suitability assessment. A formal assessment matrix validating whether legacy LEWM processes comply with stockroom management limits. 3. S/4HANA target architecture and simplification blueprint. A validated architecture document mapping simplification items, target business processes, integration changes, and modernization decisions. 4. EWM roadmap and modernization plan. A standardized document outlining the phase transition from deprecated legacy features to standard S/4HANA EWM capabilities. Key takeaway. These readiness deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from costly late-stage technical debt and technical conversion delays.
Technical readiness and sizing KPIs.
We track the following critical indicators to manage technical readiness risks during the early project phases. 1. Simplification item alignment score. The target percentage of legacy warehouse processes aligned with standard S/4HANA EWM configurations. 2. Stockroom management compliance rate. A metric measuring the compliance of legacy warehouse storage structures with stockroom management usage limits. 3. Standard EWM feature adoption index. The percentage of standard EWM capabilities such as production material requests or quality inspection engine active in the target design. 4. Deprecated functionality retirement rate. The percentage of obsolete legacy functionality, custom developments, and configurations planned for retirement based on S/4HANA simplification guidance. Key takeaway: quantifying technical readiness and sizing metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is the S/4HANA simplification item catalog, and why does underestimating its impact during Discover ruin the EWM blueprint?
Answer: the S/4HANA simplification item catalog is the technical document outlining all deprecated, modified, or simplified features in S/4HANA. Underestimating its impact during Discover ruins the blueprint because it ignores the deprecation of standard ERP warehouse management. Assuming legacy WM will migrate without functional restrictions leads to process conflicts and unbudgeted redesigns during the Explore phase.
Follow-up 2. How do you identify legacy warehouse processes and simplification item impacts during the Discover phase?
Answer: I perform a detailed audit of all active legacy warehouse structures, plant configurations, and production supply areas against the latest S/4HANA simplification item catalog. I trace physical material flows, identifying whether the legacy setups rely on deprecated warehouse management modules. I then cross-reference these findings with EWM roadmap guidelines to map process transitions early.
Follow-up 3 curveball. What do you do when the PMO insists on keeping legacy warehouse management under stockroom management to save budget, but your assessment shows they require advanced automation?
Answer: I do not argue the point conceptually. Instead, I present a process impact document showing standard EWM behavior when advanced automated staging is executed under stockroom management limitations. I explain that stockroom management strictly excludes advanced automation, wave picking, and task interleaving. I show them that forcing legacy WM on automated lines will create warehouse execution bottlenecks, unsupported business processes, and major blueprint redesigns during Explore. I ask them to choose between a standard compliant S/4HANA architecture or costly post-design rework.
Governance takeaway for this migration incident 38.
Ignoring SAP S/4HANA roadmap guidance and simplification items during Discover is a severe governance failure. Always review the simplification item catalog, product roadmap, target architecture implications, and process redesign requirements before entering Explore to protect blueprint stability, business continuity, and long-term SAP supportability.
Migration incident 39. Existing infrastructure assessment underestimates HANA sizing, network bandwidth, and RF device capacity requirements.
During the Discover phase, the project team treats warehouse infrastructure as a generic IT commodity, severely underestimating HANA database sizing, network bandwidth, and RF device capacities. SAP EWM is an execution-heavy system that processes thousands of microtransactions per hour, consuming exponential amounts of in-memory database RAM. Furthermore, EWM mobile execution requires continuous, synchronous server round trips. Ignoring these high-volume processing and low-latency network requirements early in the project results in procured servers maxing out their memory and barcode scanners, timing out on the warehouse floor. Business objective: conduct a rigorous, EWM-specific infrastructure assessment early in the Discover phase to secure adequately sized HANA appliances, robust wireless network coverage, and compatible mobile hardware.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this technical infrastructure discovery failure across the following strategic boundaries. 1. Complexity: high enterprise network architecture and hardware sizing failure. 2. Frequency: very common in large-scale distribution network migrations. 3. Business process: technical readiness and hardware procurement discovery. 4. Business scope: enterprise infrastructure architecture, HANA database sizing, wireless network capacity and hardware procurement. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise infrastructure architect and lead basis architect. 8. Business ownership: IT infrastructure director and program sponsor.
Typical infrastructure and sizing gaps.
Experienced basis architects audit the legacy hardware and local network topologies for the following critical infrastructure gaps during the discover phase. 1. Generic HANA sizing models. Utilizing standard ERP sizing calculators instead of EWM-specific metrics, severely underestimating the RAM required for high-volume warehouse task generation. 2. Wireless access point saturation, failing to account for peak shift device density, causing local wireless access points to reject new scanner connections when device limits are reached. 3. End-of-life mobile hardware, legacy barcode scanners lacking the modern browser capabilities or memory required to render S/4HANA Fiori or updated RF framework screens. 4. Inadequate IP address pools. DHCP network scopes configured too narrowly, preventing seasonal contractor devices from acquiring network addresses during peak shipping seasons. 5. Suboptimal wide area network latency. High network latency between the central data center and remote distribution centers causing continuous timeouts during synchronous RF barcode scans. 6. Print server bandwidth bottlenecks. Local print spoolers lacking the network bandwidth to handle thousands of high-resolution PDF shipping labels generated simultaneously. 7. Ignored peak season transaction multipliers. Sizing hardware for average daily volumes instead of engineering the infrastructure to withstand Black Friday or end-of-quarter volume spikes. 8. Single points of failure in network switches. Missing redundancy in physical warehouse network switches, risking total floor outages during isolated hardware failures. 9. Insufficient disaster recovery memory. Undersizing the secondary disaster recovery appliances, preventing a full performance failover during a primary data center outage. 10. Edge computing omissions for automation. Failing to provision localized edge servers required to process high-speed PLC telegrams without round-trip data center latency. 11. Virtualization resource constraints. CPU overcommitment, memory contention, or shared virtualization resources, reducing HANA and application server performance under peak warehouse workloads.
Migration incident analysis and root cause why this happens.
Failing to obtain accurate infrastructure sizing and network capacity data typically stems from the following root causes. 1. IT infrastructure teams use generic sizing tools based on active users, ignoring the massive database footprint generated by background EWM transaction volume. 2. Infrastructure governance gap. Hardware procurement, wireless network assessments, and topology upgrades are siloed from the functional EWM blueprint, allowing critical bandwidth dependencies to remain undiscovered. 3. An inaccurate assumption that because legacy green screen RF scanners operate without lag, modern graphical user interfaces will perform identically on the same network. 4. Failing to conduct physical, on-site active and passive wireless network surveys across the entire warehouse floor. 5. Underestimating the procurement lead times required to order, configure, and install hundreds of modern industrial mobile devices.
Business, program, and operational impact.
Underestimating physical infrastructure and sizing introduces critical risks across the project landscape. 1. Program impact. Go-live schedules are suspended entirely as the project team faces months of delays waiting for emergency hardware procurement, upgraded network switches, and replacement mobile devices. 2. Validation testing. Performance testing, stress testing, volume simulation, and mobile device rendering checks fail repeatedly because the underlying infrastructure cannot support the target S/4HANA workloads. 3. Warehouse operations. Forklift drivers and picking staff are physically halted in the aisles as their mobile devices drop network connections or spin with unmanageable lag times after every barcode scan. 4. Operational metrics affected. System response times exceed acceptable thresholds, transaction throughput plummets, HANA database memory utilization hits absolute maximums, and overall warehouse productivity degrades.
Governance and accountability.
We establish clear governance boundaries to manage the technical infrastructure and hardware scope. 1. Decision owner. Enterprise infrastructure architect and lead basis architect, jointly accountable for verifying HANA hardware sizing and local network bandwidth capacities. 2. Review board. Enterprise Architecture Review Board, responsible for auditing proposed hardware procurement plans and disaster recovery topologies. 3. Business Sponsor, IT Infrastructure Director, accountable for funding and executing physical wireless site surveys and network modernization. 4. Supporting Teams, Network Engineering Team, Hardware Procurement Lead, EWM Solution Architect and Infrastructure Operations Team or Data Center Operations Team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the Discover phase to secure your infrastructure readiness. 1. EWM Sizing Execution. Execute specific EWM sizing reports and the SAP Quick Sizer based on peak transaction volumes lines per hour, not just concurrent users. 2. Physical Wireless Site Survey. Conduct rigorous active and passive radio frequency mapping on the warehouse floor, specifically checking high-density racking and cold storage areas for dead zones. 3. Network Performance Validation. Validate latency, packet loss, bandwidth utilization, and wireless roaming behavior to ensure uninterrupted warehouse execution. 4. Mobile Hardware Proof of Concept. Procure sample devices early and physically test them in the warehouse to ensure they can cleanly render S/4HANA Fiori or updated RF framework screens.
EWM infrastructure and sizing deliverables.
A compliant Discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. HANA Sizing and Infrastructure Blueprint. A validated architecture document outlining target in-memory database sizing, CPU core requirements, and application server distribution. 2. Warehouse Wireless Topology Map. A detailed technical document mapping all physical wireless access points, network switches, cabling infrastructures, and IP address scopes. 3. RF Hardware and Peripheral Procurement Plan. A comprehensive catalog specifying the exact models, quantities, and firmware versions for all handheld devices, vehicle-mounted terminals, and industrial printers. 4. Network Latency and Bandwidth Assessment. A formal performance report verifying that wide area network capacities meet the strict sub-second response requirements of continuous mobile execution. Key takeaway. These infrastructure deliverables are the physical bedrock for the S/4HANA EWM blueprint, protecting the project from catastrophic performance failures and day-one hardware incompatibilities.
Infrastructure and hardware readiness metrics.
We track the following critical indicators to manage hardware and sizing risks during the early project phases. 1. HANA Memory Sizing Buffer Ratio, a metric measuring the allocated surplus RAM configured beyond estimated peak season requirements to absorb unexpected transactional spikes. 2. Warehouse Network Performance Compliance Rate, percentage of warehouse zones consistently meeting approved latency, packet loss, and wireless coverage standards. 3. Wireless Access Point Utilization Rate, a quantitative assessment ensuring local access points have sufficient capacity to handle concurrent device connections during shift overlaps. 4. Mobile Device Hardware Refresh Progress, the percentage of obsolete legacy scanners successfully replaced, configured, and tested before integration testing begins. Key takeaway. Quantifying infrastructure sizing and network metrics during Discover is how senior architects protect the program from physical execution bottlenecks.
Follow-up 1. What makes EWM-specific HANA sizing so critical, and why does using standard ERP sizing formulas during Discover create severe architectural risks?
Answer. Sizing an EWM system is vastly different from sizing a standard ERP system. Standard ERP sizing heavily weighs concurrent users and general ledger postings. EWM sizing is driven by micro-transactional execution volume. Every physical pallet movement generates a very high volume of transactional records across warehouse tasks, handling unit updates, and queue histories. Using standard ERP formulas ignores this transactional multiplier, resulting in a severely undersized HANA appliance that will max out its memory during the first peak shift.
Follow-up 2. How do you identify hidden network latency and RF capacity bottlenecks during the Discover phase?
Answer. I do not rely on standard IT network diagrams. I coordinate rigorous active and passive wireless site surveys directly on the physical warehouse floor. We trace network coverage down narrow aisles, inside metal-clad cold storage rooms, and across the shipping docks to locate dead zones. I then perform load testing to verify that the local DHCP scopes and wireless access points can successfully absorb hundreds of devices connecting simultaneously during shift changes.
Follow-up 3 curveball. What do you do when the PMO refuses to upgrade the warehouse wireless network to save budget, arguing that the legacy green screen scanners currently work fine?
Answer: I do not argue the point conceptually. Instead, I present a technical network impact document contrasting legacy character-based data packets with modern graphical S/4HANA mobile screens. I explain that modern interfaces transmit significantly heavier payloads. I demonstrate that forcing high payload browser traffic over a constrained, outdated wireless network will cause continuous scanning timeouts, dropped connections, and massive operator frustration. I ask them to choose between appropriate infrastructure modernization or significantly reduced day one warehouse productivity.
Governance takeaway for this migration incident 39.
Ignoring enterprise infrastructure, HANA sizing, and network bandwidth requirements during discover is a severe governance failure. Always validate wireless topologies, hardware compatibility, and EWM-specific database volumes before entering Explore to protect warehouse performance, operator productivity, and project stability.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Migration Incident 40. RF Hardware and Device Strategy. Existing RF guns, terminals, or mobile devices are incompatible with new Fiori-based or S/4HANA EWM RF frameworks.
During the discover phase, the project team assumes that the existing fleet of ruggedized barcode scanners and vehicle-mounted terminals can be reused seamlessly with S/4HANA EWM. Legacy warehouses frequently rely on obsolete Windows CE devices utilizing basic character-based terminal emulation. Standard S/4HANA mobile execution, whether running modernized ITS mobile or Fiori applications, requires HTML5 compliant browsers, adequate device memory, and graphical screen rendering. Ignoring mobile hardware compatibility early in the project results in illegible screens, massive unbudgeted capital expenditures, and project delays while waiting for hardware procurement lead times. Business objective. Conduct a rigorous audit of the existing mobile device fleet early in the discover phase to establish a hardware modernization, procurement, and mobile device management strategy.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this mobile hardware discovery failure across the following strategic boundaries. 1. Complexity. High enterprise hardware procurement and mobile architecture failure. 2. Frequency. Extremely common in legacy warehousing upgrades. 3. Business process. Mobile hardware strategy and device procurement. 4. Business scope. Enterprise RF device management, capital expenditure planning, mobile user experience, and hardware lifecycle management. 5. EWM deployment type. Not yet decided. 6. Immediate business priority. High. 7. Primary ownership. Enterprise infrastructure architect and mobility lead. 8. Business ownership. IT infrastructure director and warehouse operations director.
Typical legacy, mobile hardware gaps.
Experienced mobility architects audit the physical warehouse floor and device management systems for the following critical mobile hardware constraints during the discover phase. 1. Obsolete operating systems. Fleets running on deprecated Windows CE or Windows mobile platforms that do not support modern application security or browsers. 2. Incompatible web browsers. Devices lacking modern HTML5 rendering engines required to display S/4HANA ITS mobile or Fiori mobile screens. 3. Screen form factor mismatches. Legacy devices utilizing small, character-based resolutions that truncate graphical EWM buttons and critical validation fields. 4. Inadequate device processing power. Older scanners lacking the necessary RAM and CPU capacity to process heavier web-based payloads without severe screen lag. 5. Incompatible mobile device management. Legacy devices that cannot be enrolled in modern enterprise MDM platforms required for centralized deployment and updates. 6. Deprecated barcode scanning wedges. Obsolete scanning firmware that cannot parse concatenated GS1 barcodes or multi-data standard QR codes. 7. Touchscreen versus keyboard constraints. Modern Fiori apps designed for touch navigation conflicting with legacy rugged devices that rely entirely on physical function keys. 8. Inadequate Wi-Fi network interface cards. Devices utilizing obsolete wireless standards that drop connections when roaming between modern access points. 9. End-of-life vendor support. Hardware models that are no longer supported or repaired by manufacturers, leading to rapid attrition of the active device pool. 10. Lack of Android enterprise support. Failure to transition to modern Android-based industrial devices, restricting the adoption of modern warehousing applications. Key insight: the warehouse operator's productivity is entirely dependent on their mobile scanner. Forcing modern graphical software onto obsolete hardware destroys floor efficiency.
Migration incident analysis and root cause why this happens.
Failing to assess mobile hardware compatibility typically stems from the following root causes. 1. IT teams assume that if a legacy RF scanner connects to the network today, IT will automatically render S/4HANA screens tomorrow. 2. Hardware lifecycle governance gap. Mobile device procurement and modernization strategies are managed separately from software transformation projects, hiding hardware obsolescence. 3. Failing to execute physical proof of concept testing by loading S/4HANA standard screens onto the existing legacy device models. 4. Underestimating the massive capital expenditure and global supply chain lead times required to procure and configure hundreds of new ruggedized devices. 5. Project budgets focus entirely on software licensing and implementation consulting, leaving zero allocation for essential hardware modernization.
Business, program, and operational impact.
Ignoring mobile hardware incompatibility introduces critical risks across the project landscape. 1. Program impact. Go-live schedules are suspended and project budgets are shattered as the steering committee is suddenly forced to approve unplanned, high-value capital expenditure requests to replace the entire device fleet. 2. Validation testing. Integration testing, user acceptance testing, and operator training sessions fail because users cannot physically scroll, tap, or view critical fields on their legacy scanner screens. 3. Warehouse operations. Operator frustration spikes as screen rendering lag and dropped connections cause continuous interruptions during high-speed picking and put-away cycles. 4. Operational metrics affected. Scan-to-scan transaction times double, outbound picking productivity drops, and device-related IT helpdesk ticket volumes skyrocket.
Governance and accountability.
We establish clear governance boundaries to manage the mobile hardware and procurement scope. 1. Decision owner. Enterprise infrastructure architect and mobility lead, jointly accountable for validating the technical compatibility of the existing device fleet. 2. Review board. Enterprise architecture review board, responsible for auditing proposed hardware procurement models and MDM integration strategies. 3. Business sponsor. IT infrastructure director, accountable for funding, procuring, and deploying replacement hardware well before validation testing begins. 4. Supporting teams. EWM solution architect, warehouse floor supervisors, mobile device management administrators, and enterprise mobility management team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your mobile hardware readiness. 1. Physical device audit. Catalog the exact make, model, operating system, and browser version of every active handheld and vehicle-mounted terminal on the floor. 2. Screen rendering proof of concept. Load a standard S/4HANA EWM screen onto the oldest active device model to physically verify resolution compatibility and rendering speed. 3. Hardware lifecycle alignment. Cross-reference device inventories with manufacturer end-of-life schedules to justify modernization capital expenditure requests. 4. Procurement lead time validation. Engage hardware vendors early to confirm the global supply chain delivery timelines for ruggedized Android devices.
EWM, Mobile Hardware Discovery Deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. Enterprise Mobile Device Fleet Registry. A detailed hardware inventory mapping device models, operating systems, network cards, and physical form factors. 2. Device compatibility and screen rendering assessment. A formal validation document proving legacy devices can or cannot render target EWM graphical screens. 3. Mobile hardware modernization roadmap. A phase strategy outlining the procurement, staging, and deployment of modern Android-based industrial devices. 4. Device procurement and capital expenditure plan. A finalized financial document detailing the hardware replacement costs, MDM licensing, and delivery lead times. Key takeaway. These mobile hardware deliverables are the physical foundation for the S/4HANA EWM blueprint, protecting the project from catastrophic user experience failures and unbudgeted capital shocks.
Hardware compatibility and readiness metrics.
We track the following critical indicators to manage hardware modernization risks during the early project phases. 1. Mobile hardware compatibility rate. The percentage of the existing device fleet technically certified to render modern S/4HANA EWM interfaces without modification. 2. Device rendering pass rate, a quantitative measurement of test scripts successfully executed on the target hardware without screen truncation or field omissions. 3. Procurement lead time buffer, the tracked timeline comparing estimated hardware delivery dates against the commencement of system integration testing. 4. MDM enrollment compliance, the percentage of procured devices successfully enrolled, configured, and secured within the enterprise mobile device management platform. Key takeaway. Quantifying hardware readiness metrics during Discover is how senior architects protect the program from testing and operational bottlenecks.
Follow-up 1. Why do legacy RF devices frequently fail to operate with modern S/4HANA EWM systems?
Answer. Legacy RF devices, typically running outdated Windows CE operating systems, rely on terminal emulation to display basic, character-based text. S/4HANA EWM modernized frameworks, including updated ITS Mobile and Fiori, deliver modern HTML5-based web interfaces that require contemporary browser engines and greater client-side processing capability. Legacy devices lack the processing memory, modern browser engines, and screen resolutions to physically render these new interfaces, resulting in truncated buttons, unreadable fields, and frozen transactions.
Follow-up 2. How do you identify mobile hardware and device incompatibilities during the Discover phase?
Answer. I do not rely on standard IT asset spreadsheets. I execute a physical hardware audit on the warehouse floor, documenting the oldest active scanner models. I check their operating systems and browser versions. Most importantly, I execute a live proof of concept by forcing a standard S/4HANA EWM transaction screen onto the legacy device to physically demonstrate resolution mismatch and rendering lag to the project sponsors.
Follow-up 3 Curveball. What do you do when the steering committee refuses to approve the CapEx budget to replace legacy scanners, demanding that you customize the new S/4HANA screens to fit the old devices?
Answer. I present a total cost of ownership analysis contrasting hardware costs against software customization debt. I explain that rewriting modern S/4HANA screens into obsolete, character-based formats will require hundreds of hours of custom ABAP development, creating massive technical debt, creating long-term technical debt, increasing maintenance costs, and reducing future upgrade compatibility. I demonstrate that the long-term cost of maintaining customized legacy screens far exceeds the one-time capital expenditure of purchasing modern Android industrial devices.
Governance takeaway for this migration incident 40.
Ignoring mobile hardware compatibility and device procurement lifecycles during Discover is a severe governance failure. Always validate your physical RF fleet, operating systems, and screen rendering capabilities before entering Explore to protect user adoption, testing timelines, and CapEx budgets.
Migration incident 41. Disaster recovery, high availability, and business continuity requirements are not captured during Discovery.
During the Discover phase, the project team treats SAP EWM as a standard back-office application, failing to capture stringent disaster recovery, high availability, and business continuity requirements. EWM is a mission-critical operational execution engine. If the warehouse system goes offline, physical operations halt immediately, trucks back up into the staging yards, and automated conveyors freeze. Applying generic corporate infrastructure policies to EWM results in under-provisioned failover architectures, unacceptable recovery times, and massive revenue loss during inevitable system outages. Business objective. Identify and establish rigorous, EWM-specific recovery time objectives, recovery point objectives, and high availability architectures early in the discover phase to guarantee physical warehouse continuity.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this infrastructure resilience discovery failure across the following strategic boundaries. 1. Complexity, high enterprise architecture and infrastructure resilience failure. 2. Frequency, common when IT infrastructure teams operate independently from warehouse operations. 3. Business process, infrastructure resilience and continuity discovery. 4. Business scope, disaster recovery, high availability, business continuity, RPO and RTO definition. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, enterprise infrastructure architect and lead basis architect. 8. Business ownership, IT infrastructure director and warehouse operations director.
Typical infrastructure resilience gaps.
Experienced architects audit the legacy operational mandates and proposed infrastructure for the following critical continuity gaps during the discover phase. 1. Mismatched RTO and RPO assumptions, applying a standard 24-hour corporate recovery time to a warehouse that requires sub-hour recovery to meet carrier dispatch schedules. 2. Single availability zone deployments, designing cloud or on-premise architectures without geographic redundancy, exposing the entire warehouse to local data center failures. 3. Ignored automation timeouts, failing to account for how automated PLCs and conveyors react during failovers, leading to physical collisions when the secondary database takes over. 4. Unsynchronized application and database replication, configuring HANA system replication for the database, but failing to replicate the application servers and print spools. 5. Lack of manual fallback procedures, omitting the business continuity plans required to dispatch trucks on paper while the system is being restored. 6. Outdated network redundancy plans, designing redundant servers but routing them through a single point of failure network switch in the warehouse facility. 7. Missing peak season failover sizing, sizing the disaster recovery environment for average loads, causing it to crash immediately if a failover occurs on Black Friday. 8. Unmapped third-party logistics dependencies, ignoring the uptime requirements of integrated external carrier portals and customs clearance systems. 9. Incomplete backup retention policies, failing to align the frequency of transaction log backups with the warehouse's strict data loss tolerance limits. 10. Silent failover testing omissions, planning the infrastructure architecture without securing the budget and downtime windows required to physically test the failover twice a year. Key insight: high availability is not a hardware feature, it is an operational mandate. Auditing these resilience gaps during discover prevents catastrophic business paralysis at go-live.
Migration incident analysis and root cause why this happens.
Failing to capture resilience and continuity requirements typically stems from the following root causes. 1. Corporate IT treats the EWM module identically to the core ERP financial system, ignoring the real-time, physical nature of warehouse execution. 2. Resilience governance gap. Enterprise standards for disaster recovery tiers and high availability architectures are not mapped against specific site-level operational downtime costs. 3. Warehouse operations managers are excluded from IT infrastructure scoping, preventing them from defining maximum tolerable outage windows. 4. Underestimating the cloud hosting and hardware budget required to support synchronous, active-active, or active-passive architectures. 5. An inaccurate assumption that cloud-hosted S/4HANA automatically guarantees operational warehouse uptime without explicit configuration.
Business, program, and operational impact.
Under provisioning, infrastructure resilience introduces critical risks across the project landscape. 1. Program impact. The technical architecture must be completely redesigned late in the project when the business finally realizes the proposed infrastructure cannot support their 24/7 operating model. 2. Validation testing. High availability and disaster recovery failover testing expands significantly, often failing repeatedly because the network and application layers were not engineered for seamless redundancy. 3. Warehouse operations. A single hardware failure or cloud zone outage paralyzes the entire distribution center, halting inbound receiving, disabling RF terminals, and causing trucks to miss critical departure windows. 4. Operational metrics affected. Unplanned system downtime duration skyrockets, carrier detention fines accumulate, perishable inventory spoils on the dock, and massive revenue loss occurs per hour of outage.
Governance and accountability.
We establish clear governance boundaries to manage the infrastructure resilience and continuity scope. 1. Decision owner. Enterprise infrastructure architect and lead basis architect, jointly accountable for designing the technical failover and recovery architectures. 2. Review board. Enterprise architecture review board, responsible for auditing proposed disaster recovery tiers against corporate risk tolerance guidelines. 3. Business sponsor. Warehouse operations director, responsible for explicitly defining the maximum acceptable RTO and RPO for physical operations. 4. Supporting teams. Network engineering team, IT security lead, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your continuity boundaries. 1. Operational risk profiling. Conduct workshops with warehouse directors to calculate the exact financial cost of 1 hour of system downtime to justify HA investments. 2. RTO and RPO alignment. Explicitly document and secure sign off on the recovery time, objective and recovery point, objective specific to the EWM instance. 3. Design a formal business continuity plan mapping out manual paper-based fallback procedures for critical inbound and outbound workflows during an outage. 4. Resilience architecture validation. Formally evaluate synchronous database replication, application server redundancy, network failover, and storage replication strategies before approving the target architecture.
EWM resilience and continuity deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. EWM High Availability Architecture Blueprint. A detailed technical document outlining load balancers, application server redundancy, and synchronous database replication paths. 2. RTO and RPO Service Level Matrix, a formally signed document defining the maximum acceptable downtime and data loss tolerances for warehouse operations. 3. Business Continuity and Manual Fallback Guide, a validated operational document detailing how floor operators will process critical shipments on paper during a total system outage. 4. Disaster Recovery Failover Test Plan, a structured governance roadmap defining the frequency, scope, and validation criteria for physical infrastructure failover drills. Key takeaway: these resilience deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from catastrophic operational paralysis and unrecoverable data loss.
Resilience and continuity metrics.
We track the following critical indicators to manage infrastructure risks during the early project phases. 1. Target recovery time objective, the maximum allowable duration in minutes or hours to restore full EWM system functionality following a catastrophic failure. 2. Target recovery point objective, the maximum acceptable limit of transactional data loss, dictating the required frequency of database and log backups. 3. Infrastructure availability compliance rate, the percentage of production infrastructure consistently meeting the approved high availability service level objectives. 4. Failover testing success rate, the mandatory pass rate for executing seamless primary to secondary database and application layer failovers without data corruption. Key takeaway: quantifying continuity metrics during discover is how senior architects protect the program from devastating supply chain shutdowns.
Follow-up 1. What are RTO and RPO, and why does applying standard corporate metrics to EWM create severe operational risks?
Answer: recovery time objective, or RTO, is how long the system can stay down before the business suffers unacceptable damage. Recovery point objective, or RPO, dictates how much data can safely be lost and re-entered. Standard corporate metrics often allow 12 to 24 hours of RTO for back-office systems. Applying this to EWM is a disaster. A warehouse cannot pause truck arrivals or automated conveyors for 12 hours. EWM typically requires an RTO of less than 1 hour and an RPO of near zero to prevent massive supply chain disruption.
Follow-up 2. How do you identify realistic high availability and disaster recovery requirements during the discover phase?
Answer: I do not rely on standard IT infrastructure templates. I conduct structured risk assessment workshops directly with warehouse operations directors. I ask them specific questions. How many trucks back up into the yard if the system goes offline for 30 minutes? What happens to perishable or temperature-sensitive inventory? Can operators physically move pallets without RF scanners? Quantifying this physical pain establishes the baseline for the technical HA architecture.
Follow-up 3 curveball. What do you do when the PMO insists on deploying a single-zone cloud architecture to save budget, arguing that standard cloud availability is sufficient for the warehouse?
Answer: I present a financial and operational impact document contrasting the cloud savings against the cost of a single major outage. I explain that standard single-zone cloud deployments are vulnerable to localized network or facility failures. I demonstrate that an outage during peak season will cost more in carrier detention fines, lost sales, and spoiled inventory than the entire annual cost of a secondary redundant node. I ask them to choose between standard high availability investments now or explaining a total logistics blackout to the board later.
Governance takeaway for this migration incident 41.
Ignoring high availability and disaster recovery requirements during discover is a severe governance failure. Always establish standardized recovery time objectives, failover testing strategies, and business continuity plans before entering explore to protect warehouse operations, automation integrity, and enterprise revenue.
Migration incident 42. Warehouse wireless network coverage assessment ignores high-density RF operating areas.
During the discover phase, the IT network team treats the warehouse wireless infrastructure like a standard corporate office building, relying entirely on predictive software heat maps based on empty floor plans. Standard S4 HANA EWM relies heavily on continuous synchronous mobile execution. In physical reality, 40-foot steel storage racks, dense liquid inventory, roaming forklifts, and metal-clad cold storage vaults severely disrupt wireless signals. Ignoring these physical obstacles during discover results in massive dead zones, dropped operator sessions, and crippled warehouse productivity during integration testing and go live. Business objective: conduct rigorous, active, and physical site surveys in fully stocked warehouse conditions early in the discover phase to guarantee uninterrupted wireless network coverage and seamless device roaming.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this wireless infrastructure discovery failure across the following strategic boundaries. 1. Complexity: high enterprise network infrastructure and physical readiness failure. 2. Frequency: very common in heavy industrial and cold chain storage facilities. 3. Business process: wireless network topology and device connectivity discovery. 4. Business scope: wireless network architecture, radio frequency coverage, network roaming, and mobile infrastructure. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise network architect and mobility lead. 8. Business ownership: IT infrastructure director and warehouse operations director.
Typical wireless network coverage gaps.
Experienced network architects audit the physical warehouse floor and existing wireless access points for the following critical infrastructure gaps during the discover phase. 1. Predictive-only survey failures: relying on software-generated network heat maps that assume empty warehouse space, completely ignoring physical rack density and inventory contents. 2. Signal attenuation from inventory: liquid products, dense paper goods, and metal engine parts physically absorbing or deflecting wireless signals within narrow aisles. 3. Roaming handoff failures: incorrectly configured access points resulting in sticky clients, where mobile devices hold onto a distant, weak signal rather than switching to the nearest antenna. 4. Omnidirectional antenna misuse. Installing standard circular broadcasting access points above tall warehouse racks instead of utilizing focused, directional antennas required to push signals down long aisles. 5. High-density work center saturation. Failing to provision adequate bandwidth over packing and shipping stations where dozens of operators cluster simultaneously during shift changes. 6. Cold storage and freezer vault blocks. Ignoring the thick metal-clad insulation of temperature-controlled zones that completely block external wireless penetration. 7. Mezzanine floor interference. Metal grating on multi-level PIC towers deflecting signals and causing unpredictable wireless connection drops for operators above and below the grating. 8. Co-channel interference. Access points placed too close together on overlapping radio channels, creating signal noise and degrading network speeds. 9. Mobile hardware antenna variances. Upgrading the network without realizing the legacy handheld devices lack the internal antenna strength to receive the upgraded signal. 10. Automated equipment interference. High-voltage motors in automated storage and retrieval systems generating electromagnetic interference that disrupts nearby wireless communications. Key insight: a wireless network map is useless if the warehouse is empty. Auditing coverage in fully stocked conditions during discover prevents catastrophic scanning failures at go-live.
Migration incident analysis and root cause why this happens.
Failing to secure robust wireless network coverage typically stems from the following root causes. 1. Corporate IT network engineers treat the industrial warehouse identically to a carpeted office environment, utilizing the exact same hardware and survey methodologies. 2. Network infrastructure governance gap. Enterprise standards for industrial wireless roaming, directional antenna placement, and physical obstacle attenuation are not centrally governed, allowing flawed predictive surveys to dictate procurement. 3. Warehouse operations managers are excluded from wireless network planning, preventing them from highlighting high-density operational zones and physical dead spots. 4. Underestimating the budget required to perform rigorous, active physical site surveys on foot across millions of square feet of warehouse space. 5. An inaccurate assumption that intermittent connectivity drops are a software performance issue rather than a physical network layer failure.
Business, program, and operational impact.
Under-provisioning wireless infrastructure introduces critical risks across the project landscape. 1. Program impact. Go-live dates are delayed by months because resolving physical dead zones requires ordering, cabling, and installing new hardware access points across active operational facilities. 2. Validation testing. Integration testing, user acceptance testing, and mobile device validation expand significantly and fail repeatedly as operators are inexplicably disconnected mid-transaction. 3. Warehouse operations. Forklift drivers are physically halted in narrow aisles as their mobile sessions drop. Operators are forced to repeatedly restart applications and re-scan barcodes, destroying shift productivity. 4. Operational metrics affected. Scan-to-scan transaction times double. System response latency spikes. Outbound picking productivity drops, and IT help desk ticket volumes for system slowness skyrocket.
Governance and accountability.
We establish clear governance boundaries to manage the wireless network architecture scope. 1. Decision owner. Enterprise network architect and mobility lead, jointly accountable for verifying physical warehouse network coverage and hardware specifications. 2. Review board. Enterprise Architecture Review Board, responsible for auditing the proposed wireless topologies against corporate continuity standards. 3. Business sponsor. IT Infrastructure Director, accountable for funding physical site surveys, procuring specialized directional antennas, and funding cabling upgrades. 4. Supporting teams. Network Engineering Team, EWM Solution Architect, and Warehouse Floor Supervisors.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your network boundaries. 1. Active and passive physical site surveys. Mandate physical walkthroughs with signal measuring equipment while the warehouse is fully stocked and operating at peak capacity. 2. Network roaming configuration audit. Explicitly test and configure wireless LAN controllers to forcefully hand off mobile devices to the nearest access point to prevent sticky clients. 3. Deploy highly focused, directional antennas in all narrow, high-density storage aisles instead of standard circular broadcasting office hardware. 4. Perform rigorous load testing in high-density areas, such as shift change staging lanes and packing stations, to ensure access points can handle massive concurrent connection spikes.
EWM Wireless Network Discovery Deliverables.
A compliant discover phase must exit with the following concrete readiness deliverables before starting the blueprint. 1. Warehouse Wireless Topology Heat Map. A validated physical site survey report documenting exact signal strengths, dead zones, and interference points across all fully stocked facilities. 2. Access point placement and antenna blueprint. A detailed architectural design specifying exact cabling drop locations, directional antenna models, and elevation heights. 3. Network roaming and handoff configuration map. A technical specification detailing the minimum signal thresholds required for the controller to execute seamless roaming transitions. 4. Industrial network remediation plan. A formal procurement and installation timeline to replace outdated switches, run new fiber optics, and mount necessary access points before integration testing begins. Key takeaway: these wireless deliverables are the invisible foundation for the S/4HANA EWM blueprint, protecting the project from catastrophic scanning delays and false performance escalations.
Wireless resilience and connectivity metrics.
We track the following critical indicators to manage wireless infrastructure risks during the early project phases. 1. Warehouse wireless coverage compliance. The percentage of active warehouse operating zones consistently meeting the approved minimum signal strength threshold. 2. Roaming handoff success rate. The target percentage of seamless access point transitions executed without dropping the active application session layer. 3. Access point capacity utilization. A metric measuring the maximum number of concurrent mobile clients supported per antenna during peak operating shifts. 4. Network latency threshold. The strict verification that all packet round-trip times between the mobile device and the application server remain under 50 milliseconds. Key takeaway: quantifying wireless connectivity metrics during discover is how senior architects protect the program from devastating supply chain slowdowns.
Follow-up 1. What is network roaming in a warehouse environment, and why does EWM fail if it is not configured correctly?
Answer: network roaming is the process where a mobile device moving down a long warehouse aisle seamlessly disconnects from a fading access point and connects to a stronger one without interrupting the user. EWM relies on continuous, synchronous network connections. If roaming is configured poorly, the scanner becomes a sticky client, holding onto the weak signal until it physically drops. The EWM session immediately times out, kicking the operator out of their active warehouse task and forcing the operator to reconnect, re-authenticate, or restart the interrupted warehouse transaction.
Follow-up 2. How do you identify hidden network dead zones and wireless vulnerabilities during the discover phase?
Answer: I explicitly reject predictive software heat maps. Instead, I mandate active and passive site surveys executed by network engineers walking the physical floor with testing equipment. This must be done while the warehouse is fully stocked to measure the severe signal absorption caused by metal racking, dense pallets, and liquid inventory. We analyze packet loss, signal interference, and access point handoff speeds in real time.
Follow-up 3. Curveball. What do you do when the PMO refuses to fund physical site surveys because the vendor provided a software heat map showing 100% coverage?
Answer: I present a technical risk assessment explaining that software predictive models assume empty warehouse space. I share industry case studies demonstrating how fully stocked 40-foot steel racks and liquid storage physically absorb wireless signals, instantly turning green heat maps into total dead zones. I demand a small, physical proof of concept in the densest operating aisle. Once the devices inevitably drop connections in the test aisle, the PMO immediately approves the full physical network survey.
Governance takeaway for this migration incident 42.
Ignoring the physical reality of warehouse wireless networks during discover is a severe governance failure. Always mandate active, fully stocked physical site surveys, directional antenna blueprints, and roaming configuration validations before entering Explore to protect user adoption, operator productivity, and project stability.
Migration Incident 43. Rise with SAP hosting assumptions, conflict with existing warehouse infrastructure, network, and automation requirements.
During the Discover phase, executive leadership mandates a rise with SAP cloud deployment strategy, assuming that S/4HANA EWM can be hosted seamlessly in the cloud alongside core financial systems. While cloud hosting provides excellent scalability for standard back-office ERP functions, EWM is a real-time execution engine, pushing highly automated warehouse control systems, high-volume print spooling, and synchronous mobile barcode scanning into a remote cloud data center introduces unmanageable network latency. Ignoring these physical hosting constraints early results in automation timeouts, crippled floor productivity, and warehouse shutdowns during standard cloud maintenance windows. Business objective: conduct a rigorous cloud latency, automation, and local survivability assessment early in the Discover phase to determine whether a centralized cloud or a decentralized edge computing EWM architecture is required.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this cloud hosting discovery failure across the following strategic boundaries. 1. Complexity: high enterprise cloud architecture and automation latency failure. 2. Frequency: very common in RISE with SAP strategic transformations. 3. Business process: cloud hosting architecture and edge computing discovery. 4. Business scope: cloud hosting architecture, edge computing, network latency, and infrastructure sizing. 5. EWM deployment type: assumed embedded cloud without technical validation. 6. Immediate business priority: high. 7. Primary ownership: enterprise cloud architect and lead basis architect. 8. Business ownership: IT infrastructure director and transformation sponsor.
Typical cloud versus local infrastructure gaps.
Experienced enterprise architects audit the legacy warehouse automation and network capabilities for the following critical cloud hosting conflicts during the Discover phase. 1. Material flow system latency constraints: automated conveyors and PLCs require sub-20 millisecond response times that wide area network cloud connections cannot physically guarantee. 2. High-volume print spooling bottlenecks: centralized cloud servers pushing thousands of heavy graphical shipping labels down the network pipe, saturating local warehouse bandwidth. 3. Cloud maintenance window clashes: standard, non-negotiable cloud patching schedules enforcing weekend downtimes that paralyze 24/7 distribution centers. 4. Lack of local survivability: entire warehouses coming to a hard stop because a regional internet service provider experiences a temporary routing outage. 5. Synchronous mobile scanning delays: handheld mobile scanners experiencing compounded round-trip network delays, forcing operators to wait seconds between consecutive box scans. 6. Obsolete legacy hardware incompatibility: local legacy scale systems or automated guided vehicles requiring direct, local area network socket connections that cannot route securely to public clouds. 7. Inadequate edge computing scoping: failing to plan for decentralized EWM installations on local edge servers to process high-speed automation independently from the central ERP. 8. Cybersecurity gateway friction: aggressive corporate firewalls inspecting every packet traveling between the warehouse floor and the cloud, adding artificial latency to real-time execution. 9. Disaster recovery time objective mismatches: cloud recovery service level agreements that guarantee a 12-hour restore, which is catastrophic for time-sensitive, perishable logistics. 10. Unbudgeted network redundancy costs: failing to budget for enterprise-grade, redundant dark fiber lines required to stabilize cloud-dependent warehouse operations. 11. Cloud region placement constraints: selecting a cloud region that satisfies corporate governance but introduces excessive network latency because it is geographically distant from the warehouse operations. Key insight: the speed of light is a hard architectural boundary. Auditing network latency during Discover prevents cloud-hosted EWM from strangling physical conveyor automation.
Migration incident analysis and root cause why this happens.
Failing to evaluate the physical constraints of cloud hosting typically stems from the following root causes. 1. Executive leadership treats S/4HANA EWM identically to the core financial system, assuming a cloud-first mandate applies uniformly to all business modules. 2. Cloud architecture governance gap. Enterprise standards for edge computing, acceptable network latency, and local survivability are not centrally governed, allowing commercial cloud contracts to dictate physical warehouse architectures. 3. An inaccurate assumption that massive internet bandwidth solves network latency, ignoring the physical routing hops between the warehouse and the hyperscaler data center. 4. Failing to conduct physical, on-site telemetry testing of automated equipment against simulated cloud network connections. 5. Excluding warehouse operations directors and automation engineers from the cloud deployment strategy workshops.
Business, program, and operational impact.
Forcing highly automated warehouses into incompatible cloud architectures introduces critical risks across the project landscape. 1. Program impact. The project architecture must undergo a massive, unplanned pivot late in the explore phase, shifting from an embedded cloud model to a decentralized on-premise EWM model, shattering the original deployment timeline. 2. Validation testing. Automation integration testing, PLC telemetry validation, load testing, and print spooling performance checks fail repeatedly as network latency causes continuous handshake timeouts. 3. Warehouse operations. The physical warehouse experiences rolling brownouts, conveyors stall, label printers choke during peak waves, and operators are entirely locked out during mandatory cloud maintenance windows. 4. Operational metrics affected. System response times spike. Automated equipment utilization plummets. Outbound truck departures are missed, and overall supply chain resilience drops.
Governance and accountability.
We establish clear governance boundaries to manage the cloud hosting and edge computing scope. 1. Decision owner, enterprise cloud architect and lead integration architect, jointly accountable for verifying cloud latency constraints against physical warehouse requirements. 2. Review board, enterprise architecture review board, responsible for auditing proposed hosting models and validating the need for decentralized edge computing. 3. Business sponsor, IT infrastructure director, accountable for funding redundant network circuits and local edge servers if cloud hosting proves unviable. 4. Supporting teams, network engineering team, warehouse automation engineers, and EWM solution architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the Discover phase to secure your cloud hosting boundaries. 1. Cloud telemetry simulation. Execute prolonged ping tests, trace routes, and packet loss analyses from the local warehouse floor directly to the target hyperscaler cloud region. 2. Decentralized edge evaluation. Formally evaluate a decentralized EWM architecture deployed on local, on-premise hardware if the facility relies heavily on millisecond-dependent automation. 3. Maintenance window alignment. Cross-reference the non-negotiable cloud patching schedules against the warehouse's 24/7 operating shifts and peak seasonal calendars. 4. Print spool topology design. Architect a robust local print server topology to cache and distribute heavy graphical labels locally, preventing wide area network saturation.
EWM cloud readiness and edge computing deliverables.
A compliant Discover phase must exit with the following concrete architectural deliverables before starting the blueprint. 1. Cloud latency and network telemetry report. A formal assessment documenting round-trip transmission speeds, jitter, and packet loss between the warehouse and the cloud data center. 2. Decentralized EWM and edge computing feasibility blueprint. A technical architecture document evaluating the operational necessity of deploying localized servers to guarantee automation survivability. 3. RISE with SAP maintenance window alignment charter. A signed governance document resolving scheduling conflicts between required cloud updates and physical warehouse operating hours. 4. Print and automation network bandwidth sizing map. A validated specification calculating the wide area network throughput, required to sustain peak label printing and telemetry loads. Key takeaway: these cloud readiness deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from catastrophic performance failures dictated by incompatible commercial hosting contracts.
Cloud resilience and latency metrics.
We track the following critical indicators to manage cloud hosting risks during the early project phases. 1. Cloud-to-warehouse network performance compliance. The percentage of measurements consistently meeting approved latency, jitter, and packet loss thresholds required for warehouse operations. 2. Wide area network bandwidth saturation rate. A metric measuring peak data loads against the total available capacity of the external internet circuit. 3. Automation socket timeout threshold. The strict limit on acceptable latency before the material flow system drops the connection to an automated crane or conveyor. 4. Local survivability uptime target. The required operational uptime for the physical warehouse in the event of a total loss of external cloud connectivity. Key takeaway: quantifying cloud network metrics during discover is how senior architects protect the program from devastating supply chain slowdowns.
Follow-up 1. Why does a rise with SAP Cloud Hosting Strategy pose a unique architectural risk for automated S/4HANA EWM deployments?
Answer: while cloud hosting is highly efficient for standard ERP processes, it introduces unavoidable physical network latency. An automated warehouse relies on the EWM material flow system to send sub-second TCP or IP instructions to physical PLCs driving conveyor belts and cranes. If the EWM database is hosted in a remote cloud data center, that latency causes the mechanical equipment to miss its processing window, leading to conveyor stoppages, synchronization failures, automation timeouts, and significant operational disruption, stalled lines, and unmanageable operational friction.
Follow-up 2. How do you identify cloud hosting conflicts and automation latency risks during the discover phase?
Answer: I do not rely on standard commercial cloud SLAs. I mandate physical network telemetry tests, tracking ping latency and packet drop rates from the actual warehouse floor to the target hyperscaler region. I cross-reference the cloud provider's mandatory weekend maintenance windows against the warehouse's active shift schedules. Finally, I audit the existing automation footprint to calculate the exact millisecond threshold required to keep the active PLCs and check weighers running smoothly.
Follow-up 3 curveball. What do you do when the CIO mandates a public cloud deployment to fulfill a global IT strategy, but your assessment proves the highly automated warehouse will suffer severe latency outages?
Answer: I do not challenge the overarching cloud strategy. Instead, I propose a hybrid architectural compromise, standardizing the core S/4HANA ERP in the public cloud while deploying decentralized EWM on a localized, on-premise edge server within the warehouse facility. I present an architecture document proving that this decoupled design satisfies the CIO's cloud mandate for enterprise data while guaranteeing local survivability, sub-millisecond automation latency, and uninterrupted 24/7 operations for the logistics team.
Governance takeaway for this migration incident 43.
Ignoring cloud network latency and local survivability requirements during discover is a severe governance failure. Always evaluate edge computing architectures, cloud maintenance schedules, and automation bandwidth limits before entering Explore to protect warehouse performance, equipment synchronization, and project stability.
Category 7. Technical readiness and platform assessment conclusion.
To summarize Category 7, the physical infrastructure and technical hosting platform represent the absolute foundation of your S/4HANA EWM deployment. Failing to validate prerequisite SAP notes, undersizing HANA memory, ignoring obsolete RF hardware, and misaligning RISE with SAP cloud latency constraints guarantees a catastrophic go-live. A pristine EWM configuration is entirely useless if the underlying network cannot sustain sub-second barcode scans, or if the database crashes under transactional volume.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from infrastructure to operational visibility.
With our physical network, database sizing, and cloud latency boundaries firmly secured, we must now pivot to how the business actually monitors and controls the warehouse. The most resilient infrastructure and perfectly designed material flows mean nothing if warehouse supervisors are left operationally blind. We will now transition into Category 8, Analytics and Reporting Discovery, where we analyze the severe risks of assuming modern analytics will automatically replace decades of custom legacy reporting.
Category 8, Analytics and Reporting Discovery.
In S/4HANA EWM, operational visibility dictates physical execution efficiency. Historically, warehouses have compensated for standard ERP reporting gaps by building massive, highly customized ALV reports, relying on the logistics information system, or extracting data to external BW or BI cubes. Category 8 deep dives into the critical risks of ignoring this legacy reporting landscape during the discover phase, preventing a scenario where the business goes live without the basic dashboards required to manage shift productivity.
Analytics and Reporting Discovery, Incident 44.
To prevent post-go-live operational blindness, a thorough discover phase must systematically audit and document the legacy analytics landscape. Incident 44. Legacy warehouse reporting, operational dashboards, and custom BW, BI, and LIS reports are incorrectly assumed to be automatically replaced by S/4HANA embedded analytics. Let's dive into Incident 44.
Migration Incident 44. Legacy warehouse reporting, operational dashboards, and custom BW, BI, and LIS reports are incorrectly assumed to be automatically replaced by S/4HANA embedded analytics.
During the discover phase, the project team assumes that standard S/4HANA embedded analytics and core data services will effortlessly replace decades of legacy warehouse reporting out of the box. Legacy warehouse operations heavily depend on custom Z reports, complex ALV grids, logistics information system structures, and overnight extractions to SAP BW or BI to manage daily shift productivity. Ignoring this deeply ingrained custom reporting landscape during discover guarantees that warehouse supervisors will lose total operational visibility at go live, paralyzing floor-level decision-making. Business objective: identify, audit, and rationalize the entire legacy warehouse reporting and analytics footprint early in the discover phase to establish a realistic, standard-aligned S/4HANA reporting modernization roadmap.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this reporting and analytics discovery failure across the following strategic boundaries. 1. Complexity: high enterprise analytics architecture and visibility failure. 2. Frequency: extremely common in long-standing ERP landscapes. 3. Business process: operational reporting, analytics, and dashboard discovery. 4. Business scope: S/4HANA embedded analytics, legacy BW and BI integrations, CDS views, and custom reporting decommissioning. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise analytics architect and EWM solution architect. 8. Business ownership: warehouse operations director and business intelligence lead.
Typical legacy reporting and analytics gaps.
Experienced architects audit the legacy execution systems and business intelligence platforms for the following critical reporting structures during the discover phase. 1. Custom ALV grids and Z reports: thousands of custom ABAP reports built specifically to combine fragmented legacy tables like LQUA and LTAK into unified shift supervisor views. 2. Logistics information system dependencies: heavy reliance on obsolete LIS structures and early warning systems that are entirely deprecated in the S/4HANA architecture. 3. Offline Excel workarounds: shift leads downloading multiple standard SAP reports into localized Excel macros to manually calculate daily picking productivity. 4. Heavy BW and BI data extractions: critical operational logic built directly into external SAP BW cubes rather than existing in the core transactional ERP system. 5. Custom end-of-day reconciliation scripts: proprietary background jobs cross-referencing warehouse movements against financial postings to detect missing inventory. 6. Unmapped third-party visualization tools: external dashboards operating on Tableau or Power BI that rely on direct database queries to deprecated legacy tables. 7. Missing real-time doc visibility: Custom monitors used by shipping coordinators to track carrier detention risks, which do not exist in standard EWM. 8. Labor tracking and time motion reports. Legacy custom tools tracking operator scan rates and physical travel distances without utilizing standard labor management engines. 9. Dynamic quality status dashboards. Custom cockpits aggregating pending quality inspections, blocked bins, and restricted batches for daily release approvals. 10. Obsolete user variants and layouts. Thousands of saved background selection variants that dictate daily operational reporting routines.
Migration incident analysis and root cause why this happens.
Failing to scope operational analytics and legacy reporting typically stems from the following root causes. 1. IT teams assume standard S/4HANA embedded analytics and Fiori dashboards automatically cover all legacy custom reporting requirements out of the box. 2. Analytics governance gap. Enterprise standards for data visualization, CDS view development, and report decommissioning are not centrally governed, allowing obsolete Z reports to bypass review. 3. A complete failure to audit system transaction usage logs like ST03N to identify which legacy warehouse reports are actually executed on a daily basis. 4. Excluding warehouse shift supervisors and floor planners, the actual consumers of operational data, from early discover scoping workshops. 5. Underestimating the technical effort required to model new core data services views to replicate complex, multi-table legacy ALV joins.
Business, program, and operational impact.
Omitting legacy reporting dependencies introduces critical risks across the project landscape. 1. Program impact. Immediate timeline delays during the realize phase as functional consultants are flooded with unplanned RICEFW enhancement requests to rebuild missing reports critical to daily operations. 2. Validation testing. User acceptance testing stalls completely because warehouse managers refuse to sign off on the new system without proof that they can monitor their daily labor and staging backlogs. 3. Warehouse operations. At Go Live, shift supervisors lose all visibility into inbound dock congestion, outbound wave completion statuses, and individual picker productivity, resulting in severe operational paralysis. 4. Operational KPIs affected. Order fulfillment cycle times degrade, labor allocation efficiency plummets, carrier wait times increase due to staging blindness, and overall warehouse throughput drops.
Governance and accountability.
We establish clear governance boundaries to manage the analytics and legacy reporting scope. 1. Decision owner. Enterprise Analytics Architect and EWM Solution Architect, jointly accountable for mapping legacy reports to target S/4HANA CDS views and Fiori apps. 2. Review Board. Enterprise Architecture Review Board, responsible for auditing proposed custom reporting developments and enforcing standard embedded analytics adoption. 3. Business Sponsor. Warehouse Operations Director, responsible for providing a comprehensive inventory of all critical daily, weekly, and monthly operational metrics. 4. Supporting teams. Business Intelligence Lead, a BAP development team, and local shift supervisors.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your analytics boundaries. 1. Systematic usage analysis. Extract transaction usage logs ST03N and background job histories SM37 to empirically prove which legacy reports are actively used versus abandoned. 2. Execute a comprehensive technical audit of all active legacy LIS structures, custom ALV grids, and third-party dashboard data sources. 3. Map standard EWM warehouse monitor nodes and standard Fiori analytical apps against validated business requirements before approving custom CDS development. 4. Supervisor dashboard workshops. Conduct hands-on workshops with shift leads, focusing purely on the business question they need answered, rather than replicating the exact layout of their legacy Excel sheets.
EWM analytics and reporting discovery deliverables.
A compliant discover phase must exit with the following concrete analytical deliverables before starting the blueprint. 1. Legacy report usage and decommissioning log. A comprehensive, data-driven inventory documenting all legacy Z reports, their actual execution frequencies, and retirement statuses. 2. EWM Analytics Fit Gap Matrix, a detailed logical design blueprint mapping, required operational metrics to standard S/4HANA Embedded Analytics, CDS views, or the EWM Warehouse Monitor. 3. S/4HANA Reporting Modernization Roadmap, a phased architecture document defining which visualizations will reside in Fiori, which require external BW or BI, and which demand custom development. 4. Operational Dashboard Specification, a validated document defining the exact KPIs, drill-down paths, and real-time refresh rates required for floor supervisor cockpits. Key takeaway: these analytical deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from going live operationally blind and preventing massive post-go-live reporting rebuilds.
Reporting complexity and visibility metrics.
We track the following critical indicators to manage analytics and visibility risks during the early project phases. 1. Standard analytics adoption rate, the target percentage of operational metrics fulfilled by unmodified, out-of-the-box S/4HANA embedded analytics in standard Fiori tiles. 2. Legacy report retirement progress, the percentage of obsolete Z reports, LIS structures, and legacy analytical assets approved for retirement. 3. Custom CDS View Complexity Score, a metric tracking the volume and complexity of custom core data services views required to replace legacy ALV grid logic. 4. Operational Dashboard Coverage, the percentage of critical warehouse operational roles, for example, receiving lead, shipping lead, that possess a fully mapped, standard-aligned visibility dashboard. Key takeaway: quantifying analytics complexity metrics during Discover is how senior architects protect the program from standard process deviations.
Follow-up 1. What is S/4HANA Embedded Analytics, and why does assuming it automatically replaces legacy BW and BI cubes during Discover ruin the EWM blueprint?
Answer: S/4HANA Embedded Analytics provides real-time, operational reporting directly on the transactional database using Virtual Core Data Services, or CDS views. It is brilliant for real-time visibility, but it is fundamentally different from a legacy BW and BI cube, which stores persisted, historical data slices for massive trend analysis. Assuming embedded analytics replaces everything ignores this architectural difference. If you fail to map heavy historical trend reporting during Discover, your operational reporting environment may experience unnecessary performance overhead, because real-time transactional reporting is being used for workloads better suited to historical analytical platforms when users attempt to run multi-year historical queries.
Follow-up 2. How do you identify hidden legacy warehouse reporting dependencies and custom ALV variants during the Discover phase?
Answer: I do not rely on standard documentation or user memory, because users often request reports they haven't run in years. I execute transaction ST03N and analyze background job logs in SM37 to extract empirical data on exact report execution frequencies. I then conduct physical shadowing sessions with shift supervisors, asking them to show me the exact offline Excel spreadsheets and custom ALV grids they use to track daily dock bottlenecks and labor productivity.
Follow-up 3. Curveball. What do you do when a warehouse manager insists on rebuilding a 20-year-old, highly complex custom Z report exactly as it is in S/4HANA Fiori?
Answer: I do not debate the technical limitations of building massive ALV grids in Fiori. Instead, I focus the conversation on the business outcome. I ask the manager, what exact operational decision are you trying to make when you look at column G? Once they explain the business problem, for example, identifying delayed outbound deliveries, I demonstrate a standard S/4HANA analytical Fiori tile that provides that exact insight visually in real time, eliminating the need to download and pivot data entirely. We align on standardizing the business outcome, not replicating the legacy technical layout.
Governance takeaway for this migration incident 44.
Ignoring legacy reporting, operational dashboards, and analytics architectures during Discover is a severe governance failure. Always establish a complete inventory of active operational metrics, CDS view requirements, and legacy report retirement plans before entering Explore to protect warehouse visibility floor-level decision-making, and blueprint stability.
Category 8, Analytics and Reporting Discovery Conclusion.
To summarize Category 8, failing to audit the legacy reporting landscape leaves the warehouse operationally blind at go-live. S/4HANA embedded analytics and core data services are immensely powerful, but assuming they automatically replicate decades of custom ALV grids, logistics information system structures, and offline Excel tracking without a formal fit gap assessment guarantees a post-go-live stabilization crisis. True operational visibility must be designed, not assumed.
Transition from analytics to program governance.
We have now covered strategy, processes, landscapes, master data, custom code, automation, infrastructure, and analytics. However, the most technically perfect S/4HANA EWM blueprint will shatter if the human and organizational governance surrounding the project is flawed. We will now transition into Category 9, Governance and Project Readiness, where we address the fatal program risks of excluded business stakeholders and misaligned global templates.
Category 9, Governance and Project Readiness.
In S/4HANA EWM enterprise transformations, project readiness dictates the trajectory of the entire implementation. Category 9 deep dives into the critical risks of project mobilization, focusing on the catastrophic scope creep that occurs when key warehouse floor stakeholders are excluded from discovery, and the rollout paralysis that strikes when rigid global templates conflict with local, site-specific physical operational realities.
Governance and Project Readiness Incidents 45 and 46.
To secure program stability and minimize late-stage scope explosions, the Discover phase must actively manage these two critical governance domains. Incident 45. Key warehouse business stakeholders are not engaged early, resulting in major scope changes after project kickoff. Incident 46. Global template assumptions conflict with local warehouse operational requirements across different countries. Let's dive into Incident 45.
Migration Incident 45. Key warehouse business stakeholders are not engaged early, resulting in major scope changes after project kickoff.
During the Discover phase, IT leadership scopes the S/4HANA EWM project alongside high-level supply chain executives, but fails to engage the actual shift supervisors, floor managers, and local logistics coordinators who run the daily operations. Because warehouse execution is intensely physical, these excluded stakeholders rely on undocumented manual workarounds, specific shift handovers, and carrier agreements that executives are completely unaware of. When these floor stakeholders finally see the system design during the Explore phase, they reject IT entirely, triggering massive, unbudgeted scope changes. Business objective: identify and engage all operational, tactical, and strategic warehouse stakeholders early in the Discover phase to secure an accurate, comprehensive project scope and ensure floor-level user adoption.
Incident Classification.
To establish clear parameters, we classify this stakeholder governance failure across the following strategic boundaries. 1. Complexity: high enterprise scoping and stakeholder management failure. 2. Frequency: very common in IT-led and top-down transformations. 3. Business process: stakeholder mapping and scope definition. 4. Business scope: project mobilization, organizational readiness, scope governance, and business alignment. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: program manager and change management lead. 8. Business ownership: logistics operations director and program sponsor.
Typical excluded stakeholder impacts.
Experienced architects ensure the following critical operational roles are included in discovery, preventing these common scoping blind spots. 1. Night shift supervisors: missing off-hours system reconciliation procedures and automated background job dependencies. 2. Returns and reverse logistics coordinators: overlooking highly manual, chaotic customer return triage and quality inspection workflows. 3. Carrier dispatch and dock planners: missing critical external integration requirements with regional transportation partners and freight forwarders. 4. Warehouse safety and compliance officers: ignoring local hazardous material segregation rules and environmental reporting laws. 5. Inventory control and cycle counters: missing localized physical inventory tolerances and dynamic stock consolidation habits. 6. Third-party labor union representatives: implementing engineered labor standards or task tracking without mandatory union negotiations, halting the project legally. 7. Packaging and industrial engineers, missing critical physical dimensions for cartonization and automated pallet building. 8. Local customs and trade compliance leads, omitting critical duty, unpaid stock isolation rules for bonded warehouses. Key insight: the corporate organizational chart does not run the warehouse. Auditing and engaging the actual floor-level decision-makers during Discover prevents massive blueprint rejection.
Migration incident analysis and root cause why this happens.
Failing to engage key warehouse stakeholders typically stems from the following root causes. 1. Project initiation is driven entirely by corporate IT and finance departments, treating the warehouse as a generic back-office function rather than a physical execution center. 2. Stakeholder governance gap. There is no formal stakeholder mapping process required to exit the Discover phase, allowing critical operational voices to be bypassed. 3. Logistics directors assume they fully understand the daily operations of their facilities, underestimating the undocumented tribal knowledge used by floor workers. 4. Project managers intentionally restrict workshop attendance to keep the scope small, creating a false economy that explodes during blueprinting. 5. A failure to physically visit the warehouse floor, relying instead on conference room discussions at corporate headquarters.
Business, program, and operational impact.
Excluding operational stakeholders introduces critical risks across the project landscape. 1. Program impact. Massive scope creep during the explore phase as functional consultants uncover hidden physical processes, leading to immediate budget overruns and timeline extensions. 2. Validation testing. SIT and UAT cycles stall because test scripts do not reflect physical reality, and the floor operators refuse to sign off on the system. 3. Warehouse operations. Operator trust is destroyed before go live. Users actively resist the new S/4HANA EWM system because they feel it was forced upon them by headquarters without consulting their expertise. 4. Operational readiness. Change management efforts fail because the training materials do not address the actual pain points of the shift supervisors.
Governance and accountability.
We establish clear governance boundaries to manage stakeholder engagement. 1. Decision owner. Program manager and change management lead, jointly accountable for completing the enterprise stakeholder map and engagement plan. 2. Review board. Program Steering Committee, responsible for verifying that operational representatives are formally assigned to the project structure. 3. Business Sponsor, Global Logistics Director, accountable for releasing floor supervisors and SMEs from daily duties to participate in discovery workshops. 4. Supporting teams, EWM Solution Architect, HR Business Partners, and Enterprise Architect.
Real implementation tips and best practices.
Apply the following strategic guidelines during the Discover phase to secure stakeholder alignment. 1. Operational shadowing. Mandate that IT architects and PMO leads physically walk the warehouse floor across multiple shifts, including night shifts, to observe undocumented processes. 2. Formal stakeholder mapping. Build a comprehensive matrix mapping every operational warehouse role to their level of influence and required project involvement. 3. Appoint respected, vocal floor supervisors as operational process owners to champion the S/4HANA EWM design within the warehouse. 4. Conduct structured pain point workshops strictly with floor-level operators to capture raw feedback without executive filtering.
EWM stakeholder discovery deliverables.
A compliant Discover phase must exit with the following concrete governance deliverables before starting the blueprint. 1. Enterprise Stakeholder Register, a documented catalog of all executive, tactical, and operational stakeholders, including union representatives and compliance officers. 2. Project RACE Matrix, a formally signed document explicitly defining who is responsible, accountable, consulted, and informed for each EWM functional domain. 3. Warehouse Process Owner Charter, a governance document formally releasing appointed warehouse floor supervisors to the project team with dedicated time allocations. 4. Organizational Change Management Strategy, a baseline blueprint outlining communication, readiness tracking, and engagement plans for the warehouse floor. Key takeaway. These governance deliverables are the foundation for the S/4HANA EWM project structure, protecting the program from late-stage scope expansion, user resistance, and organizational adoption failures.
Governance and stakeholder readiness metrics.
We track the following critical indicators to manage stakeholder alignment risks during the early project phases. 1. Stakeholder engagement coverage. The percentage of identified operational roles formally represented in Discover phase workshops. 2. Process owner allocation rate. The verified percentage of full-time equivalent hours officially released by the business for warehouse subject matter experts. 3. RACI matrix sign-off rate. The percentage of functional domains with fully documented and executive-approved accountability assignments. 4. Organizational alignment score. A qualitative readiness score derived from early floor-level pulse surveys tracking confidence in the transformation program. Key takeaway. Quantifying stakeholder alignment early in Discover is how program managers protect the project from passive resistance and scope denial.
Follow-up 1. Why is engaging floor-level warehouse stakeholders during the Discover phase critical for S/4HANA EWM migrations?
Answer. S/4HANA EWM is a highly physical execution engine, not just a financial ledger. While executives understand the macro supply chain strategy, the actual floor-level shift supervisors and operators understand the physical bottlenecks, carrier scheduling quirks, and manual workarounds keeping the building running. If you do not capture this operational reality during Discover, the blueprint will reflect a theoretical fantasy, leading to massive redesigns and user rejection during integration testing.
Follow-up 2. How do you identify and engage hidden operational stakeholders during project scoping?
Answer. I do not rely on the corporate organizational chart. I perform multi-shift physical shadowing, walking the warehouse floor during the day shift, night shift, and weekend shifts. I identify the informal leaders, the dispatchers, lead forklift operators, and quality inspectors who hold the tribal knowledge. I then work with the change management lead to formally document them in the stakeholder register and advocate for their inclusion as part-time subject matter experts on the project team.
Follow-up 3 curveball. What do you do when the PMO refuses to include floor supervisors in the Discover workshops because they fear it will artificially expand the project scope?
Answer. I present a risk assessment demonstrating the cost of late-stage scope creep. I explain that excluding the floor supervisors does not eliminate the scope, it merely hides it until the realize phase, where fixing process gaps where resolving process gaps becomes significantly more expensive due to redesign, custom development, retesting, and schedule delays in custom ABAP development and timeline delays. I propose a compromise. Include the supervisors in tightly structured, time-boxed pain point validation sessions to capture operational red flags without derailing the agenda.
Governance takeaway for this migration incident 45.
Ignoring physical, floor-level warehouse stakeholders during Discover is a severe governance failure. Always establish a comprehensive stakeholder register, secure business resource allocations, and define clear operational accountability before entering Explore to protect blueprint stability, user adoption, and project funding.
Migration incident 46. Global template assumptions conflict with local warehouse operational requirements across different countries.
During the Discover phase of a global S/4HANA EWM rollout, the central IT organization assumes that a single, highly standardized global template can be deployed uniformly across all regional warehouses. They fail to account for critical local operational constraints, such as differing labor laws, varying material handling automation maturity, regional carrier integrations, and unique customs regulations. Forcing a rigid global template onto physically and legally diverse warehouses guarantees intense local pushback, massive localization debt, and total rollout paralysis. Business objective. Architect a flexible global template strategy during Discover that enforces core structural standardization while defining clear boundaries for necessary local, site-specific operational variations.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this global rollout governance failure across the following strategic boundaries. 1. Complexity. High enterprise rollout strategy and global governance failure. 2. Frequency, extremely common in multinational S/4HANA transformations. 3. Business process, global template design and localization scoping. 4. Business scope, global rollout strategy, core versus local architecture, compliance, and change management. 5. EWM deployment type, not yet decided. 6. Immediate business priority, high. 7. Primary ownership, enterprise architect and global process owner. 8. Business ownership, global supply chain executive and regional operations directors.
Typical global template versus local reality conflicts.
Experienced enterprise architects audit the regional warehouse variations for the following critical localization gaps during the discover phase. 1. Automation maturity divergence. The global template relies on advanced wave picking and ASRS integrations, but a regional site in an emerging market relies entirely on manual paper-based picking. 2. Labor law and union restrictions. Global engineered labor standards and tracking metrics violating strict European Works Council privacy laws. 3. Regional carrier and manifesting integrations. The standard template supports major global parcel carriers, ignoring critical local freight forwarders required in specific regions. 4. Units of measure and packaging conflicts. North American sites operating strictly on imperial weights and proprietary pallet sizes conflicting with European metric standards. 5. Localized customs and bonded zones. Regional warehouses requiring highly specific integration with local government customs portals for duty unpaid stock isolation. 6. Shift structure and handover variances. The global blueprint assuming a standard 3-shift 24/7 operation, breaking when applied to sites with strict noise and weekend operation curfews. 7. Hazardous material regulations. Differing regional fire safety and chemical segregation codes requiring localized EHS and storage type logic. 8. Third-party logistics handoffs. The template assuming all warehouses are internally managed, failing to support a region that heavily utilizes external 3PL operations. 9. Language and UX translation gaps. Missing translations or localized terminology on critical RF mobile screens, paralyzing non-English speaking operators. 10. Regional tax and billing regulations. Localized requirements for printing specific tax identifiers or commercial invoices directly at the shipping dock. Key insight. Standardization reduces IT cost. Localization protects business continuity. A rigid global template that ignores regional physics and laws will be rejected by the local business.
Migration incident analysis and root cause why this happens.
Failing to balance global standardization with local realities typically stems from the following root causes. 1. Corporate IT dictates a zero customization mandate from headquarters without auditing the physical or legal constraints of regional warehouses. 2. Template governance gap. There is no formally defined core versus local decision framework, resulting in endless political battles over what constitutes a valid localization request. 3. Scoping sessions are conducted exclusively with global process owners, silencing regional logistics managers who understand local carrier and compliance realities. 4. Underestimating the complexity of legacy site maturity, assuming a manual warehouse can adopt highly automated S/4HANA EWM processes overnight. 5. Failure to conduct formal regional site readiness assessments before finalizing the global deployment timeline.
Business, program, and operational impact.
Forcing an inflexible global template introduces critical risks across the global rollout landscape. 1. Program impact. Global rollout timelines stall as regional business units actively reject the template during local fit gap workshops, causing massive RICEFW scope explosions. 2. Validation testing. Regional UAT fails completely because standard global test scripts do not reflect necessary local legal, carrier, or automation processes. 3. Warehouse operations. Local site productivity crashes at go live because operators are forced to execute over engineered global processes that do not match their physical layout or manual equipment. 4. Compliance and risk. Operations face severe fines or shutdowns if the global template accidentally strips away localized customs, hazardous material, or labor compliance tracking.
Governance and accountability.
We establish clear governance boundaries to manage the core versus local template scope. 1. Decision owner, global process owner and enterprise architect, jointly accountable for defining the rigid global core and the allowable localization boundaries. 2. Review board, global design authority, responsible for strictly auditing and approving all regional localization requests to prevent template degradation. 3. Business sponsor, global supply chain executive, accountable for resolving political disputes between global standardization goals and regional operational demands. 4. Supporting teams, regional logistics directors, legal and compliance officers, and EWM solution architects.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your rollout template. 1. Core versus local definition. Establish a strict, documented framework defining exactly what EWM processes are globally locked, for example, enterprise structure, master data versus locally flexible, for example, carrier integration, print layouts. 2. Regional site maturity assessments. Conduct site visits to assess physical automation maturity before forcing high-tech processes onto low-tech regional warehouses. 3. Mandate that local legal, labor union, and customs compliance requirements automatically qualify as valid localization exceptions to bypass standard template rejections. 4. Design the global template with extension hooks badges that allow regional sites to plug in local carrier routing without modifying the core S/4HANA ABAP.
EWM, Global Rollout Discovery Deliverables.
A compliant discover phase must exit with the following concrete governance deliverables before starting the blueprint. 1. Core versus local governance charter. A signed architecture document strictly defining the standard global processes and the criteria for approving local deviations. 2. Regional site maturity and readiness matrix. An assessment mapping every target rollout site against its automation level, union constraints, and IT infrastructure readiness. 3. Global template blueprint. The foundational S/4HANA EWM design document capturing all enterprise-mandated configuration standards. 4. Regional compliance and localization register. A catalog capturing mandatory local legal, tax, customs, and carrier integrations required for specific country deployments. Key takeaway: these rollout deliverables are the foundation for a scalable S/4HANA EWM deployment, protecting the program from localized mutiny and endless custom development debt.
Global Rollout Governance Metrics.
We track the following critical indicators to manage template degradation risks during the early project phases. 1. Global template adoption rate. The target percentage of EWM warehouse processes running uniformly across all deployed sites without local deviation. 2. Localization RICEFW volume. A metric tracking the total number of custom enhancements approved to support necessary regional or legal requirements. 3. Regional site readiness score. A quantitative metric assessing the physical, technical, and organizational readiness of a local site to receive the global template. 4. Design authority rejection rate. The percentage of unauthorized local customization requests successfully blocked by the Global Governance Board to preserve the core. Key takeaway: quantifying rollout metrics during discover is how senior architects protect the global template from death by 1,000 local cuts.
Follow-up 1. What is a global template in an S/4HANA EWM rollout, and why does overstandardization create project risks?
Answer: a global template is a standardized, pre-configured baseline of EWM processes designed to be deployed uniformly across multiple warehouses to reduce maintenance costs. However, overstandardization occurs when headquarters forces this template onto regional sites without considering local physical realities, such as different automation levels, union labor laws, or regional carriers. This approach breaks down during local rollouts, causing massive user resistance and operational gridlock because the software does not match the local physics of the warehouse.
Follow-up 2. How do you balance the need for global IT standardization with the reality of local warehouse requirements during the discover phase?
Answer: I mandate the creation of a core versus local governance charter. We lock down the core architecture, such as the EWM enterprise structure, master data formats, and standard inbound and outbound process types. However, we explicitly allow flexibility at the execution edges, such as localized print forms, specific regional carrier API integrations, and RF screen translations. We validate this balance by conducting early site maturity assessments to ensure the template fits the physical constraints of regional nodes.
Follow-up 3 curveball. What do you do when a regional warehouse manager demands a massive custom enhancement to the global template, arguing that this is how we have always done it locally?
Answer: I do not argue the point conceptually. I escalate the request to the Global Design Authority for a strict objective review. I ask the local manager to provide hard evidence that their legacy process is required by local law, strict union mandates, or unique local automation constraints. If it is merely a preference, the design authority rejects the enhancement, enforcing the global standard. If it is a legitimate legal or physical constraint, we approve it as a localized extension using standard S/4HANA extensibility tools, protecting the clean global core.
Governance takeaway for this migration incident 46.
Ignoring regional operational, legal, and physical constraints during global template design is a severe governance failure. Always establish a strict core versus local governance charter and evaluate regional site maturity before entering Explore to protect global standardization while respecting localized business continuity.
Category 9. Governance and Project Readiness Conclusion.
To summarize Category 9, the most technically perfect S/4HANA EWM architecture will fail if the human element is ignored. Engaging floor-level shift supervisors early and balancing global IT standardization against regional physical constraints is mandatory. If you fail to manage operational stakeholder governance and global template flexibility during the discover phase, you guarantee massive scope creep, localized mutiny, and catastrophic testing failures during later phases.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from human governance to digital security.
With our business stakeholders mapped and our global template boundaries defined, we must now address who is actually allowed to log into the system. A brilliantly designed warehouse process is useless if the operator is locked out of their scanner on day 1. We will now transition into our final Discover phase category. Category 10. Identity, Security, and Access Management Discovery, where we analyze the severe risks of unmapped authentication protocols, obsolete authorization roles, and unsecured automation networks.
Category 10. Identity, Security, and Access Management Discovery.
In S4 HANA EWM, security architecture is vastly different from legacy warehouse systems. The shift to web-based Fiori applications, browser-based mobile scanners, and internet-connected automation equipment introduces strict modern cybersecurity requirements. Category 10 deep dives into the critical risks of ignoring enterprise identity providers, assuming legacy custom roles can be reused, and failing to secure vulnerable operational technology networks during the Discover phase.
Identity, Security, and Access Management Incidents, 47 to 49.
To prevent day 1 user lockouts and severe cybersecurity vulnerabilities, a thorough Discover phase must audit these critical security domains. Incident 47. Enterprise identity provider and single sign-on integration requirements are not identified during discovery. Incident 48. Existing warehouse authorization model contains thousands of custom roles that cannot be directly reused in S4 HANA. Incident 49. Operational technology security requirements for warehouse automation networks are not assessed during discovery. Let's dive into Incident 47.
Migration Incident 47. Enterprise identity provider and single sign-on integration requirements are not identified during discovery.
During the Discover phase, the project team fails to identify the stringent integration requirements for enterprise identity providers, such as Azure Active Directory and single sign-on authentication. In legacy systems, warehouse operators typically logged into character-based screens using basic system passwords. In S4 HANA EWM, the user experience shifts to web-based Fiori applications and browser-based RF scanners, which must adhere to modern corporate cybersecurity mandates. Ignoring identity and authentication mapping early in the project results in severe login latency, massive password reset backlogs, and total operator lockouts on the warehouse floor during go-live. Business objective: identify, map, and architect the integration between S4 HANA EWM and the corporate identity provider early to ensure secure, seamless, and high-speed single sign-on for all warehouse devices.
Incident classification and relevant SAP, note if applicable.
To establish clear parameters, we classify this cybersecurity and authentication discovery failure across the following strategic boundaries. 1. Complexity. High enterprise security architecture and identity integration failure. 2. Frequency. Very common in modern S/4HANA cloud and on-premise conversions. 3. Business process. Identity and access management discovery. 4. Business scope. Enterprise single sign-on authentication protocols. Identity providers and mobile security. 5. EWM deployment type. Not yet decided. 6. Immediate business priority. High. 7. Primary ownership. Enterprise security architect and identity access management lead. 8. Business ownership. Chief Information Security Officer and IT Infrastructure Director.
Typical identity and authentication gaps.
Experienced security architects audit the legacy authentication behaviors and device profiles for the following critical identity gaps during the discover phase. 1. Legacy basic authentication dependencies. Warehouse operators accustomed to typing simple passwords directly into SAP GUI, which violates modern zero-trust security mandates. 2. Shared RF scanner logins. Legacy environments where multiple shift workers share a single generic login ID, destroying individual audit traceability and security compliance. 3. SAML certificate and token omissions. Failing to map out the technical certificate exchange and token lifetimes required between S/4HANA and Azure Active Directory. 4. Session timeout mismatches. Corporate security policies enforcing a strict 15-minute inactivity timeout, which forces forklift drivers to constantly re-authenticate mid-shift. 5. Multi-factor authentication friction. Security teams forcing warehouse operators to use smartphone authenticator apps on the floor, slowing down physical logistics. 6. Service account authentication blocks. Automated systems, such as label printers and check weighers, failing to connect because they lack secure system-to-system integration tokens. 7. Third-party logistics portal access. Missing federated identity strategies for external vendors and carriers logging into the EWM Fiori launchpad from outside the corporate firewall. 8. Barcode login incompatibilities. Legacy scanners designed to scan barcodes for user credentials, failing to interact with modern browser-based single sign-on redirect pages. 9. Browser cache and cookie clearing. Shared mobile devices failing to properly clear session cookies between shift handovers, allowing the next worker to accidentally operate under the previous worker's ID. 10. Active Directory role mapping failures. Unmapped linkages between corporate Active Directory groups and EWM warehouse-specific security roles.
Migration incident analysis and root cause why this happens.
Failing to scope identity and authentication requirements typically stems from the following root causes. 1. IT teams assume warehouse authentication is identical to back-office accounting, completely ignoring the physical constraints of ruggedized, keyboard-less scanners. 2. Security governance gap. Enterprise identity and zero-trust security policies are established in a corporate vacuum without assessing the high-speed operational realities of warehouse execution. 3. Failing to conduct device-level proof of concepts connecting legacy barcode scanners to modern single sign-on redirect portals. 4. Underestimating the architectural effort required to map Active Directory group attributes to S/4HANA Fiori catalogs and EWM business roles. 5. Excluding Chief Information Security Officers and Identity Access Management leads from early warehouse scoping workshops.
Business, program, and operational impact.
Ignoring identity and authentication constraints introduces critical risks across the project landscape. 1. Program impact. Project testing milestones are severely delayed because security architectures must be re-engineered mid-flight to accommodate mobile devices that cannot process corporate multi-factor authentication. 2. Validation testing. User acceptance testing collapses on day 1 because shift workers cannot physically log into the handheld scanners, logging hundreds of invalid password lockouts instead of executing warehouse tasks. 3. Warehouse operations. Operator frustration spikes as complex authentication workflows force them to spend 10 minutes logging into a device before they can pick a single box. 4. Operational compliance. The business faces severe audit and compliance violations if they resort to sharing generic user IDs to bypass broken identity integrations.
Governance and accountability.
We establish clear governance boundaries to manage the identity and authentication scope. 1. Decision owner. Enterprise security architect and identity access management lead, jointly accountable for verifying the single sign-on and authentication architectures. 2. Review board. Corporate security and risk committee, responsible for auditing proposed authentication flows against enterprise zero trust mandates. 3. Business sponsor. Chief information security officer and logistics director, accountable for balancing strict cybersecurity compliance with physical warehouse productivity. 4. Supporting teams. Network infrastructure lead, EWM solution architect, and mobile device management administrator.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your identity boundaries. 1. Authentication proof of concept. Execute a live test connecting the oldest active warehouse scanner to the corporate identity provider to ensure it can successfully process the redirect tokens. 2. Session lifecycle assessment. Map out the exact shift duration, break times, and device handover procedures to establish realistic session timeout configurations for mobile devices. 3. Design a formal authentication architecture separating human interactive logins via single sign-on from automated system to system connections requiring security certificates. 4. Involve enterprise security architects directly in warehouse floor walkthroughs to witness the physical limitations of typing complex passwords on rugged equipment.
EWM identity and security discovery deliverables.
A compliant discover phase must exit with the following concrete architectural deliverables before starting the blueprint. 1. Enterprise identity and single sign-on blueprint. A comprehensive technical document defining the SAML integration, identity provider routing, and token lifecycles for S/4HANA. 2. Warehouse mobile authentication strategy. A validated design document detailing exactly how operators will log into RF devices, handling session persistence and shift handovers. 3. System integration authentication register. A catalog mapping all automated material flow systems, print servers, and middleware platforms to their required secure connection protocols. 4. Cybersecurity exception and risk log. A formal registry documenting any required deviations from corporate security policies, such as extended mobile session timeouts. Key takeaway. These security deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from day one authentication failures, operational disruption, and cybersecurity compliance risks.
Identity and access readiness metrics.
We track the following critical indicators to manage security and authentication risks during the early project phases. 1. Single sign-on coverage rate. The target percentage of warehouse users, including third-party contractors, mapped to the centralized enterprise identity provider. 2. Mobile authentication speed baseline. The maximum acceptable time in seconds for a mobile scanner to process a login redirect and load the initial EWM menu. 3. Service account conversion index. The total count of legacy generic accounts successfully migrated to modern certificate-based integrations. 4. Security policy exception rate. The percentage of corporate security mandates requiring formal business exceptions to allow viable warehouse operations. Key takeaway. Quantifying identity readiness metrics during discover is how senior architects prevent massive post-go-live help desk escalations.
Follow-up 1. What is single sign-on via SAML in S/4HANA EWM, and why does ignoring it during discover cause operational failure?
Answer. Single sign-on, operating via SAML protocols, allows a user to authenticate once with a central corporate identity provider, like Azure Active Directory, and seamlessly access S/4HANA EWM without re-entering passwords. If you ignore this integration during discover, operators will be forced to repeatedly type complex, rotating corporate passwords manually into rugged scanners with no physical keyboards. This process is highly error-prone, causing massive user lockouts and severely delaying the start of every working shift.
Follow-up 2. How do you identify legacy, warehouse authentication habits, and security complexities during the discover phase?
Answer: I do not rely on standard IT security policy documents. I perform physical operational floor walks during a shift handover. I observe exactly how an operator logs out, how the device is sanitized or handed to the next user, and how quickly the next operator must begin scanning. I audit active login logs to detect the use of generic, shared credentials, and I review the legacy Active Directory mapping to ensure contractor access is tightly controlled.
Follow-up 3 curveball. What do you do when the Chief Information Security Officer mandates a 15-minute inactivity timeout and a smartphone-based multi-factor authentication prompt for every warehouse scanner to comply with global zero trust standards?
Answer: I do not argue against zero trust security conceptually. Instead, I present a warehouse process impact simulation. I explain that forklift operators wear heavy protective gloves and are not permitted to carry personal smartphones on active industrial floors for safety reasons. Forcing a 15-minute timeout means the session drops while they are driving between aisles. I propose an enterprise-approved compromise. We isolate the warehouse scanner subnet securely behind a dedicated firewall, extend the token lifecycle for the duration of a standard shift. Any deviation from the enterprise security baseline is documented as a formally approved security exception, with compensating controls and periodic review, and utilize specialized badge scan logins to satisfy authentication without crippling warehouse output.
Governance takeaway for this migration incident 47.
Ignoring enterprise identity providers, authentication constraints, and corporate security mandates during discover is a severe governance failure. Always establish standardized single sign-on architectures, secure automation connections, and realistic mobile session policies before entering Explore to protect warehouse accessibility, cybersecurity compliance, and operator productivity.
Migration incident 48. Existing warehouse authorization model contains thousands of custom roles that cannot be directly reused in S/4HANA.
During the discover phase, the project team assumes that the existing warehouse security model, comprising thousands of custom legacy roles, can simply be lifted and shifted into the new system. In legacy environments, security was built around transaction codes. S/4HANA EWM shifts the user experience to the Fiori Launchpad, which relies on a completely different architecture utilizing business roles, business catalogs, and front-end OData services. Attempting to migrate legacy custom roles without redesigning them for the modern Fiori architecture results in empty launchpads, severe OData authorization failures, and a complete paralysis of user testing. Business objective: perform a comprehensive audit of the legacy authorization model early in the discover phase to establish a role redesign strategy that aligns with S/4HANA Fiori catalogs and strict segregation of duties.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this security architecture discovery failure across the following strategic boundaries. 1. Complexity: high enterprise security architecture and user access failure. 2. Frequency: extremely common in highly customized legacy systems. 3. Business process: identity, security, and authorization design. 4. Business scope: enterprise role design, Fiori catalog mapping, OData security, and segregation of duties. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise security architect and authorization lead. 8. Business ownership: Chief Information Security Officer and Warehouse Operations Director.
Typical legacy authorization gaps.
Experienced security architects audit the legacy authorization repository for the following critical compliance and architectural gaps during the discover phase. 1. Massive custom role proliferation: thousands of redundant Z roles created over decades to bypass localized security errors, creating an unmanageable administrative footprint. 2. Missing Fiori catalog authorizations: Legacy roles containing only back-end transaction codes, entirely missing the front-end catalog and group assignments required to render Fiori tiles. 3. OData service blocks. Legacy roles lacking the required authorization proposals to execute the underlying OData web services that populate modern graphical screens. 4. Severe segregation of duties violations. Over-provisioned legacy roles granting conflicting permissions, such as allowing a single user to both count inventory and post write-offs. 5. Hard-coded authorization objects in custom code. Legacy custom ABAP programs containing hard-coded authority checks that conflict with standard S/4HANA security models. 6. Organizational level overrides. Roles built with broad wildcard access across all plants and warehouse numbers instead of being restricted to localized operational boundaries. 7. Unmapped mobile user profiles. Legacy RF terminal roles failing to translate into the new mobile presentation profiles required for modern industrial browsers. 8. Obsolete transaction code assignments. Legacy roles containing hundreds of deprecated transaction codes that no longer exist or have been replaced in the S/4HANA simplification catalog. 9. Unowned legacy system accounts. Broad superuser access granted to generic system or interface accounts without active security ownership. 10. Bypassed SU-24 proposals. Custom roles built manually in PFCG without utilizing standard authorization proposals, making future system upgrades extremely difficult to manage.
Migration incident analysis and root cause why this happens.
Failing to scope the authorization redesign typically stems from the following root causes. 1. IT teams assume security migration is a purely technical lift and shift exercise, completely ignoring the architectural shift to Fiori and OData. 2. Security governance gap. Enterprise standards for persona-based role design, segregation of duties, and Fiori catalog administration are not centrally established before the migration begins. 3. A failure to execute historical security trace logs to determine which legacy roles are actually utilized versus abandoned. 4. Underestimating the functional consulting effort required to map warehouse physical tasks to modern S/4HANA business catalogs. 5. Excluding enterprise security architects and compliance auditors from early warehouse process scoping workshops.
Business, program, and operational impact.
Migrating undocumented and obsolete authorization models introduces critical risks across the project landscape. 1. Program impact. Immediate project stalls during the realize phase as security teams are forced to manually rebuild thousands of roles from scratch to support the Fiori launchpad, triggering massive timeline delays. 2. Validation testing. User acceptance testing collapses entirely because warehouse operators log into the system and are met with blank screens, missing tiles, or fatal HTTP authorization errors, preventing the execution of test scripts. 3. Warehouse operations. Supervisors and operators face continuous workflow interruptions at go live as missing organizational-level authorizations prevent them from confirming urgent warehouse tasks. 4. Operational compliance affected. The organization fails pre-go-live security audits due to massive, unmitigated segregation of duties violations inherited from the legacy system.
Governance and accountability.
We establish clear governance boundaries to manage the enterprise security and authorization scope. 1. Decision owner, enterprise security architect and authorization lead, jointly accountable for designing the S/4HANA persona-based security model and Fiori catalogs. 2. Review board, corporate security and risk committee, responsible for auditing the proposed role designs against internal segregation of duties mandates. 3. Business sponsor, chief information security officer and warehouse operations director, accountable for enforcing strict access policies while ensuring physical operational efficiency. 4. Supporting teams, Fiori infrastructure lead, EWM solution architect, and internal audit team.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your authorization boundaries. 1. Security usage analysis. Activate security trace logs in the legacy production system to empirically determine which custom Z roles are actively utilized versus obsolete. 2. Shift from a transaction-based security mindset to a persona-based security model, mapping day-in-the-life activities to specific warehouse job functions. 3. Conduct structured workshops with warehouse supervisors to define strict segregation of duties boundaries, particularly around physical inventory counting and adjustments. 4. Formally evaluate legacy custom developments to identify and remove hard-coded authorization checks before attempting to map them to the new Fiori architecture.
EWM security and authorization deliverables.
A compliant discover phase must exit with the following concrete architectural deliverables before starting the blueprint. 1. Legacy role decommissioning plan. A comprehensive technical inventory identifying all obsolete, redundant, or over-provisioned legacy roles targeted for retirement. 2. Persona-based authorization concept. A strategic design document mapping warehouse job functions to S/4HANA business roles and target Fiori catalogs. 3. Segregation of duties risk matrix. A validated compliance document outlining conflicting warehouse activities and the mitigating controls required in the target system. 4. Fiori and OData Security Architecture Blueprint. A technical specification detailing how front-end catalog access and back-end OData service authorizations will be systematically aligned. Key takeaway: these security deliverables are the foundation for a secure S/4HANA EWM blueprint, protecting the project from authorization failures, testing disruption, and post-go-live security audit findings.
Security complexity and standardization metrics.
We track the following critical indicators to manage authorization and compliance risks during the early project phases. 1. Custom role decommissioning rate. The target percentage of legacy custom roles successfully retired and consolidated into standard persona-based models. 2. Standard Fiori Catalog Adoption Index. A metric measuring the percentage of warehouse processes mapped to out-of-the-box standard SAP business catalogs. 3. Segregation of duties conflict resolution rate. The percentage of identified security conflicts successfully mitigated through role redesign before integration testing begins. 4. Security defect resolution speed. The estimated time required to troubleshoot and resolve missing OData or backend authorizations during testing cycles. Key takeaway: quantifying security complexity metrics during discover is how senior architects protect the program from testing paralysis.
Follow-up 1. What is the architectural difference between a legacy SAP role and a S/4HANA Fiori business role, and why does lifting and shifting them fail?
Answer: legacy roles are strictly back-end focused, granting access to specific transaction codes and authorization objects via transaction PFCG. In S/4HANA, the Fiori Launchpad introduces a decoupled architecture. A user needs a front-end business role and catalog to physically see the tile on their screen, and back-end authorization to execute the OData service pulling the data. Lifting and shifting: a legacy role only provides back-end access, meaning the user will log into Fiori and see a completely blank screen.
Follow-up 2. How do you identify which legacy custom warehouse roles should be decommissioned versus redesigned during the discover phase?
Answer: I do not rely on static security documentation. I collaborate with the basis team to activate security trace logs and analyze historical usage data in the production system. If a custom Z role has not been utilized by any active user in an agreed historical analysis period defined by the organization's security governance policy, it is flagged for immediate decommissioning. For actively used roles, we analyze the execution profile to map those legacy transactions into the new persona-based Fiori catalogs.
Follow-up 3 curveball. What do you do when a warehouse supervisor insists on retaining their legacy superuser access in S/4HANA because they claim they need to do everything to keep the shift running?
Answer: I do not argue the point conceptually. Instead, I present a segregation of duties risk assessment to the business sponsor and the internal audit team. I explain that granting unconstrained superuser access violates modern compliance standards, allowing a single user to both receive inventory and perform financial write-offs. I propose a compromise. We design a robust, specialized exception handling Fiori role for the supervisor while removing conflicting financial actions. If they still resist, the risk is formally escalated to the Chief Information Security Officer for official sign-off.
Governance takeaway for this migration incident 48.
Ignoring the architectural shift from legacy transaction codes to S/4HANA Fiori catalogs during Discover is a severe governance failure. Always establish a persona-based security strategy, strict segregation of duties matrices, and a comprehensive role retirement plan before entering Explore to protect user testing, system security, and audit compliance.
Migration incident 49. Operational technology security requirements for warehouse automation networks are not assessed during discovery.
During the Discover phase, the project team fails to assess the strict cybersecurity requirements of the warehouse operational technology network. Modern S/4HANA EWM material flow systems require direct, real-time socket connections to programmable logic controllers on the warehouse floor. Historically, these automation networks were air-gapped and run on obsolete, unpatched hardware. Opening a direct bridge between the corporate IT network and the warehouse OT network without proper segmentation exposes the facility to crippling ransomware attacks, or conversely, paralyzes the automation equipment if IT enforces aggressive, high-latency firewalls. Business objective: conduct a rigorous operational technology security assessment early in the Discover phase to design a resilient, low-latency, and segmented integration architecture between S/4HANA EWM and physical warehouse automation.
Incident classification and relevant SAP note if applicable.
To establish clear parameters, we classify this cybersecurity discovery failure across the following strategic boundaries. 1. Complexity: high enterprise cybersecurity and OT integration failure. 2. Frequency: extremely common in automated warehouse migrations. 3. Business process: operational technology security and automation connectivity. 4. Business scope: OT network segmentation, industrial cybersecurity, MFS socket routing and ransomware protection. 5. EWM deployment type: not yet decided. 6. Immediate business priority: high. 7. Primary ownership: enterprise security architect and OT network engineer. 8. Business ownership: Chief Information Security Officer and Warehouse Automation Director.
Typical warehouse OT security gaps.
Experienced security architects audit the legacy automation landscape for the following critical industrial vulnerabilities during the Discover phase. 1. Flat network topologies: warehouse automation running on a single, unsegmented network, allowing a breach in the corporate office to immediately spread to the conveyor controllers. 2. Obsolete automation operating systems: third-party warehouse control systems running on deprecated, unsupported legacy server operating systems with known vulnerabilities. 3. Unencrypted socket traffic: MFS telegrams passing across the network in plain text, exposing critical operational commands to packet sniffing and manipulation. 4. Aggressive deep packet inspection: corporate firewalls configured to deeply inspect every packet, adding fatal latency to sub-second MFS telegram handshakes. 5. Unmanaged vendor remote access: external automation vendors maintaining permanent, unmonitored backdoor access connections directly to the warehouse PLCs. 6. Hard-coded default passwords: industrial scanners, weighing scales, and PLCs operating on factory default passwords that have never been rotated. 7. Missing OT patch management: a complete lack of patching procedures for automation hardware due to fear of breaking fragile legacy systems. 8. Destructive vulnerability scanning: standard corporate IT security scanners inadvertently crashing fragile PLCs by flooding their outdated network ports with diagnostic pings. 9. Exposed wireless automation: automated guided vehicles communicating over unencrypted, unhidden wireless networks vulnerable to external disruption. 10. Lack of OT incident response plans: security teams having no documented procedure for isolating the physical warehouse floor during an active cyber attack.
Migration incident analysis and root cause why this happens.
Failing to scope OT security constraints typically stems from the following root causes. 1. Corporate IT security teams lack industrial engineering domain expertise and attempt to force standard corporate office policies onto sensitive, real-time automation equipment. 2. Security governance gap. A severe disconnect between the Chief Information Security Officer and warehouse engineering teams leads to undefined network boundaries between IT and OT systems. 3. Automation vendors demand unrestricted, any-to-any network access to guarantee equipment performance, aggressively pushing back against IT firewall rules. 4. Security assessments focus entirely on the cloud-hosted S/4HANA database, completely ignoring the physical vulnerability of the warehouse edge. 5. An inaccurate assumption that the warehouse automation network is physically air-gapped, when in reality IT is actively bridged to the new EWM system.
Business, program, and operational impact.
Ignoring the clash between IT security protocols and warehouse performance introduces critical risks. 1. Program impact. Go-live schedules are delayed because the security architecture must be completely redesigned late in the project after automated integration testing fails. 2. Validation testing. MFS load testing collapses because corporate firewalls interpret high-speed, repetitive PLC telegrams as a denial-of-service attack and automatically drop the connections. 3. Warehouse operations. Conveyors and cranes mysteriously stall during live operations due to security-induced micro-latency, creating massive physical gridlock on the floor. 4. Cybersecurity risk. A localized ransomware infection easily pivots from a compromised office laptop directly into the unsegmented OT network, permanently bricking the physical warehouse.
Governance and accountability.
We establish clear governance boundaries to manage the IT and OT integration scope. 1. Decision owner, enterprise security architect and OT network engineer, jointly accountable for designing a low-latency, segmented industrial network architecture. 2. Review board, corporate security and risk committee, responsible for auditing the proposed boundary between corporate systems and physical automation. 3. Business sponsor, chief information security officer and logistics director, accountable for balancing strict ransomware protection with physical warehouse productivity. 4. Supporting teams. EWM MFS solution architect, network infrastructure lead, and third-party automation vendors.
Real implementation tips and best practices.
Apply the following strategic guidelines during the discover phase to secure your automation boundaries. 1. Purdue model adoption. Implement the Purdue Enterprise Reference Architecture to physically and logically segment the corporate IT network from the warehouse OT network. 2. Industrial Demilitarized Zone. Design a dedicated DMZ layer where S/4HANA EWM can securely exchange data with warehouse control systems without opening direct paths to the PLCs. 3. Firewall latency testing. Rigorously test proposed firewall hardware to guarantee sub-millisecond throughput for critical MFS telegrams. 4. Vendor access audits. Mandate zero-trust remote access solutions for external automation vendors, terminating their connections inside the DMZ rather than directly on the factory floor.
EWM, OT security discovery deliverables.
A compliant discover phase must exit with the following concrete architectural deliverables before starting the blueprint. 1. OT Security Risk Assessment Report. A comprehensive technical vulnerability scan mapping legacy automation hardware against known security exploits and legacy operating systems. 2. EWM to Automation Topology Blueprint. A validated network diagram defining the exact segmentation layers aligned with the Purdue model for industrial security. 3. Industrial Firewall and Socket Routing Specification. A detailed configuration document outlining the specific ports, protocols, and latency thresholds required for MFS traffic. 4. OT Vendor Remote Access Governance Plan. A formal policy document dictating how third-party engineers will securely authenticate to maintain physical equipment. Key takeaway. These cybersecurity deliverables are the foundation for the S/4HANA EWM blueprint, protecting the project from devastating cyber-physical attacks and self-inflicted network paralysis.
OT security and resilience metrics.
We track the following critical indicators to manage industrial cybersecurity risks during the early project phases. 1. OT network segmentation compliance rate. The target percentage of warehouse automation assets isolated behind an approved industrial demilitarized zone. 2. MFS socket firewall latency baseline. The maximum allowable processing delay introduced by packet inspection on critical automation telegrams. 3. Legacy automation vulnerability index, a metric tracking the total volume of unpatchable, end-of-life operating systems actively controlling physical warehouse equipment. 4. Vendor access zero trust adoption rate, the percentage of external automation partners migrated to secure, audited, and time-bound remote access gateways. Key takeaway: quantifying OT security metrics during Discover is how senior architects protect the program from physical facility breaches.
Follow-up 1. What is the difference between IT and OT security, and why does S/4HANA EWM MFS blur the line between them?
Answer: IT security prioritizes data confidentiality, while OT security prioritizes physical safety and continuous availability. A delayed email is an annoyance. A delayed OT signal can cause conveyor stoppages, automation timeouts, synchronization failures, or emergency safety responses. S/4HANA EWM MFS blurs this line by establishing direct TCP or IP socket connections from the corporate IT core directly into the warehouse PLCs. If IT forces aggressive encryption or deep packet inspection that slows down the packet, the automation equipment will time out and halt.
Follow-up 2. How do you identify OT security vulnerabilities during Discover without disrupting the active warehouse?
Answer: I do not run active IT vulnerability scanners against the warehouse network. Standard network sweeps often knock over fragile legacy PLCs, physically halting operations. Instead, I use passive network traffic analysis to map data flows, review existing architecture diagrams against the Purdue model for industrial segmentation, and perform physical audits of vendor remote access connections.
Follow-up 3 curveball. What do you do when the corporate security team demands deep packet inspection on all MFS traffic, but your load tests show it introduces unacceptable latency to the PLCs?
Answer: I escalate the conflict via an operational risk matrix. I propose a standard industrial compromise. We establish a highly restricted, allow-listed network path inside an industrial demilitarized zone. We bypass deep packet inspection exclusively for known, verified MFS telegrams traveling to the PLCs, while enforcing strict zero-trust controls on the perimeter. I demonstrate that this satisfies the security team's requirement to isolate the network without destroying the physical throughput of the warehouse.
Governance takeaway for this migration incident 49.
Ignoring operational technology security exposes the physical warehouse to devastating cyber attacks and network-induced operational paralysis. Always establish strict OT segmentation, latency-aware firewalls, and vendor access governance before entering Explore to protect warehouse operations, physical assets, and business continuity.
Category 10. Identity, Security and Access Management Conclusion.
To summarize Category 10, modern warehouse security is no longer just about legacy transaction codes and basic passwords. Transitioning to S/4HANA EWM introduces strict requirements for enterprise identity providers, persona-based Fiori roles, and heavily segmented operational technology networks. Failing to architect these precise security boundaries during the Discover phase guarantees widespread user lockouts, severe compliance audit violations, and critical vulnerabilities on the physical warehouse floor.
Part 1. Discover Phase Conclusion.
This brings us to the conclusion of Part 1 and the complete Discover phase. Across these 49 incidents across 10 strategic categories, we have proven that S/4HANA migration failures are rarely born during the technical cutover. They are created at the very beginning, when project teams underestimate the physical, technical, and organizational complexities of their legacy landscapes. By rigorously auditing your master data, custom code, automation dependencies, and infrastructure early, you protect the entire program blueprint from catastrophic late-stage redesigns.
Continue the masterclass journey.
Our journey through this 1,000-plus incident masterclass has only just begun. In our next installment, we transition into the prepare phase, where project mobilization, technical environments, and system conversion readiness are put to the ultimate test. Please check the links in the video description below to access Part 2 and the remaining phases of this comprehensive S/4HANA EWM migration series. Subscribe to the channel to ensure you do not miss the rest of this ultimate enterprise playbook.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks and more importantly, For valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.